mass and are free from contamination. With optimized line operation using comprehensive inspection and operation data. In environmental measurement. Along with camera monitoring, values from on-site sensors are converted to IP for integrated data management at control centers. Our high-performance devices are used widely by manufacturers of communications, industrial and medical equipment. And now, Anritsu is advancing into new areas for a future beyond testing, to create a sustainable society. By creating synergies with new partners, seeking infinite potentialities for communications and exceeding conventional wisdom and limits. Beyond testing for a sustainable future. Advancing beyond. Anritsu.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation No. 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology, Indonesia. Through the 3 directions, science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Nanoelektronika dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and JET is indexed by internationally renowned indexers such as DOAJ, Google Scholar, Mendeley, and etc. JET is also ranked as Center 2 in Kemendristek Green accreditation system. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge, and therefore, no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
Recording in progress.
Welcome to the 2023 International Conference on Radar, Antenna, Microwave, Electronic and Telecommunications, or ICRAMET 2023. I am Ardita Septiani, the host for this occasion. The theme of this year's conference is Empowering Global Progress, Innovative Electronic and Telecommunication Solutions for a Sustainable Future. The ICRAMET 2023 lasts for 2 days, covering 4 keynote talks, 1 patron talk, also paper presentations. We have accepted for publishing 82 studies that will be delivered as oral presentations from 7 conference tracks: remote sensing and radar system, antenna devices and techniques, RF and microwave theory and devices, electronic materials, devices, components and circuits, wireless and wired communications, signal and image processing techniques, control system, robotics, and mechatronics. In this conference, you will have the opportunity to learn from the experts, share your ideas and experiences, network with your peers and potential collaborators, and showcase your research outcomes. I hope you will enjoy this conference and find it valuable for your professional development. I also hope that this conference will inspire you to continue your research endeavors and contribute to the advancements of science and technology. It is my pleasure to introduce to you all our very special guest of honors, Dr. Laksana Trihandoko is the head of Indonesia's National Research and Innovation Agency, or in Indonesian Badan Riset dan Inovasi Nasional, or BRAIN. Also with us from Indonesia's National Research and Innovation Agency, Head of Research Organization for Electronics and Informatics, Dr. Budi Prawara, Head of Research Center for Electronics, Dr. Yusuf Nurwijayanto, Head of Research Center for Electronics, Dr. Yusuf Nurwijayanto, Head of Research Center for Telecommunication, Dr. Nasrullah Armi, Head of Research Center for Computing, Dr. Rifki Sadiki, Head of Research Center for Smart Mechatronics, Dr. Yanwandri Putrasari. Head of Research Center for Data and Information Sciences, Dr. Esa Prakasa. Head of Research Center for Artificial Intelligence and Cyber Security, Dr. Anto Satrio Nugroho. Also from our technical co-sponsor, Professor Linawati, the Secretary of IEEE Indonesia section. Also with us, our keynote speakers, Associate Professor Asrul Izam Asmi from University Technology Malaysia or UTM Malaysia, Professor Iyad Dayu from Université Polytechnique Hauts-de-France from France, Professor Ken Shuseto from Kumamoto University, Japan, Professor Josaphat Tetuko Sri Sumantio from Chiba University, Japan, and Universitas 11 Maret or UNS Indonesia. We also welcome our esteemed patrons, Mr. Liu Funyan, Ms. Alice Christiana Tirta, and Mr. Gumbira Setiawan from Anritsu Pte Ltd, Singapore and Unitronic Jaya, Mr. Enjang Ruhiat from PT Serviam Abadi Murni, Mr. Masyuri Wahab from PT Radar Telecommunication Indonesia, Mr. Ivan Petty from PT Mitra Sistematika Global, Mr. Pandiga Haryanto from PT Dynatech, Ms. Dewi Kartini from CV Nugarada Abadi, Mr. Dadan Ramdan and Mr. Chandra Dwi Perkasa from PT Nusantara Turbin dan Propulsi, also representatives from PT Ramitra Perkasa. As well, I would like to welcome presenters and participants. Before commencing our opening ceremony, I would like to provide you with the speakers we have this morning. First, we will hear an opening remark from Dr. Yuliar Firdaus as the chair of ICRAMET 2023, followed by a remark from the representative of our co-technical sponsor, Professor Linawati, as the secretary of IEEE Indonesia section. Also, a remark from Dr. Budi Prawara, head of research organization for Electronics and Informatics of BRIN. Also, Dr. Laksana Trihandoko, of the head of National Research and Innovation Agency for Indonesia, or BRIN, for officially opening the 2023 International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunications. Before we proceed to our first agenda, let us hear Indonesia's national anthem, Indonesia Raya, to pay homage to all soldiers and civilians who fought for Indonesian independence. Now, we are hearing the first remark from the chair of the 2023 Conference on Radar, Antenna, Microwave, Electronics, and Telecommunications. Please welcome Dr. Yuliar Firdaus.
Thank you, Ms. MC, Ms. Alita. Good morning. Assalamualaikum warahmatullahi wabarakatuh. Honorable Chairman of National Research and Innovation Agency, or BRIN, Dr. Laksana Trihandoko, Chairman of Research Organization for Electronics and Informatics of BRIN, Dr. Eng Budi Prawara, Head of Research Center for Electronics, Yusuf Nur Wijayanto, PhD, and Head of Research Center for Telecommunication, Dr. Nasrullah Armi. Also distinguished keynote speakers, distinguished experts and speakers, participants, ladies and gentlemen. My name is Yulia Firdaus, and I am currently chair of the 12th International Conference on Radar, Antenna, Microwave, and Telecommunication, ICRAMET 2023. First of all, on behalf of the organizing committee, I am delighted to welcome you to the ICRAMET 2023. The conference will be held virtually for 2 days. This year, the conference is hosted by the Research Center for Electronics BRIN and technically co-sponsored by the IEEE Indonesia section. The theme of the ICRAMET 2023 is Empowering Global Progress, Innovative Electronic and Telecommunication Solutions for a Sustainable Future. The conference aims to bring together academia, students, and practitioners interested in the advanced technologies of communication and electronics, including remote sensing and radar systems, antenna device and techniques, radio frequency and microwave theory and device, electronics materials, device and component circuits, wireless and wired communication, signal and image processing techniques, and also mechatronics and related topics. These emerging technologies hold promise for fostering sustainability in the future, including eco-friendly innovations such as green radar systems, energy harvesting antennas, biodegradable electronics, and 5G for smart grids. This year, we invited 4 distinguished keynote speakers to outline recent issues regarding electronics and telecommunication for a sustainable future. In addition, we will have also one patron session from a telecommunication and electronics company, Andritsu from Singapore. We express our sincere gratitude to the keynote speakers and the patron speaker who could manage their time and have kindly agreed to deliver highly stimulating discussion. The ICRAMET 2023 received 152 submission papers in total, and the papers were following a single blind reviewing process by experts and researchers from different countries. The acceptance ratio is 60%, and 82 distinguished papers covered in 7 conference tracks were selected to be presented and published in this conference. The participants of the conference come from Asia, Middle East, Africa, Latin America, and Europe, coming from various professions, from students, academia, and government institutions. Finally, we thank all the organizing committee members who worked tirelessly to prepare this conference, the IEEE Indonesia section as the technical co-sponsor of this conference, the advisory board, scientific board members, reviewers, sponsors, and other parties that cannot be mentioned here who have helped and supported this conference. So we look forward to having a successful conference, and we hope that all the attendees enjoy and benefit from this conference. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Yulia Firdaus. Moving on from our technical co-sponsor, IEEE Asia section, please join me in welcoming Professor Linawati.
Okay, thank you. Thank you. Good morning, everyone. Good morning, dear distinguished guests, colleagues, researcher, professional, ladies and gentlemen. A prosperous, warm, and spirited greeting to all of you. First of all, please allow me to extend my warm greetings to the Honorable Chairman, National Research and Innovation Agency, Republic of Indonesia, Dr. Laksana Trihandoko, Chairman of Research Organization for Electronics and Informatics, from BRIN, National Research and Innovation Agency, Dr. Eng Budi Prawara, Head of Research Center for Electronics, National Research and Innovation Agency, Dr. Yusuf Nur Wijayanto, Head of the Center for Telecommunication, National Research and Innovation Agency, Dr. Armi, and of course to the General Chair of International Conference on Radar, Antenna, Microwave, Electronic and Telecommunication, ICRAMET 2023, Dr. Yulia Firdaus, as well as the all distinguished and keynote speaker, invited speaker, Professor Asrul Isam Asmi from University Technology Malaysia, Professor Iyad Dayub from France, Professor Seto Kensu from Japan, Kumamoto University, and of course to Professor Yosafat Tetuko Sri Sumantyo from Chiba University and Universitas 11 Maret. And last but not least to the all conference committee member and all participants this morning. Ladies and gentlemen, on behalf of the IEEE Indonesia Section Chair, Professor Gamantio, I would like to extend our warmest welcome to all keynote speaker, presenter, and participant of ICRAMET 2023. The conference is held on today and tomorrow in Bandung, Indonesia in online mode only by BRIN or Research Center for Electronic National Research and Innovation Agency with the IEEE Indonesia section as a co-sponsor. Please allow me to briefly explain about IEEE Indonesia section. In 2023, the IEEE Indonesia section co-sponsor more than 70 international conferences held in Indonesia, including this conference. But co-sponsoring conferences is not the only activity we do. The IEEE Indonesia section has carried out a large variety of activities over the 35 years of its operation in Indonesia. The IEEE Indonesia section implements the same mission of the IEEE, namely advancing technology for humanity within the scope of Indonesia. But at the same time, we also contributing to the IEEE mission internationally. As an example, we have started to work together with other IEEE section in the Asia Pacific region in promoting clean energy technology for climate sustainability under guidance of the President of IEEE, Professor Saifur Rahman. In line with the mission, we maintain good and mutual relationship and networking with the Indonesian government, industry, university, professional and scientific organization, and various communities in Indonesia. IEEE Indonesia section, of course, very proud to have had a cooperation agreement with the Director General of Higher Education since 2021, which allow us to directly participate in the development of engineering higher education in Indonesia. Our contributions are the following. Firstly, the IEEE Indonesia section presently have 22 technical society chapter and joint chapters covering the field of interest of 27 IEEE societies, widely ranging from power and energy to communication to oceanic engineering to education and to social implication of technology. These chapters support various scientific and academic activities in IEEE student branch in 38 the potential benefit of talent and skill development for students through the IEEE network. Aside from that, we also hold workshops on STEM, science, technology, engineering, and mathematics for high school students in our attempt to attract the best talents into the field of science and engineering. Up to now, a number of IEEE student branches in Indonesia section have won international grant for humanitarian technology project and STEM workshop, while several IEEE student members in Indonesia have received international award and scholarship from IEEE. Thirdly, the IEEE Indonesia section technically co-sponsor more than 70 international conferences annually. As the co-sponsor of these conferences, we strive to assist them to maintain the quality of the paper at the highest level and within the scientific scope of the IEEE. In terms of international publication, as of August 2023, there are nearly 30,000 scientific papers in total, with at least one author coming from Indonesia published in the IEEE Explore, which consists of those published in IEEE conferences and others in IEEE journal. However, out of those 30,000, there are still less than 1,000 papers authored by at least one Indonesian researcher that have been published in IEEE journal. Accordingly, we encourage Indonesian researchers to publish their research works in IEEE journal, which have been widely recognized as high-impact journals. To conclude this remark, we highly appreciate the commitment shown by the organizer of the ICRAMET 2023 to keep the quality of accepted papers at the highest level, focusing only on papers within the scientific scope of the IEEE. We hope that such a strong commitment be sustained through the coming years. Finally, we wish all participants an enjoyable and valuable experience during this conference by sharing your best knowledge in the research area of your interest. Please make ICRAMET 2023 a memorable event. Thank you and have a good day.
Thank you, Professor Linawati. I hope that our continued collaboration with IEEE will be coming for the coming years. Next, please join me in welcoming Dr. Budi Prawaran, as the Head of Research Organization for Electronics and Information from Indonesia's National Research and Innovation Agency.
Good morning, pleasure to be here to welcome all of you to the 12th International Conference Antenna.
Recording in progress.
On behalf of the organizing committees. This year's ICRAMET conference theme is Empowering Global Progress, Innovative Electronics and Telecommunication Solutions for a Sustainable Future. I hope that ICRAMET conference this year accommodate the discussion and the discovery of research in electronics and telecommunications, as well as fostering the community of researchers in electronics and telecommunications. We have carefully curated papers that are covered in 7 conference tracks in the field of electronics, telecommunication, and other related fields. We would like to welcome our keynote speakers that has been thoughtfully selected to outline recent developments and updates in electronics and telecommunications technology. First, keynote speaker is Professor Asrul Izam Azmi from University Technology Malaya, UTM Malaysia. Second, keynote speaker is Professor Josapa Tetuko Sri Sumaryanto from Chiba University, Japan, and University 11 Maret, Indonesia. Third one is Professor Kensu Seto from Kumamoto University, Japan. And the last, Professor Iyad Dayub from Université Polytechnique Hauts de France. We also welcome our distinguished patrons, Mr. Fon Yen Liu from Andritsu Unitronic Jaya. This conference was started at the National Scientific Meeting in 2006, organized by the Research Center for Electronics and Telecommunications, Indonesia Institute of Sciences, entitled Seminar Nasional Radar. This meeting was held annually until 2011, and it was developed as the International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunications. Since 2015, the proceedings of ICRAMET have been published globally in the IEEE Explore digital library. Finally, we would like to express our utmost gratitude to all participants, speakers, sponsors, organizing committee, members, and all involved parties who have supported ICRAMET 2023. We would like also to express gratitude to the IEEE Indonesian sections as technical co-sponsor of the ICRAMET. And I hope ICRAMET 2023 International Conference is going to be successful. Thank you very much for your attention and have a great conference. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Budi Prawara. Now, please join me in welcoming Dr. Laksana Trihandoko, the head of National Research and Innovation Agency for Indonesia, to officially open the 2023 International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunication.
Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, salam, Om Swastiastu, Namo Buddhaya, salam kebajikan. Distinguished Head of Research Organization for Electronics and Informatics, distinguished keynote speakers, experts, and also all participants, ladies and gentlemen. First of all, I would like to welcome you all to the 12th International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunications, ICRAMET 2023. It is a great pleasure for me to be here to join this international conference organized by our research organization for electronics and informatics. As we embark on this intellectual journey, it is very crucial to recognize the important advancements in electronics and telecommunication technology that have brought us to this point. The never-ending pursuit of innovation in these fields has not only transformed the way we communicate, but has also provided a foundation for a connected and technologically driven world. Moreover, in recent years, the landscape of artificial intelligence, AI, has evolved rapidly, becoming an integral part of various industries and also influencing the way we live and work. The symbiotic relationship between electronics, telecommunications, and AI has given rise to unprecedented possibilities and challenges, shaping the trajectory of our future. In order to shape the future of humanity, it is crucial that we responsibly and ethically develop these technologies. We find ourselves at a time where the collaboration among researchers, academia, and industry becomes important. Therefore, this conference hopefully could become not only a platform for exchange of ideas and research dissemination between researchers and academia, but also a platform to showcase attractive innovations and solutions for some industries that is interested with related topics to this conference. This collaboration not only drives innovation, but also could provide sustainable solutions for the challenges we will face in the future. Finally, it is important to bear in mind that a good innovation requires relevant research that not only groundbreaking, but also socially conscious. Our quest for knowledge should be guided by a framework that places the well-being of humanity at the forefront. Thank you to the research organization for Electronics and Informatics, and also all organizing committee members who has organized this event. I would like to conclude my speech by encouraging participants to explore the knowledge and research shared by speakers through the digital platforms. I wish everyone a successful and safe and fruitful discussion during this ICRAMET conference. Taking this opportunity, I would like officially open the 12th International Conference on Radar, Antenna, Microwave, Electronics and Telecommunications, ICRAMET 2023. Thank you very much. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Laksana Trihandoko. On behalf of the committees of ICRAMET 2023, I would like to take this opportunity to thank our generous patrons who made this conference possible. Please join me in expressing our gratitude to Under2 PTE Ltd Singapore and Unitronic Jaya, PT Era Mitra Perkasa, PT Serviam Abadi Murni, PT Radar Telekomunikasi Indonesia, PT Mitra Sistematika Global, PT Dynatech, CV Nugarada Abadi, PT Nusantara Turbin dan Proposi. Thank you all for your support for these events. Next, we move on to screen capturing session. I would like to request all honorable guests, distinguished speakers, presenters, and all of the participants to turn on your cameras. We will capture the frame 3 times, and I will do the 3 times of the signaling. Okay, everyone, please open your camera. Okay, we will start for the first frame in 3, 2, 1. For the second, in 3, 2, 1. And last, in 3, 2, 1. Okay, thank you for all your assistance in this screen capturing session. Ladies and gentlemen, we have concluded our opening ceremony, and I would like to thank all honorable guests, distinguished speakers, and all of our participants for the participation and attendance in the opening ceremony of ICRAMET 2023. For our first agenda, okay, we will have a special presentation from our gold patron, Under2 PT Ltd Singapore, or Unitronic Jaya, presented by Mr. Liu Fyun Yu, the Field Marketing Manager from Under2 PT Ltd Singapore. But first, I would like to check whether Mr. Liu Fyun Yu is already here with us.
Yep.
Okay, thank you.
Already here.
Thank you.
Hello.
So yeah, we are ahead of the schedule for 3 minutes. Are we okay to continue, Mr. Liu?
Yes.
Okay,
We're fine. Yeah.
Okay, thank you, thank you. Okay, so I would like also to welcome Ms. Alice Christiana Tirta and Mr. Gumbira Setiawan, representing Under2 PT Ltd in Singapore and Unitronic Jaya. Thank you for joining us on this session. And this session will be moderated by Mr. Prasetyo Putranto. First, I will introduce you to Mr. Prasetyo Putranto. He is currently a researcher at the Research for Indonesia Research. He earned a Bachelor of Universitas Gajah Mada. Sorry, am I clear?
Recording in progress.
And one of the very common technical challenges before that, one of the key aspect for the setup that we need is what is the vector network analyzer dynamic range. So what is the dynamic range? Basically, it is the difference between the and then on the receiving side, and what is the noise level received at the VNA receivers. So some of the technical specification for the VNA, the parameter settings from the port on the vector network analyzers to the device under test or the antenna under test. Yeah. So the cables itself, it will usually introduce a signal loss between the DUT and the VNA port. And this will effectively reduce the VNA measurement dynamic range. So take an example for this one of the cable that is measured. So as we know that as the frequency going towards higher, towards the microwave range, millimeter wave range, and so on, it is not uncommon to get almost a 10 dB loss just by the cable itself. Yeah. And typically for a microwave cable, as a rule of thumb, is about a dB loss per meter, just at the 4 gigahertz. Yeah. So and we can get as much as a 4 dB per meter for 40 gigahertz. So for this particular graph is a very long cables. Yeah. So if I have about a 12 dB kind of a loss at a 40 gigahertz. And another factor that contribute to the uncertainty in your measurements is the cable phase. As we know that VNA, vector network analyzer, they are not only measuring the magnitude, they are also measuring the phase. And the phase stability it can be affected by both the environmental temperature as well as the cable movements. Later, we will see some of the setup that involve a lot of cable movement, especially when we're doing the antenna measurements. Yeah. And not to mention, yeah, the cable, if you need a very high quality cable, that is would be a very expensive peripherals as well. So take for example, which I could find it from the web. Yeah. So a 40 gigahertz cables, it costs almost can be cost almost like a 1,500 US dollar. And the higher the longer the cables, so from 63 centimeters to 120 meters, yeah, it can cost as much as 2,400 US dollar. So just in a nutshell, for every 30 centimeter increase, there's an estimated cost of increase of $250. Yeah. So that translates about $800 increment for per meters. Yeah. So imagine you need to measure a 20 meters long distance subject. So just the cable alone could cost you about 16,000 US dollars. So now, how do we tackle the challenge? So for Enriser, we try to address this by eliminating the cable insertion loss and also the phase uncertainty by instead of using the test port cable to extend from the VNA to the DUT, which is the conventional method, we bring the VNA straight to the DUT port. Yeah, the right hand picture here is the solutions that we are proposing, where instead of the benchtop, the traditional VNA, where we have both the ports is assembled in one chassis, we have break it down into two different chassis. So this could be the port 1. We bring it directly mount and then connect to the DUT end and another chasis, we bring it to another end, in which the distance for these two ends could be a very long, let's say 5 meter, 6 meter, 10 meter, 20 meter, or even 100 meters. Yeah. So how do we do that? Is instead of using the RF coaxial cable, we link the synchronization between these two distributed VNA through our enriched proprietary phase link connections, where we have the communication between the VNA ports using optical cables, yeah, and also the data and control. Those are less susceptible to uncertainty when they move around. Yeah. So that is how we try to resolve the issues. Okay. Let me try to play a short video and hope you could hear the music as well.
Making accurate antenna measurements in large chambers and outdoor antenna test ranges, or making long-distance measurements such as testing long cable runs on aircrafts or ships are not easy tasks. The traditional measurement solution uses a two-port benchtop vector network analyzer, a VNA, where the user must attach two very long test port cables. The problem with this solution is that long cables introduce signal loss, reducing dynamic range. To overcome this challenge, a high-end VNA is required, and components such as low-noise amplifiers are introduced to improve dynamic range. As the frequency of interest goes higher, however, small movements in the test port cables have an adverse effect on signal phase. Introducing the solution to long-distance S-parameter measurement problems, the Inritsu Shockline ME7869A. This modular two-port distributed VNA can make vector-corrected S-parameter measurements over distances as long as 100 meters. Complicated test setups and lossy cables are eliminated, since the instruments are powered by Inritsu's patented phase link technology. This technology allows synchronization between the two VNA test ports using optical cables. No matter how much the user moves the cables, there's no phase deviation, while system dynamic range is fully preserved no matter the distance between test ports. Now you can confidently test long cable runs from aircraft's nose to tail and wingtip to wingtip, from ship's antennas to underdeck control rooms and antennas on outdoor test ranges, or in large anechoic chambers, all to full performance with a compact and easy-to-use solution. Inritsu, providing excellence in wave measurements, covering the distance with our patented phase link technology, integrated into the Shockline ME7869A modular vector network analyzer. Inritsu, advancing beyond.
Okay, yeah, that's the video of our product, distributed VNA, and let's come to some study on how to simplify the setup. Yeah, so let's take a large OTA chamber or an outdoor antenna test setup. So this is a large OTA test chamber for the automotive testing. So this is how basically the conventional testing. So we will have a vehicle on the turntable, and then we have a test antenna on the shelf. So, and take a look, yeah. So we need to constantly move the test antenna, and as the vehicle rotate, so there is some movement as well. So from the setup, so we can see that a very long cable needs to be connected from the VNA to the test antenna, as well as into the vehicle. And very often, to compensate the loss, a preamplifier is necessary in the chamber. Yeah. Secondly, so we can see that there is a movement involved, and this kind of movement, and it will cause the phase change in the RF cables. So these two are often one of the headache in the large OTA chamber testing setup. So instead of using the long cable, we can have the enriched distributed VNA by directly mounting towards the close to the test antenna that will, and also inside the vehicle. Yeah, so that will help to eliminate the long RF cable, and we don't need the preamplifier, and we can also minimize the phase changes caused by the cable's movement. Here is another example with a link budget study. So the left-hand side is the conventional setup for just a 6-meter chambers. Yeah. So the benchtop, the conventional VNA, it has to be a very high-end VNA in order to have the sufficient dynamic range to power up the whole system. But because of the whole setup involve a very long distance cables from the VNA towards the antennas and the DUT, so we need to add on the power amplifiers and LNA and the rotary joint as well. But with the distributed VNA, so we can actually directly mount the VNA module close to the antennas, and thus we can eliminate all the other accessories. And even that, if we do the calculation of the link budget, so the calculating the ERP, the radiated power from the antenna, and then towards the power that is received on the other end, the total dynamic range, you can see that for the distributed VNA is still much better than the conventional setup. So this is how we could help the large chamber kind of like setup. And take note that we don't need a very good data sheet dynamic range specification in the data sheet for this particular distributed VNA. So even the dynamic range as specified in the data sheet for this may not be as good as a very high-end benchtop VNA, but the full setup itself, we can still achieve much better system dynamic range. Another example is on the outdoor. So similarly, on the outdoor, the conventional setup, we will need a lot more equipment and accessories such as the mixers, receiver, and in order to compensate of all the setup losses and so on. Again, we can replace it with the distributed VNA closer to the source antenna and the antenna under tests. So it is much simpler, and if we eliminate all the peripherals, and we improve the stability. So this is one of the sites, as you could see, So one of the source antenna and then the antenna under test. You could see that when the source antenna they move up the shaft down, there are a very long RF cable that could be dangling here. So this could contribute to a lot of uncertainty when it moves around. But if we replace it with the distributed antenna, distributed VNA close to the source antenna, although there will be still the cable dangling, but this dangling, because it is fiber optical, and also just a normal data cable, it is not as severe in terms of the uncertainty for the phase measurements. So just a quick summary for this. So the distributed VNA, it has a clear advantage for a large long distance OTA application for the testing antenna, because we can eliminate a lot more of the accessories such as the amplifier, mixers, and so on, to just simple this two-port distributed VNA. And we can connect it directly to the test antenna we don't need the very long cable, which introduce the insertion loss. And because there are no long RF cables involvement, the phase stability is improved. And of course, yeah, so the installation are much simple. And remember, when we use all the accessories like the mixer and so on, they are band limited because they could not cover a very wide bandwidth. But with this, without all this, the mixers and so on, or or the amplifier. So actually, yeah, we can kind of do a very wide range strip to as high as like a 40 gigahertz. Yeah. Okay. So now let's come to another radar antenna system application. So it is quite common for to study a phase difference of a synchronized radar pulse transmitter that could be a far away. Yeah, let's say about 20 meters apart. So if we are to use the VNA, distributed VNA for such study, so there are some of the features that may be necessary. So as we know that VNA usually it has both the source and the receiver. So and it always have the source kind of like pumping out the signals and so on. And we don't really want it to kind of like have the signals generated from it. So we can kind of like turn off the source power to let the VNA to act as a receiver only. Yeah, this is one of the consideration. Another is that consideration is that since the pulse has a certain duty cycle, so you may want to just to trigger it based on the rising or the falling edge, and to have some delay when it's doing the signal measurements. And time domain is also very often necessary. And again, yeah, since the radar can be far apart, it may not be just a fixed 20 meter, it could be 50 meter and so on. So we might need to have to consider to cater for different distance. So now, how does our distributed VNA comes to have it? So first of all, we built in a features to turn off the power, and we can set the response to only measure the receiver on the port 2, and then compare it to the port 1 receiver, that we can get the comparison of the phase on these two ports. Secondly, yeah, so we have the external trigger source. So you can have the trigger line come in, and we can trigger it based on either the rising or the falling edge. And you can have a trigger delay as well as the based on the pulses. Thirdly, yeah, so we might want to monitor in the time domain. So we have the time domain options, which can convert from, instead of viewing the results in the frequency, so we can convert it into time or even to the distance. Then from here, we can, let's say, to put on the marker to find out what are the pulse width and the difference, yeah, between the antenna 1 and the antenna 2. And of course, with our distributed VNA, we are flexible in terms of support different distance. As of now, we provide a few standard options, such as 25 meter, 50 meter, and 100 meters. But we can also do some customization for some of the other lengths. Okay, so now comes to some other useful application for telecommunication as well as other usage as well. So because of the modular nature, so instead of a lot of usage can be just based on the one port of this distributed VNA. So we can just use one of the modular and then connect to the antenna and then do the sensing and to check the return loss and thus to do the measurements. This picture is showing like a material measurements on the radome defect detection. And because of the wide range, up to 43.5 gigahertz, that give a much better resolutions. Yeah. And of course, now as of the 5G, we have been talking about millimeter wave range. Yeah. So we can cover the 28 gigahertz, 39 gigahertz antenna return loss measurement with just one single port VNA. And of course, with this, we can also plug into a cable to check the distance to faults as well as the return loss. Yeah. And because of the small size, so it is very space efficient. Yeah. So can use it for the education purpose as well. And a couple of weeks ago, we also recent in ICEP in Kuala Lumpur. So we have this setup. So for a 5G millimeter wave array antenna, beam characteristic as well as or the risk characterization. Risk is something a reconfigurable intelligent surface or smart surface is one of the topic that is highly interesting in order to help to deployment of the 5G millimeter wave because of it is a passive in nature. So it what it does is that it can help to reflect the beam and then you can install it a lot of this in the indoor so that will help to increase the coverage for the 5G millimeter wave. Yeah. And here is a setup. So we can have the one of the ports over here and then connecting to a beamformer when we have the beam directed towards the risk surface, and from there it is being reflected and received in the by the horn antenna on the other side, which is connected to the distributor VNA port 2. So in fact, this because of the nature of the distributor VNA, we can thus do an experiment for a much longer distance, let's say a 5 meter, 10 meter, 20 meter, to check the effectiveness of the coverage by implementing of all this risk technology and so on. And again, with the advantage of the distributed VNA, so we can have it to do the measurements like a shielding effectiveness on a very large vehicle like the helicopters, aircraft, the ship, as you have seen in the video I played just now. Okay, so let me quickly run through what are some of the distributed VNA cables. So basically, it consists of the two of this modular VNA. It's a MS46 131A, and you will need a control PC connect to the distributed VNA, and then in between they are synced with the so-called the phase link cables. The yellow are the optical cables and the black are the electrical cables. And from here, this will be the user interface where you can connect to the DOT or the antennas and thus you can stretch it out for a very wide long distance. The VNA itself, it supports 3 frequency models, 8 gigahertz, 20 gigahertz, and 43.5 gigahertz. And you can do a full 2-port as parameters. So to cater for different length, so we have a standard like a 2 meter, 5 meter, 25 meter, based on the earlier model, ME7868A. So for the 2 meter and 5 meter, the connection is rather straightforward. For a 25 meter, we need to add on the extender, to cater for the drop or the losses in the electrical drive slang. And we have a new product to cater for up to even 100 meters. Yeah, and it's called the ME7869A. So as you could see, it is much simpler. Yeah. So comparing to the 25-meter setup as I shown just now, so with the new product, we simplify it, the connections. Yeah. We don't have so many cables connecting around, and then we have we just basically 3 modules, and then a row of the cables to connect to each other, and it can go up to 100 meters. Yeah. So instead of these 2 multifunctional extender modules, now we only need one of this MN25 132A, and from here we can power up the VNA as well as the communications. So, and from the PC, so the old model we will need to connect to both sides. Now the new one, we just only need to connect to the center, the MN25 132A, and we don't need this particular rail. So yeah, the reels can be quite big, and yeah, so we are all bundled it together, a tidier setup. And we also reduce the number of power supplies in the entire system. So we just need one power supply to connect to this center, the extender. Okay, so let's come to the last part, which is the summary. So with the conventional VNA setup, when you applied it for a very long distance measurement, so basically you suffered it from a long RF cable insertion loss, and you will have the phase stability issues. That basically reduce the VNA measurement dynamic range. And very often to cater to compensate it, we will need an additional accessories to compensate it, and the setup can be complicated. So we provide the small size from a modular 1 port, and also the distributed 2-port VNA. Is basically powered by our patented NLTL technology as well as the phase link technology to bring the VNA port directly close to the DUT, and thus we remove the RF cables. And the modular form, so it provides a flexible configuration for various distance coverage. So I believe with this, it will help your research, for the antennas, radars, as well as the microwave technology in a great way. Yeah. So you can come and browse our product in this website. And lastly, so to take note of our product update, we welcome you to join our LinkedIn, and then follow our LinkedIn product page, where you can have our most updated information on hand. With that, I would end my presentation.
Okay, thank you very much for your interesting and insightful presentation, Mr. Liu. So I am Prastio. I should be the moderator in this session. First of all, I'm sorry for the sudden network problem before. So if I may summary that your presentation is about that this phase link technology can simplify the measurement that should need a long distance cable, right?
Correct.
And okay, and now we have a question and answer session for 9 minutes. Once again, to all participants who have question, please use raise hand feature in your Zoom, and please open your camera. You may deliver the question after I call your name. And you can also ask via chat box as well. So
I think I saw one question on the chat box. Is from the question is it possible to
I have the question. I have the question.
Yeah.
Okay.
Yeah, please go ahead. Please go ahead.
Okay, my name Wahyu from Research. Hello.
Yes.
My name is
we can hear you.
Wahyu from the Center for Telecommunication.
Mhm.
My answer, my question is, how make we say how to use for the long distance, how to make the conventional I need to VNA,
Mhm.
you know. Yes, understand.
Sorry, your voice is breaking up. Yeah. So, could you kindly repeat that?
Okay. We have the conventional unreached VNA.
Uh-huh.
I forget the series, but I know that this the economic version. Yes. And how to make this VNA to function the long distance measurements for cable. How
I
to
see. Okay. Yeah. Usually, yeah. In order to make use of the conventional VNA to cable to cover, so the key thing is to calculate the dynamic range that you have, and of course, take a sample for this one. It's just a 6 meter kind of a chamber. So, and then the 6 meter, the path loss is about, let's say, we calculated at the 40 gigahertz, yeah, it's about 80 dB. And so we need to know that what is the power that is being delivered to the source antenna, and then on the receiving end, the antenna under test, what is the power that is being received, and how much power that is being when it brings back to the VNA, how much power that is basically received. So basically, you can calculate it accordingly, and see what are the components that you will need to add it up. Like you will need to boost the power delivered to the source antenna, and you may also need to add on the low noise amplifier in order to bring up the power that is going to deliver to the VNA to be sensitive enough to receive it. So yeah, usually it will be quite complicated, and it involves a lot of external kind of like accessories. Yeah. And those components depends on the frequency range and the band, and also the cables. Yeah, it could be quite expensive as well. So yeah, basically we will need, I would say, to simplify again. So basically we will need to understand what is the distance, and then we calculate the losses that is expected. Then from there, we will need to calculate what is the power need to be delivered, and what is the power need to be received. Yeah. Then from there, we add on the accessories accordingly. I hope it helps.
Okay, thank you. So we must buy the new ones.
I would say to simplify it, yeah, I would say it will be easier to have this one. It will much simpler to set it up. Yeah, of course you can still use the old one, but I would say the setup could be quite complicated. Yeah. The more components you have, when you want to try to debug, the more
Okay,
the
thank
more
you.
factors you need to consider. Yeah.
Okay, thank you very much. And there is one question in the chat box from Mr. Iman
Yeah.
Firmansyah.
So
Is it possible to configure the VNA for radar target simulator?
Yeah.
Yeah.
Okay. Well, for us, yeah, for what we can really do is that, yeah, so we may not be actually I'm not sure the radar tagged simulator what is the parameters that you really need to measure, but basically we can kind of like measure like the pulse. You can do a comparison of the phase, and then you can check the pulse width and so on. So yeah, it really depends on what are the parameters that you are of interest. Then it depends on how we find the application of the VNA for the radar. Yeah.
Okay, thank you very much.
Okay, thank you.
Yeah, I think because yeah, the time is limited, so before we conclude this session, on behalf of the ICRAMET committee, I would like to thank Mr. Liu for delivering the speech in ICRAMET 2023, and for Andrew to Singapore for providing patronage to this conference. So thank you for your time.
Yeah, thank you again.
Also, yeah,
if any question, just feel free to approach Unitronics. Yeah. Okay, thank you.
Yes. Yeah, and also participant that's interested in Anritsu product, you can access website of Anritsu, www.anritsu.com. Thank you for all participants in this session. So finally, allow me to formally conclude this session. I hope you all have a wonderful day and find inspiration in the upcoming conference session. My sincere gratitude to you all. I now invite you to redirect your attention back to our MC. Thank you very much.
Thank you, Mr. Prasetyo Putranto, and also thank you, Mr. Lee Vyun-Yen. We apologize to Mr. Lee Vyun-Yen and participants regarding the confusion due to the connection issues. So I would like to express gratitude again for Anritsu, PT Ltd Singapore, and Unitronic Jaya for having brought to us the first patron session. I hope you found this session informative and useful. Thank you for your attention. Next, we will have our first keynote talk by Associate Professor Asrul Izam Azmi from University Teknologi Malaysia, or UTM. This session will be moderated by Dr. Eri Dwi Kurniawan. First, I would like to introduce Mr. Eri. Dr. Eri Dwi Kurniawan completed his Bachelor of Electrical Engineering in 2009 from Gajah Mada University, Yogyakarta, Indonesia. He received his doctoral degree in the Engineering and System Science Department at National Tsinghua University, Taiwan, 2014 to 2019. Currently, he works as a research fellow at the Research Center for Electronics, National Research and Innovation Agency for Indonesia, or BRIN. His research interest is micro or nano electronic devices, particularly nanoscale transistors, including design, simulation, and fabrications. Also, micro-nano electromechanical system and flash MEMS, sensor technology, and embedded systems such as microcontroller programming, system on chip, etc. He has also been appointed as focal point Indonesia for ASEAN Subcommittee for Microelectronics and Informatics Technology, or SCMIT, from 2022 to the present. Please welcome Dr. Eri Dwi Kurniawan.
Good morning. Good morning, distinguished speaker, honorable guests, all presenter and all the audience. My name is Eri Dwi Kurniawan. I'm the researcher at Sensor and Actuator Devices Research Group, Research Center for Electronic National Research and Innovation Agency, BRIN, Indonesia. And today I will serve as the moderator for the session keynote talk 1 today. Today you will hear a presentation from Associate Professor Dr. Asrul Izam Azmi from University Teknologi Malaysia, UTM, with the talk topic about the fiber optic sensor advanced technique and application. Before we get started, I want to take a few minutes of your time. I will introduce the biodata of Professor Asrul, including his background study, working experience, and his research interests. Professor Asrul got a bachelor degree from the Faculty of Electrical Engineering, University Teknologi Malaysia from 19 1997 until 2001. Then he continued his master also in the same university from 2002 until 2004. And he completed the doctoral of philosophy in electrical engineering, the University of New South Wales, Australia in 2012. And now he is associate professor at University Teknologi Malaysia, and he also is a research manager in Faculty Electrical Engineering, University Teknologi Malaysia from 2022 until now. And he also head of the league-wide communication research group at UTM from 2014 until 2017 and 2019 until 2022. And he also worked as the lab manager, School of Electrical Engineering, University Teknologi Malaysia from 2020 until 2023. His research interests are including optical sensor, device, and instrumentation. And he also interested in the sensor application in various engineering field and also optical communication system. Ladies and gentlemen, today's speech topic is about the fiber optic sensor. As we know, the fiber optic sensor have emerged as a prominent sensing technique due to the main advantage of small size, high multiplexing capability, and robust operation in harsh environment. So in this talk, Professor Asrul will give an introduction to fiber optic sensor fundamental, development milestone, and also achievement in various applications. He also presents some of the research work related to the application of fiber optic sensor at University Teknologi Malaysia. And ladies and gentlemen, the time for the keynote speech talk is around 45 minutes, including the Q&A. For the participant we would like to ask the question, please use the raise hand function at participant menu on your Zoom and type the question in the chat box. Ladies and gentlemen, please welcome Professor Asrul to deliver the speech. Time is yours.
Okay, thank you, moderator. Assalamualaikum warahmatullahi wabarakatuh, and very good morning, everyone. First of all, I would like to thanks to the ICRAMET 2023 organizing committee for inviting me to give this keynote speech. It's my pleasure to share some of my knowledge and experience in this highly reputable conference. My name is Asrul. I am from the Faculty of Electrical Engineering, University Teknologi Malaysia. The title of my speech today is Fiber Optic Sensor, Advanced Techniques and Application. The outline of presentation is given as the following. First, I will give an introduction about fiber optic sensor. Afterwards, I will give a few examples of fiber optic sensor in advanced application. Then I go into the advanced sensing techniques of fiber bright grating sensor. I also will share the applied research work that have been carried out at University Teknologi Malaysia related to the fiber optic sensor. And then finally, I will give a closing on the obstacles, potential, and also conclusion for this talk. And the objective of the presentation today are to share some examples of advanced fiber optic sensor technology. This talk also intend to create awareness to the audience on the key application of fiber optic sensor, in particular in the structural health monitoring. Hopefully, the talk will benefit all the audience this morning. Let's move to the introduction part. First, we look at the definition of a sensor. A sensor is defined as a device that detects and responds to the environmental changes. From there, we can further define optical fiber sensor as a class of sensor that utilize fiber optic to detect and measure environmental parameters. Now we look at the figure here. It shows the schematic of an optical fiber sensor. Optical fiber sensor system must has at least 3 of these components. First, the light source, which need to provide signal to the sensor. We also have a detector, which is used to detect light, and also an optical fiber, which is used as the sensing element. Let me introduce briefly about optical fiber. The figure on the bottom left shows the structure of optical fiber, which It is basically a thin cylindrical structure made of glass or polymer. It is used basically for light guiding structure. Figure at the middle here shows the outer diameter of a standard optical fiber used for telecommunication, which is at 125 micrometer. And the figure on the right bottom here shows the actual photograph of a standard telecommunication optical fiber. Now I will give a general explanation on the needs of optical fiber sensor technology for industry. Actually, the role of optical fiber sensor technology is to complement the conventional sensor, which is the electrical-based sensor. And this technology is targeted at the applications where the electrical sensor technology is marginal or non-existent. There are few examples of application where fiber optic sensors really attracted considerable interest as the following. First, on the health monitoring of civil engineering structures such as dams, bridges, and buildings, oil and gas exploration, aeronautic and aerospace, environmental sensing, and security and defense. In fact, there are many other applications which are not listed in this slide because of the time constraint. And these are the advantages that really make the difference in terms of the performance and practicality compared to the conventional sensor. First advantage is the small size of optical fiber. Single mode fiber has the outer diameter of 125 micrometer, which allow it to be deployed in a very tight space, or even it can be embedded directly in any structure. Second important advantage that this technology allows high number of sensors to be multiplexed in a single piece of optical fiber. This means it will also reduce the cable length and also simplify the installation because sensors are connected in series. Okay, depending on the type of optical fiber sensing technique, the fiber backgratting technique, which in current stage, it can accommodate more than 1,000 sensor head, okay, in a single fiber. There are also other type of sensor known as a distributed sensor, reported recently in Nature journal. More than 1 million sensor point can be multiplexed in a single fiber. Okay, under other important capability of fiber optic sensor is its long sensing coverage. For example, for the fiber backgratting, the maximum distance was reported at 250 kilometers. And there is also other technique with longer distance. Other advantage are fiber optic sensor not affected by electromagnetic interference. It has robust and safe operation, and it has relatively long lifespan. Okay, now we look further on the fiber optic sensor history and milestone for the last 5 decades. Okay, this summary is made based on my own search on the available resources and also by referring to the published works. Okay, basically many important breakthroughs will happen in 1970s or earlier when some of the techniques were invented during this time, for example, interferometry and fiber backgratting techniques. And then this initial finding has increased the research momentum for the following decades. Then in 1980s, many important breakthroughs related to the distributed sensing, okay, was achieved. Then there was also a pioneering application of fiber optic sensor, but limited to military application only. Then in 1990s, the trend of commercialization of fiber optic sensor product was started. A few companies have successfully produced and sell fiber optic measurement instrument, for example, Micron Optics, Luna, JDS, Uniphase, and etc. Okay, at the same time, fiber optic sensor also was started to be deployed in the field test in structural health monitoring as well as in oil and gas industry. Then in decade of 2000, there are more and more commercial fiber optic product focusing in niche market such as oil and gas and also structural health monitoring. Then the following decade from 2010 to current time, we can say that fiber optic sensor technology has reached significant maturity. Okay, most of the research work now are trying to fulfill the needs of the latest diversified application, improving the performance as well as making the technology more affordable. Okay, some of the trends are listed there. Okay, now I will give a few examples of advanced application of fiber optic sensor in order to give some idea on how far this technology has developed so far. Okay, first on oil and gas industry. Oil and gas industry is one of the sectors that hugely benefit from the fiber optic sensor technology. It has been used in various stages in oil and gas industry, beginning from the exploration, production, and transportation of oil and gas using pipelines. Okay, the main reason why fiber optic sensor is crucial for this industry because the downhole environment is very harsh for electrical instrument. Okay, for example, the pressure there can reach 2000 bar, temperature can go up to 300 Celsius. And oil and gas also produce a byproduct known as hydrogen sulfide, which corrosive and could cause failure to electrical instrument. And the new oil reserve also located very deep below the ocean. Okay, as most of the shallow reserve had depleted, the deepest oil well reported reached down to 12 kilometer deep. Okay, this reason provides the opportunity to optical fiber sensor as they are significantly more capable and reliable for this condition. Okay, for oil and gas application, one of the important usage of fiber optic sensor is for vertical seismic profiling. This is used during the exploration stage. Okay, this will allow to identify the geology of the subsurface layer. Okay, this profiling basically involves the generation of artificial sound. Okay, and fiber optic sensor is placed in the entire well permanently to record the propagating acoustic sound, and then from the measurement, acoustic velocity is calculated, and then it is used to determine the composition of the subsurface material, such as oil and water ratio. Another important application is to monitor the gas flow, as well as to monitor the well integrity such that there's no leak happen within the well. Okay, oil and gas also relies on the vast pipelines network to transfer the hydrocarbon. Therefore, it is crucial to establish comprehensive network surveillance system to protect the pipeline from unwanted incidents such as intrusion, theft, and also sabotage. Okay, in fact, many oil field service companies such as Schlumberger, Halliburton, and others company have invested heavily in proprietary sensor technology so that it will give them a competitive edge compared to other companies. And certain aspects of the intellectual property are kept confidential and not disclosed to public. Okay, another application is in aerospace and aeronautic. Basically, fiber optic sensors have been used by key players in aerospace and aeronautic industries such as NASA, Boeing, and also Airbus. For example, NASA has applied fiber optic sensor in variety of their vehicle testing. Okay, one application is in the electrified aircraft propulsion. In the NASA Helios aircraft, as can be seen in the figure, okay, it is installed with a number of electrical motors along the wings. However, these electrical motors generate so much electromagnetic noise, this has prevented any electrical sensor to be installed at the aircraft for monitoring purpose. Okay, therefore, fiber optic sensor were utilized and successfully operate. Fiber optic sensor also has been installed by NASA in their unmanned vehicle, the Predator B. Okay, figure at the bottom left. This is used for monitoring the wing shape during flight. Okay, apart from that, NASA also has used fiber optic sensor in their development of the composite crew module for space exploration. Okay, the sensor was used to measure real-time three-dimensional strain distribution during pressurized testing. Okay, for all the characterization work, NASA has developed their own advanced monitoring system based on high-definition fiber grating sensor. This system can accommodate 2,000 sensors in a single fiber, and there are maximum number of channels is 8 channels. So the total sensor is maximum number of sensor is 16,000 sensor. It can be used for multi-parameter sensing such as strain, temperature, and also vibration. Fiber optic sensors also have been widely used in civil engineering structure, especially in countries like China. The main purpose of the sensor is to provide measurement of strain and temperature. The strain measurement provide early detection of concrete deformation, shrinkage, and also potential cracks. Some examples are provided here where fiber optic sensors are deployed for long-term monitoring at tunnel and also bridges in China. And last but not least, fiber optic sensor also has gained interest for military application. One example provided here is fiber optic hydrophone. Hydrophone is a device that is used in a sonar system to detect acoustic signature emitted from other ships or submarine. Top figure here shows the USS Virginia attack submarine, which was installed with wide aperture array fiber optic hydrophone at the flank of the submarine. There are 6 arrays in the total, and each array consists of 450 unit hydrophone. Okay, fiber optic hydrophone also have been tested and deployed in a tow array configuration. As you can see here at the bottom figure, shows a testing carried by Thales Australia, where the fiber optic sensor is installed at the back of a small boat. Now we look further details on fiber bright grating sensor, which one of the most important type of sensor. Okay, I will explain on the classification of optical fiber sensor. Basically, there are 3 main categories, which are based on the modulation, principles, and also the spatial scope. On the classification based on modulation, the sensor is classified based on the change of the light wave parameters, whether it is intensity, wavelength, phase, or polarization component. On the principle, fiber optic sensor also can be classified based on the principles such as grating, scattering, interferometry, spectroscopy, variation wave, and so on. Fiber optic sensor also can be classified in terms of its spatial scope or the coverage of the sensor. Okay, it can be classified as a single point sensor where only one sensor is used for a localized measurement. Another classification is quasi-distributed, where there are a discrete number of sensors presented along the fiber. There are also another classification known as the distributed sensor. It is a continuous type of sensor where the whole fiber is used for sensing. Okay. And fiber bright grating sensor can be categorized as a wavelength modulated sensor, and it also can be configured to operate as either a point sensor or quasi-distributed sensor or distributed sensor, depend on the requirement. Now we look on the structure and operation of fiber bright grating. Fiber grating basically is formed by periodical changes of refractive index in the fiber core. Okay, when a broadband source is launched into the fiber, a narrow band will be reflected and by the grating, and it is peaked at the wavelength known as the bright wavelength. Okay, while the remaining light will pass through the grating. Okay, the expression at the bottom here shows that the bright wavelength, okay, depends on the effective refractive index and the period of the grating. Okay, now we look further on the response of fiber bright grating towards 2 important parameters, which are the strain and temperature. These 2 parameters are the most common physical parameters measured in the structural health monitoring application. A figure on the left side shows the strain response. When the fiber bright grating is strained, it causes the bright wavelength to shift either to the higher or to the lower wavelength, depends whether the force is a tensile or compressive. Okay, the common strain response is around 1.2 picometer per strain, per microstrain. Okay, fiber bright grating also responds to temperature changes because of the thermo-optic and thermal expansion property of glass. The temperature response is typically around 11 picometer per Celsius. Fiber grating is responsive simultaneously to strain and temperature. Therefore, it's important to implement a compensation method in order to nullify the effect one of the parameter. Okay, now we look on the grating fabrication method. Figure on the left side shows the conventional writing method, okay, based on UV laser scanning with a face mask. As you can see, there's a glass enclosure in which the fabrication is done inside to prevent UV light exposure to the user. There is also a platform, okay, where optical fiber is aligned to a face mask, so that when incoming light arrive at the face mask, the light will be diffracted into different direction or order, in which it is used to write the grating on the optical fiber. Okay, on the right side figure on the right side shows the FBG writing technique that is known as the draw tower method. This is the most advanced method which is suitable for a large production of grating. Okay, the writing process is done simultaneously with the fiber drawing process. Okay, from the figure, the process starts from the melting process of glass preform at the top of the tower, and the process requires tower to have heights of at least 10 meters or more, okay, to allow faster drawing process. As the preform is heated, it will melt, and then subsequently fiber is drawn. Okay, during the fiber drawing, the grating writing using laser is done simultaneously. Okay, this manufacturing process has many advantages. First, the large number of sensors can be produced. Secondly, it produces grating with a better strength. Okay, this slide shows the typical sensor connection in wavelength division multiplexing configuration. In here, the light source could be a broadband or laser sweep system, okay, that cover the whole spectrum of the grating. Okay, the grating are connected in series, whereby each grating reflects light at different wavelength, and the peak of the spectrum of the grating is used for tracking the sensor response, okay, either strain or temperature throughout the measurement. Okay, wavelength shift can be resolved using equipment such as optical spectrum analyzer or Fabry-Perot tunable filter. Okay, however, this type of measurement technique has some limitation. Okay, the first one, okay, the number of highest number of sensor typically limited to around 10 sensor per channel. Okay, this is because the sensor requires sufficient wavelength spacing to avoid spectrum overlapping or crosstalk between adjacent channels. If we increase now large number of sensors in single channel, it will also create other complexity in terms of production of sensor at various wavelength. Another important point is that the positioning of sensor is very important because it is, the sensor measurement is very localized, okay, due to its small size. Okay, as we can see, the WDM or the wavelength division multiplexing technique has limitation in terms of number of sensor per channel. In order to increase the number of sensor, one can implement WDM together with the time division multiplexing or TDM. Okay, the number of sensor can be increased by n times, okay, depending on how many time slot is created. Okay, with increased number of sensors, it's possible to measure like two-dimensional distribution of strain or temperature by arranging sensor into certain coordinates. Okay, in order to substantially increase the number of sensor per channel, okay, an advanced method known as the optical frequency domain reflectometry or FDR can be used. Okay, this technique is totally different compared to the WDM. Okay, the overall setup is shown by the figure at the top, and the sensor part is shown by the figure at the bottom here. It consists of a reference mirror and also a large number of grating sensors connected in series. Okay, for this FDR, all grating have similar wavelength and also have a low reflectivity. Each grating and the mirror pair form a unique cavity, okay, due to the variation distance between FBG and the mirror. Okay, each cavity, as indicated by the arrow of different colors in the figure, will generate signal known as a bit signal. This bit signal from each of the cavity is unique from one another in terms of the frequency. So the detected intensity of the system can be given by the summation of the bit signal, okay, as indicated by the equation at the bottom. Okay, and it is in the form of sinusoid. Okay, after in the detection stage, okay, this signal or this expression can be processed in a Fourier domain. And normally for all FDR, more than 1,000 sensors can be multiplexed in a single fiber. Okay, all the sensing techniques have a limit and trade-off in terms of the sensing distance and the spatial resolution. For example, FBG with WDM, it can attain best resolution of about 10 millimeter. Okay, that is limited by the grating length, which is about 10 millimeter, while the sensing distance can go beyond 100 kilometer. While for the FDR, okay, the best spatial resolution is about 1 millimeter, also limited by the length of the grating. Okay, for this scheme here, but it also has limitation in terms of the range, which is about few kilometers only. Okay, apart from that, we also have the conventional distributed sensing technique, such as the Rayleigh, Raman, and also Brillouin distributed sensing with their own characteristics, and therefore it also has its own particular application. Okay, now we do a simple comparison of performance and characteristic between fiber grating sensor and the electrical sensor. Okay, the main parameters that are normally acquired in structural health monitoring are the strain and also temperature. The common electrical sensor used, okay, is the foil strain gauge. So we compare this sensor to the FBG sensor. All of these specifications were obtained from the website. Okay, now we look for the strain sensing performance. For the first two, the resolution, also the strain range. Okay, we can see here more or less both fiber grating, also foil strain gauge have about the same performance. However, the further below, if you look at the other characteristic, okay, there are big difference in terms of the size. For example, optical fiber has a much smaller size. Okay, this is one of the main advantage. And then for multiplexing capability, okay, single optical fiber can accommodate between 10 to 1,000 sensor per channel. Okay, depend on the technique that we have discussed previously. However, for foil strain gauge, it is not able to be multiplexed because each sensor has its own conditioning circuit. So this is a huge limitation for the conventional foil strain gauge sensor. Okay, other favorable advantages are the weight, okay, the distance where optical sensor can cover, the EMR resistance, which are also very important in many applications. Okay, figure on the left side here shows the comparison in terms of the size between foil strain gauge and also fiber optic sensor, while figure on the bottom right shows, okay, the difference in terms of the cabling requirement. First, to install 21 foil strain gauge, okay, compared to the cabling that required to install, okay, more than 600 fiber optic or fiber bright grating sensor. Okay, these are advantage of fiber optic sensor are really crucial for many applications. Okay, now I will share some of the applied research work that carried out at the University of Technology Indonesia. Okay, basically in return, we do both fundamental and applied research. In the applied research work, we involve with the composite, geotechnical, aeronautic, high power plasma science, and also medical wearable devices. I just want to highlight the challenges working in the applied fiber optic sensor research. Normally in the applied research, our job involved with a various field of knowledge. So one of the challenges is to understand some of the fundamental, the specific problem and requirement of the other field of area. Okay, that's one of the challenge. Another challenge is that each application has its unique issues, or okay, it require a unique deployment technique, okay, that need to be fully understood. Okay, each of the application also requires us to develop specific problems, okay, or step, okay, in order to implement the fiber optic sensor. Okay, so the first application I did involve with application of fiber sensor for monitoring of fiber reinforced polymer composite. The structure shown here, structure shown in the figure here is known as the top head stiffener. This is mainly used in construction of high performance sailing boat. Okay, here the grating was embedded directly into the composite at various locations, and then underwent a vacuum infusion process. This embedded sensor was successfully give the measurement of interlaminar strain, which give the indication of the progressive failure happen inside the composite during mechanical test. On the figure on the right side, okay, I also involved applied research in geotechnical field in order to investigate soil movement at slope terrain due to water infiltration and also vertical loading. Okay, this topic is important for Malaysia because Malaysia has many potential landslide areas that causes by rainfall. Okay, about 20,000 potential landslide areas available in Malaysia. So in this study, the fiber grating sensor were installed in a slope model, okay, shown by the figure on the right side, and the embedded sensor successfully reveal many interesting characteristics of strain distribution underneath the slope terrain. Another application that I involved in is in the aeronautic field, where optical fiber grating sensor were used to measure air pressure, of aircraft wing during wind tunnel test. Array of fiber gravity sensor were installed by a surface attachment across the aircraft wing in order to measure air pressure at various positions. The optimal result shows that the measured air pressure coefficient is almost identical to the result from the conventional pressure sensor. Another project is involved with the high voltage measurement of a partial discharge from high voltage transformer. Okay, this is also show that the fiber optic sensor able to provide reliable output during the phase resolve partial discharge test. Another research work, fiber optic sensor was applied in temperature profiling inside plasma reactor. Okay, this plasma reactor was used for treatment of volatile organic compound. Okay, temperature profile is important in order to determine the effectiveness of the process. Okay, also involved with development of wearable device for non-invasive measurement of human body parameter. One of the recent project is to develop flex sensor to monitor range of motion for human joint. One interesting finding, okay, is that the use of graphite in silicon packaging has improved the repeatability of the sensor. It is shown by the graph with the black line, which has a very small variance. Now I'll give a closing remark on the obstacles that generally encounter in embracing fiber optic sensor technology, and then on the potential area, and also finally a conclusion for this presentation. Okay, one of the major obstacles of embracing fiber optic sensor is the cost is comparatively expensive compared to the electrical sensor. Then there is also lack of standardization or regulation for the usage of a fiber optic sensor. Okay, then another obstacle is to operate the system. Okay, one need additional skill and knowledge. Okay, require like a training in order to operate the equipment. And in general, most people also not familiar with optical fiber technology. Due to the unfamiliarity, most people are skeptical. They are looking for the previous track record, and there's not too many track record available for fiber sensor because it's a very specialized and niche. Other obstacle are compatibility with the existing equipment. Okay, finally, the market of fiber sensor are fragmented, which means that a majority of companies are small and medium companies. This also brings some issues such as a lack of R&D spending, and also companies are vulnerable to economy downturn. Okay, potential areas. Among the potential areas are in the medical, food industries, environmental sensing, distributed sensor, and high definition distributed sensor like OFDR, which I already explained in this presentation. Also, more effort to make needed in order to make the fiber optic sensor more portable and smaller. Other approach to make the fiber optic sensor portable, smaller, and more efficient is by implementing the integrated fiber optic sensor system, which I will explain in the next slide. Okay, on the integrated fiber optic sensor system, both figure here shows the similar equipment, one which is the fiber gravity interrogators. Figure on the left show the system that I used previously. It is a system which was developed from the scratch. Okay, by combining components like optical fiber, splitter, detector, Fabry-Perot filter, and amplifier in a big casing. Okay, this picture was taken about 15 years ago, and the system is still working up to this day. Okay, but recently a company known as Hyperion produced an integrated system that combined all of these components into a single board. Okay, and definitely the integrated system approach like it has significantly improved many aspects of the system performance. Okay, like it increased the functionality, capability, reliability, and portability, and also it reduced the size and power and also cost. In future, more and more integrated fiber optic system will be realized. So for the conclusion, all right, I have presented the advanced application and techniques of fiber optic sensor. Fiber optic sensor has its own specialized application in the key industries, and the role of fiber optic sensor could not be replaced by other technology. So fiber optic sensor will remain relevant, and in fact, it will further expand due to the emerging application and its technological advancement. Okay, finally, among all of the techniques available, okay, the distributed sensor, which is FBG plus or FDR, suit many applications, and in fact, it has huge potential because of the advantages of a huge sensor count, okay, high spatial resolution, and also a relatively good sensor coverage. Okay, thank you for listening to my talk today. I hope the information that I share will be beneficial to you. I pass back the session to the moderator.
Yeah, thank you very much for the insightful talk, Professor. So in this talk, Professor already stated that fiber optic sensor have so many huge potential, it's so many application. So now we move to the Q&A section. We have 8 minutes left until 10:20. So for the participant who would like to ask the question, please use the raise hand function in the participant menu on the Zoom and or type the question in the chat box. I will call your name and please deliver your question by unmuting and turning on the video. Any question from the audience? Okay, Mr. Johnny Simatupang, please deliver your question.
Thank you for the opportunity to give a question to Associate Professor Asfu. Yeah, it's so interesting to see the presentation, and especially when you talk about the fiber optic sensor still relevant until now. My question is, what about another area? Do you have any idea to which area that fiber optic sensor can be applied beside those you have mentioned here, Professor? And also, do you have any experience in doing the experiment in FBG sensor, apply in your maybe in your lab or in your country in Malaysia? Thank you.
Okay, thank you for the question. I will try to answer it. Okay, basically there are many areas. Okay, some of that of the area maybe also not keep track with that, but I think that currently there are many other sites that we can do research in optical fiber sensor, especially with the widespread use of the artificial intelligence. This is one of the area that people are going into, because when we involve with fiber optic sensor or a sensor research, it will involve with the signal, okay, signal processing. Okay, signal processing in a fiber optic sensor is crucial because the signal always have a lot of noise inside. Okay, so in order to make a correct decision, okay, in order to determine something in the system, so okay, many research work already implemented artificial intelligence in a fiber optic sensor. That's one of the area. And also one of the important area, I'll not mention in the slide just now, is in the environmental sensing. Okay, but that technology normally what happened in Malaysia, like a pollution, people dump chemical in a river, for example, and that it release a very dangerous gas to environment. So that technology may not use a fiber bright grating sensor. It use like a spectroscopy sensor, which use a laser, because when we use laser, it can cover very large range. Okay, I mean, because we need to expose the laser to the gas and also the chemical. Okay, to your second question on the research, okay, in UTM, apart from fiber bright grating, okay, normally the fiber bright grating that is used in the applied research is not manufactured by ourselves. Normally we outsource the grating, and then we install to our system. We have the fiber bright grating interrogator, have 8 channels, and I can use we can use to interrogate as many as 200 something sensor at the same time. Okay, but we also develop many other type of sensors, like the interferometer sensor, and also spectroscopy sensor. And some oil sensor also we also apply it in certain application, like in the high voltage to measure the transformer oil quality, for example. That's one of the research that we do in UTM. If you're interested, then we can also discuss after this, inshallah.
Thank you so much. Yeah, I would like I would interest to make collaboration later on. Yeah.
Okay, thank you.
Thank you. Thank you.
Okay, thank you for the comment, Professor Asrul. I think we have a question from the chat box. The first one is from Mr. Michael Purwadi. What about the resolution and accuracy of pressure measurement using FPG? Or please, you can directly answer the question.
Okay. In our slide just now, I show. Okay. For strain, normally the unit of the accuracy about 0.5 microstrain. But pressure, maybe I need to check it exactly. All right. And then the next question is what? Sorry.
One question. So, Mr. Purwadi, do you have any comment about the answer?
Yes, thank you, Mr. Chairman. So my question is about the resolutions and the accuracy of the measurement of pressure measurement using FPG.
Yep.
Yeah, we would like to know the resolution because we need the resolutions very high, up to 10 power minus 6 accuracy, and the resolution and the accuracy is about 10 power minus 6 or 5. Thank you. So if it's possible.
Thank you for the question. Okay, it depends on the techniques that we use. For pressure sensing, normally the best technique is based on the interferometry type. Okay, that was my PhD topic. Basically, basically is used the high sensitivity is used for the hydrophone application. Yeah, the requirement for the hydrophone is about 10 micropascal. I mean, the minimum detectable pressure is 10 micropascal because that is the condition known as the deep state zero. I mean, the condition when C at a very calm condition. So basically, a fiber optic sensor can achieve that level. Okay, because that's why it is used in the hydrophone. But the exact number, I need to check with the paper. I already forget that one.
Okay, thank you very much, Professor.
Okay, thank you very much, Professor. Maybe this is the last question because our time is limited. This is from Mr. Marlin in the chat box. Dear Professor Asrul, thank you for the presentation. I have two simple questions. The first one is how much the cost for a single system, let's say for wearable medical devices. And the second one is what is the maximum penetration depth of the fiber optical sensor for biological tissue case, for example, detection of subcutaneous adipose tissue. Is it possible?
Okay, for the first question, okay, the cost of a single fiber Bragg rating sensor currently sold in Malaysia, manufactured by one university in Malaysia, is around 100 ringgit Malaysia, and then plus like the packaging that required, maybe is around another about 200 ringgit actually around that price. Okay, and what is the maximum? Okay, the second question here is it's outside my expertise. This is a different field actually. You also use a laser in this case. Maybe I will discuss with you later on because this is slightly outside my field actually.
Okay, Mr. Marlin, do you have any comment?
Yeah, hello. Thank you, Prof. Azrul, for your answer. I understand what your answer about the price. I think it's not so expensive, right? So, and then the second one, I think it is quite similar with your presentation on the previous slide, if I'm not mistaken. I think earlier slide at the second or third page.
Okay. What is the title of the slide?
Is it about the medical devices?
Oh, okay.
Yep.
Yeah.
Yeah, this one. The right side. Oh, okay. This is the body temperature. Okay. Yeah, I see. So, is there any penetration depth on this sensor?
Okay.
So, I think, yeah, it's just non-invasive.
Okay, so
Okay.
so this one is attached outside human. Okay, so
Oh,
it
I see.
at the glove, for example. So it's not invasive technique. Yeah.
Oh, okay. Okay, I understand. Thank you.
Thank you.
Okay, thank you very much. I think we reached of the end of the session. So from today's discussion, we can summarize that fiber optic sensor have so many potential and advantage. However, they also have some disadvantage, like it's expensive and have other drawback that to overcome and to do research about that. So before we conclude this session, on behalf of the committee of ICRAMET 2023, we would like to thank and give the token of appreciation awarded to Associate Professor Insinyur Dr. Azrul Izam Asmi from the University Technology Malaysia in recognition for the delivery of keynote talk in the 12th International Conference on Radar, Antenna, Microwave, Electronic and Telecommunication, ICRAMET 2023. We have learned a lot from his speech today. We hope we can do some research together with you and have the collaboration in the future. Thank you very much, Professor Azrul. Time I give to the MC. Thank you very much.
Welcome. Okay, thank you.
Thank you to Dr. Eri Dwi Kurniawan and Professor Azrul Izam Asmi for the first keynote talk of ICRAMET 2023. Shortly, we will have a morning break for 10 minutes. Then we will begin the parallel session 1, 2, and 3. Later on, the second keynote talk is starting at 1 p.m. GMT plus 7 after the lunch break. We encourage you to stay logged on during the breaks. Also, some reminders for presenters. First, to keep the naming convention according to the guidelines, so our host can monitor if any presenters are in the incorrect rooms. Second, to keep logged on even during the breaks. Third, for the presenters that are in their assigned sessions, please turn on the video for the whole session, including when you are not presenting. Fourth, please be reminded it is compulsory for presenters to be present at their respective question and answer sessions. Do not forget to fill in the attendance form as a presenter when you are in your own session. Please have your presentation slides ready for the question and answer sessions. For all the participants who want to ask some question during the Q&A sessions, please use the raise hand menu that can be accessed from the reactions menu in your Zoom application, or type your question in the chat room. For the breakout rooms, the presenters will be directly assigned by our host according to the schedule shortly. The parallel session 1 will be held in the breakout room 1, parallel session 2 will be in the breakout room 2, and the parallel session 3 in the breakout room 3. For the rest of participants, you can switch between breakout rooms to find presentation that interests you. I would like to thank again all of the speakers, panelists, and attendants for taking the time to be here today. Thank you and enjoy the conference.
Can you imagine? What we call communications is just part of the electromagnetic spectrum composed of countless radio waves, visible light, X-rays, microwaves, UV, and more, flooding the Earth. Everywhere. These invisible communications convey information at tremendous speeds. For example, over 10 gigabps for 5G wireless and over 400 gigabps for wired backbone networks. At this speed, 15 hours of 4K video can be sent in just 1 second. Although communications are invisible, they spread everywhere through society. Testing means capturing these invisible communications. Testing has long been the core of Anbitsu's business. Anbitsu was founded in 1895, the year Marconi successfully demonstrated the world's first wireless telegraph, marking the birth of modern wireless communications. To start, Anbitsu developed and manufactured wireless telegraphs, and then diversifying to meet the progress in communication technologies.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Welcome to the parallel session 1 of ICRAMET 2023 with topics control system, robotics, and mechatronics. First, let me introduce myself. My name is Bondan Swandi. I'm a researcher from Research Center for Electronics, National Research and Innovation Agency, Indonesia. So today we will have 5 presenters. The first presenter is Mr. Michael Purwadi. Are you with us, sir?
Yes, I'm here. Thanks. Sorry. Yes, I'm here.
Okay, thank you. Thank you. The second one will be Mr. Furis Yudo Setiawan Paise. Are you present?
Yes, I'm here.
Okay, thank you. The next presenter will be Mr. Eko Joni Pristianto. Are you already with us, sir?
Yes, I'm here, Mr. Bondan.
Okay, thank you. And the fourth presenter will be Mr. Jimmy Abdul Kadar. Are you here, Mr. Jimmy? Okay, thank you. And for the last presenter in this session will be Mr. Raka Pratama. Are you already present, Mr. Raka? Mr. Raka? Okay, maybe he will join us later. Okay, there are some notes and rules that I have to mention to all the participants. For all presenters in this session, please keep your video on until the session finishes. We will have screen capturing session by the end of the presentation or when all participants are present. Also, please fill out the attendance form during this session. Our co-host will send you the link in the chat room. Please have your presentation file ready in order to answer some questions from your slides. The time For each presenter is 15 minutes long. So there will be, your videos will be played, and then we will have a question and answer session after your videos. And please make sure you are present during your question and answer sessions. For the participants who would like to ask question, please use the raise hand function, or you can use the chat box and write your questions in the chat box. Okay, now let's start with the first presentation. The first presentation from Mr. Michael Andreas Purwadi. Your video will be played just now.
Thank you, Mr. Chairman. Good morning, ladies and gentlemen. It is an honor for me to present to you our work entitled Fast Response Nonlinear Injection Control of Isolated DC-DC Converter for Cable-Based Seabed Observatory Platform. This is a continuation of our works presented last year in ICRAMET 2022. As you know, Indonesia is an archipelago country with the ocean covering more than 70% and is the gateway of the exchange between Pacific and Indian Ocean. Indonesia Inner Sea plays an important role on the world climate, especially in the present day, where climate change becomes the greatest threat for humankind. Our vision for ocean observatory system is shown in the right picture, where submarine cables connect a land station onshore that function as powerhouse and the data hub to several ocean bottom units or OBU. At this OBU will be placed interchangeable sensors and acoustic communication hub to receive data from autonomous mobile sensors. The electrical current controlled will be sent from the powerhouse onshore to the OBU as energy necessary. The constant current is chosen because it is more robust faced to the rupture of the submarine cable. The power supply in the OBU will convert this constant current to a constant voltage through a Zener diode. The Zener diode is chosen as high voltage in order to decrease the current from landing station to obtain the power needed by OBU and to minimize the loss of power along the submarine cable. The cable can have tens to hundreds kilometers long. However, the power dissipated by Zener varies with its load. When the load is low, then the Zener will be hot. Unfortunately, the load will not be constant. It depends on the sensors actually present in the OBUs. So we propose a current feed isolated DC-DC converter as shown in the picture to replace the Zener diode. The converter will chop the constant current such that the mean of current switch to the power needed by the OBU. The control strategy used by the converter is a nonlinear injection control with additional integral proportional linear controller proposed in this work. The control strategy is shown in the equation below. The transfer function of the converter, including its control algorithm, is a second-order system with a zero shown in the top left as equation 1. One parameter of the dynamic equation is the exponential decaying zeta omega n that represent the speed and delay of the response. This parameter depends largely on proportional gain Kp and slightly to the load R0, RO. So we can compute the gain Kp according to user need. The right picture shows the evolution of zero and poles, which depend on parameter zeta. Zeta is always positive, that's shown in the equation 3. When it is less than 1, then the zero is negative, less than minus half of omega n. The poles are complex number, so the response will be oscillating. When the zeta is bigger than 1, then the zero evolve from minus half of omega n to 0 in this area. The first pole will become more to the left or negative, but the second pole will become lesser negative and tend to 0. The same with the zero of the system. When zeta is big enough, the second pole and the zero will kind of compensate one to another, as shown in equation 4. This is the decomposition of transfer function when zeta is bigger than 1. We can see that when zeta is big enough, then the second gain, S2, become close to 0 as shown in equation 6. If it occurs, then the system will become a first order-like system with gain S1. Fixing the value of zeta, we can determine the gains K1, Ki according to equation 3. We did the simulation using MATLAB Simulink Simscape. This is a mixed physical and behavior simulation. Block A and B contains the nonlinear injection that linearize the system. The block C contains the integral proportional controller. The table contains the parameter of simulation. Switching frequency is 10 kilohertz. The gain Kp is set to have the exponential decaying parameters 10 times faster than the natural response of the load. The gains Ki is computed such that the response will have overshoot with zeta close to 1 and non-overshoot with zeta sufficiently big. The graph in the top left shows the output voltage with different value of zeta. The blue line is the response natural of the system. There was a load change as big as minus 75% at time 0.003 seconds. The graphic in the left below shows the rise of current during the load change. At the center below, it is the graph of input duty cycle of converters. We can see that the black line representing the duty cycle when the gain, the integral gain is big or the parameter zeta is close to 1. It can goes up to its maximum value, which is 1000. So it can be saturated if the gain Ki is bigger. So the future investigation on control algorithm should avoid this saturation as a constraint. We simulate also two OBUs in series with different loads. The first one in the blue line is 100 ohm, and the second load in the orange line is 20 ohm. Using the same value of gains, proportional gains and integral gains Ki, the system is still stable phase to load changing. As conclusion, we can obtain the faster response of the system with proposed additional integral proportional controller, whose gains can be calculated according to the user need. The coefficient zeta should be sufficiently big to avoid overshoot. The system is still stable when several converters are put in series in phase of load changing of each OBU. For the future work, new optimal control should be designed in order to take into account the maximum value of duty cycle. Thank you, Mr. Chairman, ladies and gentlemen, for your attention.
Okay, thank you very much, Mr. Purwadi, for your presentation. It's very interesting. So is there any question from the audience? If you have some question, please raise your hand or you can type your question in the chat box. If there are any question or maybe one question, simple question from me, Mr. Purwadi. So,
Sure.
yes, in the first place, can you explain why you use DC voltage, high voltage in spite of AC? And next one, what is your consideration of using this kind of PI controller compared with
Recording in progress.
Thank you.
Thank you, Mr. Chairman. So the first question, why we use DC voltage, DC current in place of AC current, because the distance of the cable is around 54 kilometers. So the cable itself become more complex when we use the AC current. With the AC current, we have to take into account all the capacitor along the cable. So it become more complex to manage. The second one, why we use integral proportional controller? Yes, because this is we use switching power supply with a lot of noise in the current. So if we use derivative controller, it will amplify the noise in the high frequency. So it is enough if we use proportional and integral. Integral is known to have a characteristic for annulation of the static error. Thank you, Mr. Bondan.
Okay, thank you. One last question. I think we have one question in the chat box. What component most suffered from environmental conditions that result in disturbance or model uncertainty? Yes. Can you
Thank you.
answer? Yeah.
What component most suffered from environmental condition that resulted in disturbance or model uncertainty? I think it's the cable itself, because the cable is the cables goes from onshore in the coastal area down to the deep sea. So the temperature is not constant along the cable. So the resistance, the parasitic resistance and capacitor is not constant also along the cable. So I think it is the most impacted by the environmental issue. Thank you.
Okay, thank you very much, Mr. Purwadi. I hope it answers your question. Yeah, MITDS no Kohai. Because of the limitation of time, we'll we go to the next presenter. For the second presenter is the video will be shown now. Please.
My name is Foresido Setiawan Paise. I'm doctoral student of Electrical Engineering Institut Teknologi 10 November Surabaya. I will presentation paper with the title Improving Load Power Sharing Accuracy in Standalone Microgrid DC Networks using Intelligent Adaptive Troop Control based on fuzzy local method employed to ensure equitable distribution of load current in DC microgrid application. The traditional drop equation, the drop characteristic shifted then is modified to reduce the current sharing error, and the current sharing reference is determined on the basis of the ratio of its rating to the load current load. Previous research study have not discussed the performance of voltage control and current control used in drop control. Voltage control and usage control proportional integrator controller as compensation error where its performance need to be improved. We propose adaptive drop control based on fuzzy logic control as error compensation. This is microgrid DC system configuration with 3 generators and 3 DC converter, and connect to bus DC and connect to DC load. And different line resistance value 1, 2, and 3 as influenced by conductor lag and temperature and others. This cause unbalanced power sharing between plants, so adaptive drop control is needed. This is the equivalent circuit of drop control. Control DC generate 1, DC generate 2 as the generating resource. RD1 and RD2 drop resistance used to regulate power sharing between DC J1 and DC G2. Then airline 1 and airline 2 are conductor resistance which not the same value. From this equivalent circuit can be written the following equation: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. The vertical axis as the bus voltage, and horizontal axis and converter current. If the drop resistance minimize, delta current becomes large. Delta current become better. Delta I becomes large. If RD large, delta I becomes small. So the setting use fuzzy logic control. This is a picture of adaptive drop control. Adaptive drop control has a primary control and secondary control. The primary control adjusts the value of RD following the change current converter current. Airline change, the converter current also change. So it will change the value RD. It will be detected by control system, so the pulse modulation put with modulation value can be adjusted. If the airline value rise, the converter current will drop. Converter current will drop. Then the pulse width modulation will be enlarged. As result, the bus voltage will drop. So secondary control is needed to restore the pulse width modulation value. Fuzzy drop resistance setup. Madam fuzzy logic control is employed to calculate the drop resistance for all converter system. The I line current reference as described in equation 14 is utilized as the input for the fuzzy logic control, while the resistance drop coefficient is obtained as the output. This is question 14. The input-output characteristics of the fuzzy logic control proposed in this study are shown in figure 7 below. Each converter units drop resistance and can be modified to lower the nominal power sharing error among the DC generating source based on the difference in the current value on each channel, which is the input reference value. It will determine the output of the fuzzy system in the form of an increasing or decreasing drop resistance value. This is there are three member function: negative, zero, and positive in input and output. Next, this is a block diagram of adaptive drop control algorithm on MATLAB or Simulink. The same microgrid model on MATLAB Simulink. Okay, simulation result: the converter parameter, input voltage 48 volt, input voltage 100 volt, converter inductance 2 millihenry, converter capacitance 470 microfarad, frequency switching 10 kilohertz. Test scenario with changing loads, DC generation system performance testing was carried out by comparing conventional drop control using a fixed nominal drop resistance equal to 1.2 ohm. And then airline 1 0.25 ohm, airline 2 0.6 ohm, and airline 3 0.1 ohm. The RD line resistance value for this generate. The test scenario is carried out by changing the load value, which varies based on time. The rate load 1 second varies from 1,000 to 100 watt. All the way up to 750 watt, and then add 2 seconds. The load follow the change from 750 watt to 900 watt. As the result of testing the performance, power distribution, and load bus voltage using conventional method or without adaptive drop control. This is a performance of power distribution. Power distribution is unbalanced, yeah, and there is a voltage drop through 95 volt, 95 volt, yeah, 95 volt. This performance of bus voltage. The result of testing the power distribution perform under variable load condition with adaptive drop control is a performance power distribution balance power sharing, and relative stable voltage of 100 from the generators. This assertion is supported by test results that demonstrate effective power distribution even in the presence of firing line resistance and load power change. Simulation result obtained using MATLAB simulating indicate that the fuzzy logic based adaptive drop control achieves a balanced power distribution ratio of 1 to 1 to 1 across 3 DC generators. Furthermore, the voltage restoration response at the bus is the relatively faster compared to conventional drop control methods with exhibit voltage deviation range from 6.4% to 3.9% of the nominal 100 volt voltage level. Thank you.
Okay, thank you very much, Mr. Asli. Thank you. For the question and answer session, I will open one question from the audience. Is there any question? Okay, there is one. Okay, there is no question from the audience, so maybe one question. Mr. Pawadi, you have question?
Yeah, thank you, Mr. Chairman. So I have written also my question in the chat. My question is, how about the efficiency of the converter? That is the utmost important factor in the solar panel system electrical generator. Thank you.
Okay, thank you very much. Please, Mr. Forrest. Yeah, please, Mr. Forrest, to answer the question.
Okay, thank you. Sorry, I can speak English well.
That's okay.
Okay. For efficiency PV solar cell, I don't use PV, but this DC resource.
Yeah, I mean the efficiency of converter, Pak.
Yeah.
Kan konverternya sekarang pakai itu ya, pakai
converter bus.
fuzzy logic ya,
Yeah.
Untuk merubah RDI kalau saya nggak salah tadi ya.
Yeah,
RDI-nya menjadi lebih besar gitu.
Yeah.
Supaya sama dengan yang lain. Gimana kira-kira, Pak?
Ya, jadi sorry saya kan tidak begitu fasih berbahasa Inggris, saya bisa menggunakan bahasa Indonesia ya. Oke.
Yes, please.
Oke, jadi untuk efisiensi perubahan RD-nya itu menggunakan adaptive drop control. Jadi apa namanya? saya tidak bisa tampilkan gambarnya, tapi mungkin bisa saya jelaskan bahwa setiap untuk pengaturan RD mengikuti perubahan arus konverter. Jadi kalau airline-nya berubah, jadi arus konverter juga akan ikut berubah. Jadi untuk efisiensinya cukup bagus karena dari hasil simulasi power sharing-nya itu mendekati 1:1:1. Jadi dari perubahan beban yang diuji, beban 1.200 itu dibagi rata, jadi 400 watt, kemudian saat perubahan ke 750 itu juga dibagi rata menjadi 250. Seperti itu, Pak. Jadi di sini kontrolnya ada pulse width modulation atau PWM itu kan bisa diatur. Jadi jika airline-nya naik, arus konverternya kan akan turun. Jadi pulse width modulation ini akan diperbesar. Jadi akibatnya tegangan bus akan turun, sehingga karena turun maka perlu adanya secondary control untuk mengembalikan nilai pulse width modulasi PWM-nya. Jadi seperti itu.
Oke Pak, terima kasih.
Okay, thank you very much, Mr. Forrest. Maybe I will explain a little bit the explanation from Mr. Forrest in English. So for the RD efficiency using the adaptive drop control, the RD efficiency is using the adaptive drop control. So if the airline is changing, then the current control is also changing. And from the simulation, the power change result is close to 1.1 in comparison. Okay, thank you very much, Mr. Forrest. I think the session for you is end now because the limitation of time. I'm sorry for the METDS Nokohai. We don't have time to answer your question. So before we continue to our next session, I would like the presenter and the audience to open camera because we want to take pictures of the audience and the presenters in this session. So please open your camera. And please, the host, Mr. Berlian Surya, to take the image. We have 2 pages. I will count from 3 to 1 to take the pictures. 3, 2, 1. Okay, thank you. And for the second pages, please, I will count again from 3 to 1. 3, 2, 1. Okay, thank you very much for the breaking session. Okay, now we will go to the third presenter. Our third presenter is Mr. Eko Joni Pristianto. So we will watch his videos just now. Okay, please play the video.
Assalamualaikum. My name is Eko Joni Pristianto from Research Center for Telecommunication, National Research and Innovation Agency of Indonesia. On this occasion, I will present a paper entitled Implementation of Kalman Filter for Stabilizing Ultrasonic Sensor Reading on Distilled Ethanol Level Measurement. Introduction. As we already know, Kalman filter is a technique used to estimate the value of a parameter or state in a certain time. The Kalman filter algorithm is widely used in various fields. One of them is used to remove and use the data from the sensor reading process, such as noise. The application of the Kalman filter has been studied to reduce noise with the DXT22 and IM35 temperature sensor at room temperature. Nowadays, the high order of Kalman filter is used for the Kronecker algorithm in a non-linear system and produce better accuracy, tracing, and testability. In previous research, an instrument for measuring the total ethanol product resulting from the distillation machine process was developed. This instrument measures ethanol content using specific gravity approach. The system of ethanol level measurement include a temperature sensor is used to measure the distilled liquid temperature, a sensor is used to measure the weight of the distillation liquid, and an ultrasonic sensor is used to measure the height of the distilled liquid. The addition of magnetic stirring is used to stir the liquid before measurement, so that the ethanol liquid is homogeneous and microcontroller to process sensor data. The height of the distilled liquid is converted into the volume by knowing the storage container diameter. The volume value qualified due to the distillatory vibration during the ultrasonic sensor work. Another disturbance is from the external signal from other device and the complexity of the measurement made. This problem could be solved by designing a digital filter system, such as the Kalman filter, to eliminate the deviate value. Therefore, this paper aims to optimize the ultrasonic sensor reading of ethanol level measurement using a Kalman filter. Method. Figure 1 show the block diagram of the ethanol measurement system equipped with a Kalman filter. Data reading from the sensor will be filtered by the Kalman filter algorithm. The calibrate is using the calculate equation. Furthermore, the volume is changed into specific gravity and modeled by mathematical formula. Finally, after process the data, the ethanol level will be shown on the user. The sensor data used in this research is the XT-SR04 ultrasonic sensor, which are used to measure and detect the height value of the distilled liquid. The Kalman filter was used to filter the deviation result in the final data reading from the sensor. The deviation result was measured by comparing recent data result with the previous one. The filter data will be processed and calibrated by equation 1. Following, E equal to P R square T, where V equal to distillation volume value, P is constanta, R equal to tube container radius, and T distill level or sensor result. Applying the volume value to determine the density value or rho, to determine density to concentration value, the regression formula is used by comparing the real measurement data with the calibrate pedometer instrument. The correlation between the specific gravity versus the concentration value result are square of 0.9997 based on this experiment. The ethanol concentration will be calculated according to previous research with equation 3 following, where Y equal to alcohol concentration value and X equal to density value. The reading of the measurement system are calibrated with the reading of the pedometer actual value at the some concentration value. The calibration process has been discussed in the previous paper. Figure 2. So the use of the Kalman filter algorithm in the system. The sensor will read and point to the distilled liquid level while the system is running. Furthermore, data will be processed by the Kalman filter algorithm. The data value which have a small deviation will be further calculated by mathematical equation, and the result will be displayed. Meanwhile, the data value with a H-log deviation, then the result will be processed in the Kalman filter equation again. The Kalman filter is shown in figure 3, consists of two steps that are one prediction with done after initializing correction and initializing correction after prediction. The workflow of the Kalman filter so that prediction process was carried out with correlation data result after initializing data. Meanwhile, the correlation process can also have carried out with prediction data result. Both processes are interconnected and affect each other. The Kalman filter equation at the discrete time was the adopt from earlier paper entitled Kalman filter algorithm designed for XTSR04 ultrasonic sensor data equation system. And so as follow. Kalman filter is an algorithm that can interpret the sensor data result with a dynamic and changeable. the Kalman filter can predict and correct the data at the same time. The Kalman filter algorithm in this research was just manually. The Kalman filter algorithm consists of two main process steps, namely state prediction and correction phase. In the beginning step, the estimator X sub k and P sub k was initialized. Then go to prediction state. Project state ahead according to equation 4, and project error covariance ahead to equation 5. Subsequently, go to correction phase. In this state, Kalman gain is computed according to equation 6. Then update state estimation value with measurement factor zk according to equation 7, and update error covariance according to equation 8. The process of prediction and correction occur continuously to generate the estimate value of the measurement. Thus, the measurement noise that appear in the sensor system can be eliminated. The R and Q value is get from reference that use similar ultrasonic sensor XG SR04 that apply to our system. The metric Q can be determined arbitrary, whereas the metric R is determined based on a variant of the raw data measurement distance. So that it can be obtained parameter value from the system are as follow: K sub k equal to 0, X sub k equal to 0, P sub k equal to 0, X equal to 1, and then F equal to 1. The result give convariant metric of the measurement noise Q equal to 0.0001, and covariant metric associated with the noise state R equal to 5999.3955. Using the R and Q value to our alcohol concentration measurement system, it shows that the error of the reading data has very small standard deviation. It means the Kalman filter is successfully applied to our filter to eliminate the error measurement. Research and discussion. The performance of the Kalman filter algorithm can be seen in an experiment to measure that solution from distillation. That measurement system reading was calibrated with hydrometer reading or true value at some concentration value of sample and repeat 500 times with the present error of 1068%. The result of setting the R and Q value in the Kalman filter equation is performed in figure 4. The square blue line illustrates that sensor result without the Kalman filter, while the sensor result with the Kalman filter is colored with the round red line in figure 4. The blue line can indicate a significant deviation with a standard deviation value of f.89, which has a fluctuation trend of ethanol concentration. Meanwhile, then red one has a slight deviation with a standard deviation value of 0.45 with a stable ethanol concentration tendency during the process. In figure 5, the graph presents another measurement of the Kalman filter application in an ultrasonic sensor. The data was from 25% ethanol solution. The Kalman was stable in this measurement and got the result at better measurement of figure 4. The Kalman figures ultrasonic sensor measurement in solution. The solution was not stable because of the disturbance from the distillatory. The solution is an end product distillatory. The red one from the data with the Kalman filter has a very stable measurement with a standard deviation value of 0.24 compared to without the Kalman filter with a standard deviation of 9.34. Figure 4 and 5, the part of the hole from the distillation process. Figure 6 represents the data sensor result with 800 seconds of the process with 78% distilled ethanol using the Kalman filter algorithm. The concentration level will increase in 0 until 10 seconds of the process, then constant and stable at 75 until 80% of the concentration level. It could be conclude the Kalman filter algorithm produce a stable and significant result for this still ethanol sensor reading. Conclusion: the design of the Kalman filter algorithm has been done successfully. In this result, the Kalman filter algorithm is used for the prediction and correction of ultrasonic sensor reading for future the solution of an ethanol product in the distillation process. The stable and constant result was obtained from the algorithm, which a Q value of 0.0001 and a value of 5999.3955. This research has a high potential to be applied in food and agricultural science to predict and measure the ethanol content in the food accurately. Here are some references used in this paper.
Okay, thank you very much, Mr. Eko. Yeah. Okay, for the Q&A session, I will open one question only because of the limitation of time. So please, if there is question from the audience, you can raise your hand or okay, there is one question from Mr. Rahmat, yeah, Mr. Rahman, yeah. What are the advantages of the Kalman filter over other approaches in this context? So why you choose this Kalman filter? Please answer the question.
Okay, thank you for your question. According to the Kalman filter algorithm, it used to process the data obtained from the ultrasonic sensor reading on distilled ethanol level. The algorithm can interpret the dynamic and changeable sensor data, predict and correct the data at the same time. The Kalman filter consists of two steps: prediction and initialization correction. The prediction process and initialization correction and the correlation, the result initializing data. The advantage of using the Kalman filter algorithm is in this context that it can handle and minimize noise in the ultrasonic sensor, which vulnerable to noise and produce better accuracy, tracing, and test ability on the nonlinear system. The Kalman filter algorithm can also predict and correct data at the same time, making it more efficient than other methods that require separate prediction and correction step. Okay, thank you.
Okay, so Mr. Rahman, are you satisfied with the answer? Okay, thank you very much. So apologize to Mr. MITDS no Kohai because we don't have we already passed the time. So maybe later you can ask your question directly to Mr. Eko, yeah. So next we will go to the fourth presenter. Fourth presenter will be Mr. Jimmy Abdel Kader. So we can see the video presentation now.
Before we begin, let me introduce myself. My name is Jimmy Abdelkader, and I'm part of research. This research is collaboration between National Research and Innovation Agency and 11 Maret University. And today I would like to present about detection of driver behavior using convolutional neural network with modified inception model. Okay, and this is member researcher. For introduction is, as we know, traffic accidents, which are one of the main causes of death in the world, are usually caused by distraction driving. Distracted driving is condition that diverts of driver's attention from the driving task. Hence, a system that notifies the driver about their condition may help minimize the impact of distracted driver. Machine learning is a branch of artificial intelligence may be utilized to predict the driver behavior in recent years. Advanced in machine learning is called deep learning, have shown promising results in multiform computer vision. Based on computer vision, convolutional neural network or CNN are arguably the most commonly used architecture in deep learning. Studies show that the benefit of CNN is proficiency in extracting relevant feature extraction without human supervising. Adding depth to the CNN will enhance its capability, but having wide networks may be also improve the CNN system. One of the most wide networks is the inception model. The advantage is having a wider network is that it could be done without adding much to computational loads. This aim of the research is investigates the use of wide networks such as insertion on driver condition detection tasks. And also we evaluate our method in two different conditions. Next, this is our prior study. This is the proposed architecture. The convolutional layer is used to find the feature maps. The polling layer is a layer that containing polling operation to diminish the aspect of feature map. Dropout with the rate of 0.2 is used to regulate the network from overfitting. Softmax is an activating function to use to map of the data class output. This is the proposed inception model for detail. And this is the data sample. And this is the dataset description. That the model was evaluated into two condition experiment. The first one is user dependent, that the data is divided into 80% training and 20% testing. Both data contained from all four users. For the second one is the user independent condition. We only use the data from 3 in training, while all data from user are used in testing. This is processing data. Before compiling the model, we normalize the rescale into 224 multiplied 224 pixel and extracted to RGB feature as input to our model. Data augmentation is also applied to training the data due to our small size. The data were zoomed with magnification range to 0.25 times, shifted with the shift range of length and width of 0.125 and flipped horizontally. Now this is experiment setup. The progression of accuracy and loss of the proposed method for user dependent can be seen on the screen. The tiny gap, the training testing set in the last epoch show that the design method is in this test has produced good performance when all participants are in the training set and test set of proposed method for user-dependent experiment can be seen on this slide. The proposed method can easily result in correct prediction C4, C5, C6, C7, C8, and C9. Next, the proposed method can be correctly predict all images into C0, C2, C4, C5, C7, C6, C7, and C9. In this experiment, misclassification happened because some behavior have similarity with other behaviors, as do their behaviors that we have not yet to be mentioned. Of course, this makes it difficult for proposed method to differentiate this behavior. This performance compares with convolutional CNN architecture for use-dependent experiment. The proposed method performs better than the conventional CNN and tested for fewer parameters. The loss the conventional CNN is about 4 times bigger than the loss of proposed method. Beside that, The conventional CNN tends to be overfitting because of the tight gap between the loss and its training set and its test set. Overfitting happens because the high complexity owned by the conventional CNN can only be applied into limited dataset with a few class labels. More work on hyperparameter tuning may be needed to improve CNN to conventional CNN. This is progression of accuracy and loss of proposed method for use independent can be seen on the screen. The enormous gap between the training and testing set is the last epoch show that the proposed method cannot work better than new participant was used in test set. Besides, the testing loss in inversely proportional to number of epoch. This indicates that the user-independent model cannot learn driver behavior well. Conversion metric on the proposed method user-independent experiment can be seen on this slide. The proposed method can result correct prediction in C1 and C4, but the number of correction prediction too small compared to the image data on those behavior. The proposed method can be correctly predicted all images in C7, but there are some image data in other behavior that misclassification of behavior. And this is performance of comparison with conventional CNN architecture for user independent experiment. The proposed method performed better than the conventional CNN in the test set. Although the accuracy gap is small, its loss gap is enormous. The loss conventional CNN is about 4 times bigger than the loss of proposed method. However, the proposed method for user independent does not perform better than the one of user dependent. Besides, the proposed method can be, however, the proposed method for user independent does not perform better than the one for user dependent. Besides, the proposed method needs to be more balanced in the setup because the loss gap between its training set and its test set is very big. For conclusion, the trainable parameter in the proposed method can be reduced by up to 99.21% compared to the conventional CNN architecture. The proposed method can have a better performance than the conventional CNN architecture when used on datasets divided based on the amount of data. The proposed method ran into decrease in performance of 66.30% when the driver was used as input. This performance decrease happened because the proposed method automatically extracts all the features of the image, including face, so the model built on the proposed method tends to overfit. Okay, that's all. Thank you for attention.
Okay, thank you very much, Mr. Jimmy, for the interesting presentation. So now we are in the Q&A session. Any question from the audience? Okay, we have one question in the chat box from the IMETDS Nokohai. What about the training time comparison? Please, Mr. Jimmy, can you answer? The training time comparison.
Okay, thank you. Training time comparison is more about no time for comparison. timing about user dependent and independent. This method is used to compare the training time for what the proposed method is better than the conventional CNN. So maybe answer my question. My answer. Hello. Hello.
Yes. Yes, Mr. MITDS, is it answering your question?
Okay, thank you. So, which is faster?
Faster.
The training time, which is faster? The propose or the CNN?
Oh, this is not about faster or not. This is accuracy.
Yeah.
Use accuracy.
Okay, okay. So,
Accuracy much better than a proposed method.
Okay, okay. Okay, so you will not measure the training time, right?
The processing and
The processing
time.
processing time, yeah. Okay, okay. Thank you. Thank you very much for the explanation.
Okay, thank you very much. So maybe one more question from Mr. Roni Saputra. Could you please explain how the proposed method compared to other method in terms of processing time? This is the same question. And computational power required. Does it more efficient? So the first question from Mr. MITDS is about the processing time. And now the computational power required. Is it more heavy to compute than CNN or vice versa? Please answer the question.
Okay. Thank you for the question. This is a more compute. Of course, it's more compute. We need more data to compute it. Especially for dataset, we use the for dataset that increase about 100 images. This is more complex than I think. That's why this is more the proposed method is need more time for compute. Mungkin it is answered my question.
Okay,
The question.
Any response from Mr. Roni, please? Is it answering? Yes, please, Mr. Roni.
Thank you for the explanation. One follow-up question. So, is the train network possible to use it in real time?
Can you repeat? I can hear.
Can you speak it louder, please?
Can the train network, the final network, be used in real time application?
Okay. Can your proposed method use in a real time processing?
No, because this is we use a sample for machine learning that data can use for machine to learn about the data. That's why this is machine can learn about the models. This is not real time to develop it.
Thank you.
Okay, thank you very much for your answer. So since the time is over for your session, so we need to move to the last session. Sorry for the questions that cannot be answered. Next, we will go to the last presenter, is Mr. Raka Pratama. We will see his videos present just now. Please play.
Hey, today I will do my presentation about my paper about automotive-based localization for autonomous wheelchair. So the presentation outline is one introduction to method, 3 system design and implementation, 4 result and discuss, 5 experiment and result. So the purpose to I make this paper is for enhance the functionality and capability of autonomous driving system and make independent self-location system. So autonomous system need a dependent localization system to prevent trouble localization or not dependent on GPS so user can ride safety. And the last is will automatic integration in autonomous wheelchair. So the autonomous system in vehicle must be complete to cover all the lack of its odometry and prevent various sorts of interference. So we use rotary encoder to read speed from the wheel in wheelchair, and the purpose in this paper is to study investigate its location, localization, performance based on wheel odometry use a rotary encoder. So next a method we use motion model for the differential drive vehicle. The model can be seen in this picture. This is a model of differential drive system in Cartesian coordinates. So in the right side, as you can see, this is the equation for calculation the localization, where the is the wheel diameter L and R are the left and right wheel distance, and VL and VR are the left and right wheel speed. So next is wheel automatic approach for predicting the vehicle cost. The automatic calculation can be done with the kinetic model based on Taylor series expansion, like you can see in this equation, and the first order form of Taylor series expansion, like this picture, and the equation above then can derive to solve the arbitrary position of the vehicle, like this equation. So next, system design and implementation. The wheelchair we use is using BLDC motor with a combined mass of wheelchair amount to 62 kilogram. The motor was the following compressive specification, operating at a voltage 24 volts and with the power output of 150 watts. So the mechanical design to integrate the rotary encoder with the wheelchair wheel, a pulley and timing belt are used to connect the wheel and the rotary encoder. The pulley is installed on the BLDC motor shaft, and the rotary encoder and the size is adjusted from its axis. The timing belt has a pitch to millimeter, while the pulley use consists of 20 tooth pulley for motor shaft and 100 tooth pulley. Sorry, 20 for rotary encoder and 100 for motor shaft. Next, the mechanical design to attach the rotary encoder to the wheelchair platform. A mount for the rotary encoder is made. The holder is attached to the body under the wheelchair. So in the electrical design, despite the fact that real wheelchair platform has a RGBD camera and a LiDAR sensor, we focus on developing a wheel automatic system for localization. The rotary encoder specification is a two-phase incremental rotary encoder with a pulse count of 600 and a working voltage range of 5 to 24 volts. And you can see the electrical design in this image. So for the explain and result, the first we calibration the wheel rotation speed with the laser-based tachometer. So in the table 1, as you can see, there is some error in the right and left, so it's not the same. And we calibration with this logic diagram in the right side. And then we calibration the rotational speed data between the right wheel and the left wheel in order. The angular speed of the two wheel has a maximum difference up to 0.1 radian per second. This is different is caused by the deviation or what is called drive in a wheelchair. Therefore, we apply data filtering like logic diagram in the right side. So next, the calibration was carried out to compare the actual angle of the wheelchair with the estimated heading angle obtained from the differential kinematic equation. Then a series of experiments were carried out by rotating wheelchair by 90 degree. The value recorded for its trial were as follows: 20, 22, 30, 32, and 36. Then calibrate with a proportion gain of 30.2 to produce the angle of 90 degree. After that filter, a maximum error of up to 6 degree was obtained in the next experience. Based on the information obtained, the filling process is carried out again, like the image in the right side, as you can see, the logic diagram. So when all necessary filtering procedure have been complete, the experiment can be prepared for implementation. So the experiment will carry out on a 6 meter square pad with the wheelchair regulated to follow the predetermined square pad. So in the left side, you can see graphic from wheel odometer and actual position. And then in table 3, you can see different position about the wheel odometer and actual position. So the conclusion is the study investigate how effective localization is using to propose wheel odometer technique. Based on the result, the experimental research is now that there is difference of 0.47 meter in the x coordinate and 0.38 meter in the y coordinate when the wheelchair returns to its starting position point. The system has various advantages, include cost effectiveness, low power consumption, real-time data, and simplicity of implementation. Despite its advantage, it is important to realize that wheel automatic has some limitation, especially in difficult conditions with uneven terrain or wheel slippage. As the result, it is often combined with additional sensor to improve the accuracy and robustness of the localization system as a whole. So thank you for the attention. Thank you for your attention.
Okay, thank you very much, Mr. Raga. So we still have time for question and answer. Are there any questions from the audience? You can raise your hand or you can type your question in the chat box. Maybe I have one question, Mr. Raka. So in case of slip, the wheel of the chair is slipped. Is there any correction that you made when one of the wheelchair is slipped? For example, the left wheels in terms of the direction of the wheelchair. Thank you.
Okay, thank you for your question. Sorry, you say slip?
Yes, the tire is slipped.
The tire is not moved.
When there is a water, then the tire is slipping.
Oh, okay. So so in my research, I don't I didn't use to prevent the slip wheel. So I just integrate wheel automatic on the wheelchair and just to test the wheel automatic, so I don't have the regulation to the slip patch to the wheel. Yeah.
Okay, so you
Thank
didn't
you.
include it in this research, yeah? Thank you
Yeah,
very
so I'm
much.
just
Okay,
thank
thank
you.
you very much, Mr. Raka. So, do we have any question from the audience?
Yeah, Pak Bondan, so I have a question.
Okay, yes, please, Mr. Sarjono.
Yeah, so to Raha Ramadhani, yeah, okay. So have you tested your wheelchair, yeah, for variation of distance? For example, 10 meter, 20 meter, 30 meter, and have you calculate as well? Have you considered the deviation, so the accuracy of the position? It is the accuracy are different or not? Is different or not?
Okay, thank you for your question.
Hmm.
So, in my result, is it so I'm using 6.6 square to the experience, and then the result is there is different of x coordinate. So the x coordinate different is 0.47, and the y coordinate different is 0.38 when returning to the initial position. Yeah, so there is difference for actual position to wheel odometer rate.
What is your conclusion in it? Regarding the position accuracy depend on the distance that is traveled.
Okay, so my conclusion is when the wheelchair is running straight, while the right and left wheel have the same speed, the localization is very effective. But if there are too many turns where the speed of the right and left wheel are different, the resulting error in the wheel odometer will be greater. Yeah, so where too much turn, there is much error in wheel odometer. So it is good for just running straight where the right and left wheel have the same speed.
So I mean, how far is the distance the wheelchair has traveled?
I'm just 6.6 meter in square feet.
Okay, so I'm just curious. For example, if you have taken conducted test, for example, just a straight way with the distance of 10 meter, and another one is 10, 20 and 30, and it is only my suggestion. Yeah, okay. Then please calculate the accuracy of the odometric what is device. Yeah, I mean the result should be what do I say? Now I want to see actually the actual deviations of the results of these three kind of measurements. That's only my suggestion. Okay, I just want to see so the accuracy is. I mean the longer is the distance, but the what is the higher is the deviation or not. Okay, thank you very much, Mr. Bondan, Mr. Raka.
Okay, thank you very much, Mr. Sarjono and Mr. Raka. Maybe Mr. Raka will take the consideration for his next research, future work. Okay, thank you very much. So now we are at the end of our session. 5 presenters already present their presentations. So at last, I would like to thank for all the participants and all the audience. Pardon for any mistakes in this session. Thank you and see you in other opportunities. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh.
Recording stopped. Recording in progress.
The ELM network to the time synchronization metric. A pre-processing is first performed to capture the coarse features of the timing metric based on a symmetric correlator, then feed to the ELM network. The labeling technique for taking coarse feature doesn't require channel information, so it is more practical. The simulation results show that the proposed method has the smallest
data center installation and maintenance, as well as development and manufacture of optical modules and active optical cables. Our network monitoring solutions support operations by helping visualize and diagnose network conditions. In automobiles, our test platforms help ensure that in-vehicle emergency call system signals meet required functions and standards. We are also a player in food and pharmaceutical quality assurance. On production lines, X-ray inspection systems, metal detectors and check weighers help assure products have good shape and specified mass and are free from contamination. With optimized line operation using comprehensive inspection and operation data. In environmental measurement, along with camera monitoring, values from on-site sensors are converted to IP for integrated data management at control centers. Our high-performance devices are used widely by manufacturers of communications, industrial, and medical equipment. And now, Anritsu is advancing into new areas for a future beyond testing, to create a sustainable society. By creating synergies with new partners, seeking infinite potentialities for communications and exceeding conventional wisdom and limits. Beyond testing for a sustainable future. Advancing beyond. Anditsu.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology Indonesia. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Jurnal Elektronika dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as DOAJ, Google Scholar, Mendeley, and etc. JET is also ranked as Center 2 in Kemendistek Green accreditation system. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge and therefore no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
Can you imagine? What we call communications is just part of the electromagnetic spectrum composed of countless radio waves, visible light, X-rays, microwaves, UV, and more, flooding the Earth. Everywhere. These invisible communications convey information at tremendous speeds. For example, over 10 gigabps for 5G wireless and over 400 gigabps for wired backbone networks. At this speed, 15 hours of 4K video can be sent in just 1 second. Although communications are invisible, they spread everywhere through society. Testing means capturing these invisible communications. Testing has long been the core of Anbitsu's business. Anbitsu was founded in 1895, the year Marconi successfully demonstrated the world's first wireless telegraph, marking the birth of modern wireless communications. To start, Anritsu developed and manufactured wireless telegraphs, and then diversifying to meet the progress in communication technologies. Communications have evolved dramatically since development of the Internet in the 1980s. And Anritsu has grown into a global company, leading test and measurement business for optical and digital communications. Mobile phones have also seen explosive growth during the same time. And the mobile industry has used Anritsu test solutions right from the first generation. 5G smartphones are now becoming popular in many countries. Anritsu provides testing solutions to many fields of daily life. Manufacturers use Anritsu test solutions to evaluate transmission and reception characteristics of their smartphones, communications modules, and IoT devices, as well as to test connections using our base station simulators. Anritsu testers are used by manufacturers and test houses for conformance tests. On mass production lines, Anritsu wireless testers speed up inspection times. Easy-to-operate wireless LAN testers support evaluation of IoT devices. Engineers installing and maintaining mobile base stations use Anritsu spectrum analyzers to evaluate radio wave power, frequency coverage, and interference signals. Anritsu solutions support data center installation and maintenance, as well as development and manufacture of optical modules and active optical cables. Our network monitoring solutions support operations by helping visualize and diagnose network conditions. In automobiles, our test platforms help ensure that in-vehicle emergency call system signals meet required functions and standards. We are also a player in food and pharmaceutical quality assurance. On production lines, X-ray inspection systems, metal detectors and check weighers help assure products have good shape and specified mass and are free from contamination. With optimized line operation using comprehensive inspection and operation data. In environmental measurement, along with camera monitoring, values from on-site sensors are converted to IP for integrated data management at control centers. Our high-performance devices are used widely by manufacturers of communications, industrial, and medical equipment. And now, Anritsu is advancing into new areas for a future beyond testing, to create a sustainable society. By creating synergies with new partners, seeking infinite potentialities for communications and exceeding conventional wisdom and limits. beyond testing for a sustainable future. Advancing beyond Anditsu.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology Indonesia. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Elektronika dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as DOAJ, Google Scholar, Mendeley, and etc. JET is also ranked as Center 2 in Kemendikbud Green Accreditation System. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge, and therefore, no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
Can you imagine? What we call communications is just part of the electromagnetic spectrum composed of countless radio waves, visible light, X-rays, microwaves, UV, and more, flooding the Earth. Everywhere. These invisible communications convey information at tremendous speeds. For example, over 10 gigabps for 5G wireless and over 400 gigabps for wired backbone networks. At this speed, 15 hours of 4K video can be sent in just 1 second. Although communications are invisible, they spread everywhere through society. Testing means capturing these invisible communications. Testing has long been the core of Anbitsu's business. Anbitsu was founded in 1895, the year Marconi successfully demonstrated the world's first wireless telegraph, marking the birth of modern wireless communications. To start, Anbitsu developed and manufactured wireless telegraphs, and then diversifying to meet the progress in communication technologies. Communications have evolved dramatically since development of the Internet in the 1980s. And Anbitsu has grown into a global company, leading test and measurement business for optical and digital communications. Mobile phones have also seen explosive growth during the same time. And the mobile industry has used Anbitsu test solutions right from the first generation. 5G smartphones are now becoming popular in many countries. Anbitsu provides testing solutions to many fields of daily life. Manufacturers use Anbitsu test solutions to evaluate transmission and reception characteristics of their smartphones, communications modules, and IoT devices, as well as to test connections using our base station simulators. Anbitsu testers are used by manufacturers and test houses for conformance tests. On mass production lines, Anbitsu wireless testers speed up inspection times. Easy-to-operate wireless LAN testers support evaluation of IoT devices. Engineers installing and maintaining mobile base stations use Anbitsu spectrum analyzers to evaluate radio wave power, frequency coverage, and interference signals. Anbitsu solutions support data center installation and maintenance, as well as development and manufacture of optical modules and active optical cables. Our network monitoring solutions support operations by helping visualize and diagnose network conditions. In automobiles, our test platforms help ensure that in-vehicle emergency call system signals meet required functions and standards. We are also a player in food and pharmaceutical quality assurance. On production lines, X-ray inspection systems, metal detectors and check weighers help assure products have good shape and specified mass and are free from contamination. With optimized line operation using comprehensive inspection and operation data. In environmental measurement, along with camera monitoring, values from on-site sensors are converted to IP for integrated data management at control centers. Our high-performance devices are used widely by manufacturers of communications, industrial and medical equipment. And now, Anditsu is advancing into new areas for a future beyond testing, to create a sustainable society. By creating synergies with new partners, seeking infinite potentialities for communications and exceeding conventional wisdom and limits. Beyond testing for a sustainable future. Advancing beyond. Anditsu.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology, Indonesia. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Elektronika dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and
Can you imagine? What we call communications is just part of the electromagnetic spectrum composed of countless radio waves.
Good afternoon, everyone. Welcome back to ICRAMET 2023. I hope you had a nice lunch and are ready for the next session. Now we are having our second keynote talk by Professor Josaphat Tetuko Sri Sumantyo. This session will be moderated by Dr. Bambang Setiadi. First, I would like to introduce Dr. Bambang Setiadi. He is a graduate of Institut Teknologi Bandung, earning a bachelor's degree in informatics in 1999. His professional journey includes experience in the private sector until 2005, followed by a transition to research role at LIPI, or now known as BRIN. Holding master's and doctoral degrees from Chiba University in 1999 and 2016, respectively. He currently serves as a researcher at BRIN's Telecommunication Research Center, specializing in signal and image processing for remote sensing applications. Okay, now please welcome Dr. Bambang Setiadi and Professor Josaphat Tetuko Sri Sumantyo.
Okay, thank you very much, Miss Ardita. Can you hear my voice?
Yes, I can hear your voice clearly.
Okay, thank you very much. Hello, everyone. Assalamualaikum warahmatullahi wabarakatuh. My name is, wabarakatuh. My name is Bambang Setiadi. I'm from BRIN. Today, I will be moderator for this session. Ladies and gentlemen, distinguished guests, friends, and colleagues, it is an honor to stand before you today to introduce our esteemed keynote speaker, Professor Josaphat Tetuko Sri Sumantyo, PhD. Professor Josaphat is currently a professor at the Health and Disease Omics Center, Faculty of Medicine, Chiba University, Japan. His career spans across borders, showcasing a commitment to global education as an honorary professor at the ITB, Institute of Technology Bandung, Indonesia. And he is also a full professor at the Department of Electrical Engineering, Faculty of Engineering in Universitas 11 Maret, UNS, Solo, Indonesia. His influence extends far beyond geographical boundaries. His leadership is evident in his role as the head of the Division of Disaster Data Analysis at the Research Institute of Disaster Medicine, Faculty of Medicine, Chiba University, Japan. In this position, he brings his expertise to the forefront of addressing the critical intersection between technology and disaster management. Since 2013, 10 years ago, he has held the distinguished position of a full professor at the Center for Environmental Remote Sensing, or CERES, also in Chiba University, Japan. His research interests are quite diverse and impactful as his roles, spanning from synthetic aperture radar, or SAR, ground penetrating radar, or GPR, mobile satellite communications, antennas developments for various applications, unmanned aerial vehicles or drones, and microsatellites. Today, we have the privilege of delving into the heart of his expertise as he presents the captivating topic about the development of innovative micro remote sensing for disaster, remote sensors for disaster and environmental monitoring. Please join me in extending a warm welcome to Professor Josaphat Tetuko Sri Sumantyo. Professor Josaphat, how are you?
Yes, fine. Yeah, thank you very much for the invitation. Yes, nice to meet you again. Yeah.
Thank you very much for joining us, Professor Jos. The virtual stage is now yours. Please commence your presentation.
Okay. Yeah. How many minutes?
You have about 45 minutes.
45 minutes. Okay.
Yeah. For the presentation and for the question and answers, I will tell you if it is like 30 minutes. We will, if it is possible, it will be very nice if we can have 10 to 15 minutes for discussion, Professor.
Okay. Okay. Just my talk is 30 minutes. You mean?
Yeah. If possible.
30 minutes. Okay. Yeah. Okay. I'm already share my slide. You can see my slide.
Yes, we can see.
Okay.
Yeah. Can you maximize the slide, please?
Okay, wait a minute. Yeah.
We are seeing the presenter screen right now.
Yeah.
This one. Yes.
Okay. Yeah.
Correct.
Okay. Yeah. Okay. I will start my talk today. Yes. Thank you very much for the invitation. I want to introduce about what we already done in my laboratory in Yosafat Microwave Remote Sensing Laboratory, or JMR SL. Yeah. My name is Yosafat Tetuko Sri Sumantio, that already introduced by my colleagues and Pak Bambang Setiadi. Yeah. And right now is actually I'm affiliated to many institutions right now. Yes, including the new one last October. Yes, I'm one of professor in health and disease omics center that we want to predict about what kind of the disease that will be happen in the human body. Yeah. Okay. Okay, because 30 minutes is not so long. Yes, the title of my talk today is the development of the innovative microwave remote sensor and for the disaster and environmental monitoring. I'm affiliation in Chiba University and also at Universitas 11 Maret. And for the detail is you can find my data in Sinta. Yes, Sinta website. Yeah. Okay, my talk is the content is like shown here. First is on the background and objective concept of the CPSAR. CPSAR in the circularly polarized synthetic aperture radar that we already developed in my laboratory. Also, Pak Bambang is also involved in my laboratory to develop the signal processor before. And then also including the system itself and the mission and roadmap and flight mission, image processing, microsatellite onboard CPSAR, and also some application I want to show to you. The background of my research, like shown here, actually we focus on the disaster monitoring, especially from the landslide, earthquake, subsidence, and so on. Yes, that it is frequently happen on the Earth surface, like especially in Japan and also in Indonesia. Therefore, the all-weather and night daytime available accurate and innovative sensor is needed. And also in our laboratory, we promoting the research and education on the system and application of the synthetic aperture radar, or SAR. And the objective itself, our laboratory collaborate with domestic and international institutions, including BRIN. Yeah, some of the BRIN staff is already have collaboration with my laboratory to develop the multi-band synthetic aperture radar. Multi-band is means we already developed the L, C, X, and now we develop the K-band. Yes, K-band synthetic aperture radar. This is for the UAV, aircraft. We already established and proven this one. And we also developed for the high altitude platform system, or hubs. Yeah, when the altitude is 15 to 25 kilometer. And also the microsatellite, especially here is we focus on the right now is the airborne and microsatellite SAR mission. Like shown here, it is some product in my laboratory. For example, it is from the X-band SAR is from the Boeing 737. We already installed from the Squadron 5 at Hasanuddin Air Force airport. Yeah, and also the C-band. It is from the CN235 aircraft, also from the Cessna, and then L-band from the drone. I think you can find Pak Bambang in this picture that we worked together before, and also the L-band and C-band microsatellite CPSAR. And the concept of the circularly polarized synthetic aperture radar, it is my patents. I have the patent from the CPSAR itself, that we generate the right-handed or left-handed, and then we transmit, and then will be scattered by the object. And then the scattering wave itself, it depends on the shape and characteristic of the surface, and also the tilted angle and the orientation of some of the object itself. Yes. So based on this one is the the intensity, phase, and also the polarization will change. Yeah. So then the left-handed or right-handed, and then you can get together or receive together, and then you can process. Yeah. Okay, this is the first of image of the CPSAR that we have done at Lanut Hasanuddin at Makassar before, and compare with the optic sensor. This one is cloud covered by the cloud, and then we can penetrate and we can get this very clear image. And this one is with the resolution is 37.5 centimeter. And yeah, fortunately, I got some information that China, yes, China CAS, yes, China Academy of Science already made the circular polarized from the P band, and they prove about my theory that the circularly polarized synthetic aperture is more better compared to the linear polarization. Yes, I'm very glad that they made the airborne SAR from the P band and then made the some experiment and showed and proved my theory. Yeah, and from the detail of my mission, yeah, from the circularly polarized synthetic aperture, you can get in this paper. This one is a free of charge, open access, and you can get just airborne circularly polarized synthetic aperture. So you can download. And the roadmap in my laboratory, we already developed from the ground base and also from the airborne aircraft, and now we develop from the hubs, yeah, high altitude platform, and from the microsatellite. And yesterday, yes, I interviewed by the Japanese government, and I hope we can get the next budget, and we want to develop 10 UAV. Yes, this one, the GX. GX is Josaphat Laboratory Experimental Unmanned Aerial Vehicle with wingspan is 6.6 meter, and we can bring 25 kilogram of the payload. And I hope we can realize 5 drone SAR, yes, for disaster monitoring in the future. Microsatellite, L-band for the drone, yes, and C-band, and also the X-band for Boeing 737 and CN235. And parallelly, we also developed some drone, yes, where this drone can fly about 2 hours, yes, 2 hours with the hybrid, and then we can use this platform to to bring our radar, because if we buy from the market right now, I think it's just have the limitation of the endurance. Yes, it is just 20 minutes or 30 minutes. Yes, it's not so good for our mission, because our mission is we need for the long endurance. Yes, at least it's 1 hour of the flight mission. Yeah, and yes, I hope we can realize our drone from next year. Yes, it is what we already done. Yes, already proven is from the LCX band, and then from the microsatellite. Now we already developed from the L band, and I hope we can do to expand from the to launch this our microsatellite. And it is one of the picture of the first image of the circularly polarized synthetic aperture. It's very clear, and it is without the filtering. It's very clear. Yes, this innovative sensor, yeah, or remote sensor, and we can implement for many applications. Yeah, from the disaster monitoring, like from the peatland, land deformation, fire spot monitoring, volcanic and earth monitoring, and also the landslide precursor monitoring. And the other one is from the natural resources observation, including the fishery and maritime application. For example, from the natural resources is to mapping the some of Indonesian area. Like now we have some project at the Toba area. Yes, I hope we can get the data is more detailed by using this CPSAR. And also the illegal fishing, ICRAMET fishing, like in the northern part of Indonesia, I think we need this synthetic aperture radar. And the oil spill monitoring, we work together with Pertamina. Yes, we have the project at the Kepulauan Seribu, using the K-band, our K-band synthetic aperture radar. And the other one is the search and rescue, SAR. Yes, it is it's very good. We can implement this sensor to observe or to find some accident. Yes, in heavy rain and cloud or has environment, and also sometimes in forest. Like in Papua, I think it's almost every year we have some of accident of the small aircraft that it is very difficult to find. Yeah, I hope using the synthetic aperture you can implement this observation. And the other one is home security and anti-terrorism mission. Yes, I think it's in Indonesia is very good because it's very large. So we need to implement this one for the border and home security. And the other one is for the infrastructure monitoring. Yes, we have some project with the Malaysian government. Yes, to observe the land deformation in Malay Peninsula. Yes, it is under the SATREP project with the Malaysian government. Okay, and then from the airborne SAR itself, yes, like we compare with the another aerospace institution like the DRR of the Germany, NASA of the United States, and Japan, the JAXA. Yeah, they operate. They are operating the synthetic aperture using the linear polarization, but we developed by ourselves. It is in our original and the only one in the world. It is and also our innovation. Yes, it is in the circularly polarized synthetic aperture radar on the CPSAR that we already installed in CN235 MPA of the Squadron 5 at the Lanut Hasanuddin at Makassar. And okay, this is some of picture. Yes, you can see here Pak Bambang here. Yes, he worked together with us before. It is we did the experiment at Lanut Adi Sucipto before. Yes, in 2017. But I think it's my student and us is very happy. Yes, we can do to realize our dream to develop our radar and install, and we did some experiment, and we also developed some of the material for the new radome. Yes, on the new material for the drone itself. We call it the polymaterial, and polymaterial is just right now is used by the SoftBank, and we work together with SoftBank for the new drone and also for the new telecommunication system for the 5G and 6G. Yes. Okay. This is when our radar is installed in the Cessna 172. Yes, of the aircraft. And okay, this one is the CN235. Yes, aircraft that we installed our antenna. This antenna is developed by our former student Pak Cahya. He worked at BRIN, yes, and he developed this is very nice antenna with bandwidth is about 400 megahertz, and we can realize to get the data with the resolution 37.5 centimeter. And this one is the system itself, yes, controller and transmitter, receiver, and here is the center of the controller to our system. And before we did the flight test, yes, it is we did the I think the antenna testing, yeah, without the radome, and it is with the radome, and we compare, and we know the characteristic of the radome itself with the attenuation is about 0.5 dB. Yeah, I think it's not so large about this attenuation. And the other one, okay, next is the first image. Yeah, the first image. I think the first image of the circularly polarized synthetic aperture radar. Yeah, I think it's very clear compared to the optic sensor that covered by the cloud. It is no cloud, no haze, and also the no volcanic ash. And okay, it is the other images is very detailed. Yeah, it is the optic from the Google, and we can compare. This one is more detailed. Yeah, and you can get some phenomena, different phenomena. It's we can penetrate the object, and also we can analyze the structure of the tree. Like now, my student is use this images to reconstruct the configuration of the tree, and I hope in the future we can implement for the carbon carbon business, in the future. And the other one, this one is the full polarimetric of the CPSAR, and you can get the data of the full polarimetric using the circular polarization. This one is LLRR. L is left-handed circular polarization, and R is the right-handed circular polarization. And RLLR, this one is the cross polarization. Compared to the linear polarization, that the cross polarization is more stronger compared to the co-polarization. It is the characteristic of the circular polarization. It is opposite to the linear polarization. So you can get, this one is very strong, the cross polarization, compared to the this co-polarization. Yes, but the linear polarization is opposite. From the co-polarization, horizontal, and vertical is stronger compared to the cross polarization, HV or BH. Yeah. Okay, yes, this one is if we enlarge, and you can get is more detail, and you can the structure of the the tree is very clear, using the circular polarization. And for the illegal shape, yes, you can implement this CPSAR, and you can get the shape the shape, it is very nice, and you can also get the scattering of the this is I think is the antenna of the telecommunication system using the C-band that interference to our radar. And okay, this one is mangrove area. We can use to estimate the mangrove, the volume of the mangrove, and also for the fish pond. Yes. Now we implement this one, this technique to monitor the fish pond at the Lake Toba. Yes, at the North Sumatra. And okay, this one is mangrove at Pangkajene, and now we work together with the BPN. Yes, how to to know the boundary every area, and then I hope we can help the kantor BPN, yes, to make the map of the we call it the bidang, every bidang or parcel, yes, every parcel of the land, but because if you use the conventional technique, is I think we need 100 year, yes, to finish to mapping Indonesia. But I hope using the CPSAR is I hope is less than 5 years we can finish to map whole of the Indonesia. Okay, this one is the microsatellite development, yes, in my laboratory, and my student is came from many countries. For example, this one from Pakistan, from Indonesia. Now, Pak Berlin and Pak Cahya is working at BRIN, and Katia now working at European Space Agency. And okay, Mirza Sang is from Pakistan, is now work at aerospace company at Korea, and Chuasang, yes, now he worked at Xiamen University at Malaysia. Okay, this is our microsatellite, and maybe I'm still have 10 minutes. Yeah.
Yes, Professor.
Yeah. Okay. Yes. I want to show some application. It is use the spaceborne images. Yeah. Like we know, synthetic aperture radar. It is when we get the data, it is from the level 0 on the raw data, we can process and we can get the information of the intensity, phase, and polarization. Yeah, from the intensity, as you can derive the backscattering coefficient, and you can use for many applications, and including from the deep learning, yes, and so on. Yes. And the other one is the phase. From the phase, as you can, extract the coherency, and coherency itself we can get from the coherent analysis. And the other one is the interferometric. Yeah, interferometric is you can use the long track interferometric ferrometric and the cross-track interferometric. A long track is if you get the data in the same time, two data, yeah. But cross-track is if you get the data in different time, yeah. So, and the other one is, okay, from the long track, you can extract using the INSAR or interferometric SAR, differential interferometric SAR. And INSAR, you can derive the DEM, digital elevation model. And from the cross track is same. And you can get the, the change in time, time series. Yeah. So in this case, you can derive the PS INSAR on the permanent scatter interferometric SAR. And finally, polarization. Yes, I'm already show you a full polarimetric of our data. Yes, so in this case, you can use the 4 images, the full polarimetric, but you can, full polarimetric. It means the data itself is about half. Yes, the memory is half because when we transmit one pulse, we use from the 2 receiver. So in this case, it's half of the memory, and the coverage is about half it. So this is if you want to use in fully, it is use the dual mode, yes, or single mode, yeah. But if you want to extract the full polarimetric, is unit 4, yeah. So okay, first is the coherency. Yeah, coherency is you can analyze using the coherency analyze. Yeah, so in this case, it's 2 images. Yeah, in the same place on the same spatial place. Yeah, of the pixel is you can calculate. Like shown here. Yes, using the complex conjugate, and you can multiply, and you can extract the coherency. Yeah. One of the application, like we already done to observe the Central Java earthquake, it's very easy, just using the coherent analysis. If the building change drastically, it means the coherency value is very bad. It means close to the 0. Yeah, but if the object, before and after the earthquake, it is not move, it's not destroy. It means same. Yeah. If the same, so the coherency is to be 1. Yeah, because the value of the coherency is from 0 to 1. Yeah, 1 is means no change. Yes, or same. Yeah, so you can get like this one. Yes, the red one is the building is destroyed. Yeah, and the green one or blue one, it is yes, a little bit destroyed, but not the no color area on the gray scale. On the white scale, it means it is no change. Yeah, it means 1. Yeah, so this is you can use this very easy and very simple application. Yes, to mapping the earthquake impacted area. Yeah, using this the coherence value. And the other one is the interferometric. Yeah, interferometric is if no change, you can extract the DM. But if change is, you can extract the land deformation using the differential interferometric SAR or DINSAR. And about the theory itself, yes, you can read in my paper, yes, that published in the IEEE Translation on Geoscience and Remote Sensing in 2012. Yeah, it's very long ago. Yeah, about 13 years ago. Yeah, this is you can get from 2 images. Yeah, if you want to know about the change of the land. Yes, for example, this point, yes, move, yes, like this one from P to P does. Yeah, so you can extract the dx change is mean the land shifting. Yeah, or land deformation, and then the vertical deformation is dz. Yeah, so you can extract by the change of the phase itself. The change of the phase is mean you can extract from the length of the RM. Yes, it is in the slant range of the master, and RS, it is the slant range at the slave. Yeah, and then you can extract like blah blah blah, and you can get the change on the face. Yeah. Okay, I want to skip this one because no time. And okay, technically it's like this one. For example, it is when I made the observation of the Lapindo. Yeah, Lapindo is I use from the ELOS to ELOS2. Yes, 2 period. Yeah, but the problem is the blank. The blank area is hard to fill up the blank area. So in this case is first, for example, the master is 2017 February, and for the slave is 2006 May. Yes, and then you can first is geometry corrected. After that is you can extract, yes, the SLC data, and then you multiply and you can get the interferogram. Yeah, it is the fringing of the interferogram. But unfortunately, in this image, it still have the orbit, yeah, orbit information of the satellite. So in this case, you need to extract, yeah, the orbit information. So you need to, minus extract. It mean, and after the elimination of the orbit pattern, sorry, and then you can get the image is more clear, yeah, with the fringing like this one. It means, oh, we can, if you familiar with the interferogram, is you can predict, oh, this one is the the mountain, yeah, and then this one in the flat because the chain is very large, yeah. And then if you have the simulated Chilean pattern, yeah, you can extract from the former DEM, yes, and then you can extract again, and if no change, you can use as the DEM or digital elevation model on the information on the head. But if you find the change on the land deformation, yeah, unfortunately, this one is still in the phase information, and you need to extract again, yes, using the unwrapping, and you can get the final land deformation change, yeah, in centimeter or in meter. Yes, it depends on how to setting your, your data before. Okay, next is the application of the interferometric SAR. Yeah, it is using the TerraSAR X to observe the land deformation at the Jakarta. Yes, you can find, oh, this area is very, change drastically, and means in this area is have some, land subsidence, and also at the BSD area, yes, also have some subsidence, and also northern part of Jakarta is also have some, the subsidence. And so why some flood and also the broken of the land is happen in Jakarta. Okay, and you can also use for to extract the volcanic ash thickness, and it is from the Lapindo, yes, like I already mentioned. And you can read my paper in IEEE TGRS about estimation on the spotted hot mud flow. Yeah, current using the continuity equation. The continuity equation is my new equation that you can extract, on the volume, or to estimate the volume of the material that spotted, yes, in this Lapindo or Sidoarjo area. And you can extract, which villages impacted by the this hot mud spotted phenomena. Yes, and you can extract the total material that already spotted until right now in Sidoarjo area. Next is the volcanic ash. Yes, you can also use this de-insar technique to know about the thickness of the volcanic ash that it is made Mbah Marijan die, yes, because of this volcanic ash. And the other one is the PSINSAR. PSINSAR is the extension of the DINSAR. Yeah, many DINSAR, and you made stacking. Yeah, is from the long period of the observation, and then you can implement to know about the speed of the land deformation. Like this one is at Bandung City, yeah, at the Dayuhkolot area, and also Cimahi. So why in this area is some wall is cracked, and the road is also cracked, and this is the the reason why this the environment in this area is not so good right now. And the other one is at the northern part of the Jakarta. Yes, about the sedimentation itself, you can also estimate using the DINSAR. Yes, I'm already made this one, and you can read my paper in IEEE GRSL. Yes, fortunately, my paper also on the cover of this magazine. Finally, about the polarimetric SAR. Yeah, polarimetric SAR is I think the theory itself is very complicated, but you can use the Snap, yeah, on the Pulsar Pro. Yes, the software that you can use to process the data of the ELOS2 and also the ELOS1 and TerraSAR X and also Canadian RadarSat. Yes, the full polarimetric, and you can get like this one. Okay, this one is the blue one is the surface scattering. Surface scattering is from the paddy field, from the sea surface, and also from the road on the runway. Yes, for example, some area in the runway of the Juanda. Yes, it is in the airport of the Juanda. Also, this is the surface scattering, and the other one is the volume scattering, the green one. The green one is a scattering from. It means the multi-scattering. Multi-scattering is from the vegetation, yeah, commonly. So in this case, is you can extract the scattering, volume scattering, and you can classify as the vegetation area. Yes, if you work in forestry or in the agriculture, I think yes, I recommend you to use this polarimetric SAR. And the other one is double bonds. Double bond in the scattering from the man-made. Man-made in the building. From the shape, yeah, and from the bridge, yeah, and also some of the land bridge, yes, it is double bonds. Yes, double bonds is means and the phase is come back. When you transmit and scatter first time is 0 degree and to be the 180 and then scatter again and to be 360. It means 0 degree again. So this is the double bonds. Yes, if you want to classify the building, it means you can use the double bonds. Okay, it's in the Surabaya area and it is in the Jakarta area. And the next one is now we work on the Toba Lake, and it is a very nice picture. Then you can classify, the environment in around the Toba Lake. And the other one is Mount Sindor. Okay, I think it's 30 minutes. Yes, for my time is finished. Yeah, thank you very much for the invitation. I hope you can learn from what we already developed in my laboratory, Josaphat Microwave Remote Sensing Laboratory in Chiba University, and also at the Universitas 11 Maret at Solo. Thank you very much. Yes, and I give back to Pak Bambang. Yes, my time. Yeah, thank you.
Thank you very much, Professor Josaphat, for the highly informative and captivating presentation. We appreciate your time and profound insights. Now we will open the floor for the question and answer session. If anyone has questions, feel free to leave them in the chat, or you can use the raise hand feature in Zoom if you want to ask directly. When asking questions, please be sure to activate your microphone and camera if possible. We want to hear and see you directly. Just a reminder, we still have like 10 to 12 minutes for this discussion. Please don't hesitate to share your insights or questions, or if you have any experiences, you have any that you want to share with Professor Josaphat. This is a truly unique opportunity to interact directly with him. So let's proceed with the question and from participants. Is there any questions?
Yes, and my laboratory also gives the open opportunity if you want to enroll on the master degree or PhD or doctor degree. As you, I'm very welcome of you. Yeah.
That's a very good news, Professor. So you are currently accepting students for master and PhD degrees.
Yeah.
All right.
You can use the degree by research program. Yes, I think you can find the list of the Chiba University is my laboratory. Yeah.
I see, I see. So from if you are a BRIN or Indonesian, you can apply for the scholarship from for the degree DBR program, right? Right, Professor.
Right. Yeah, right.
Any questions so far? If there is no question, I will start with the
I
first
have the
question.
I have the question.
Okay.
Hello,
Yes,
Prof.
please.
Hello, Pak Yuyu. Yeah,
Hello,
how are you?
Pak Yuyu.
I want to asking about the how many levels successfully for the scanning for the SAR, yeah?
Yes.
One scan is success, or we must the timely to scan.
Sorry, you mean what?
Probably he means how many times do you have to fly over an area in order to get a clear picture, Professor? Is that correct?
Yes, yes, yes.
Yeah. I think it's once is you can get it's very clear. Like you know, I'm show you. It is just once we got the data. Yeah. Yeah.
Okay.
Yeah.
I say actually you don't have to fly many times, Professor. Is that correct? I mean, if you
yeah, but it is depend on the mission. Yes. If you want to know about the change, yeah, land deformation, or you know, or to know about the vegetation change. Yeah, it is frequently you must get the data. Yeah.
Okay, thank you, Prof.
Yeah, yeah.
Any other? Yeah, that is actually quite intriguing question, Professor, because if you fly once in this technology, so you have to record the position of the flight in order to get a clear picture?
Yeah, yeah. Of course, when we did the recording, is we have the GPS information and also the IMU information. Yeah, so we can we can make the geometric correction. Yes, to
I see.
our picture. Yeah.
I
So
see. So
for this one I think it's not so difficult. Yes, but in the future, is now we are develop a more high precision and also the high resolution. Yes, if high resolution is it is a little bit some challenge. Yeah, because every 1 pixel is about 1 centimeter. Yeah, it is if we need high precision, it means some centimeter precision. So in this case, is like now is the GPS problem. Yes, it is one of the topic in our laboratory. Yeah.
I see. That's very interesting. We have a question from in the chat room from Mr. Yudi Tanasa. He asked, how do we reduce error in SAR images?
Okay. I'm sorry. What kind of the error? This one? Yeah.
Mr. Yudi Tanasa, are you there?
Error means the noise or something? Yeah.
Probably. I think so.
Yeah.
Okay. Yes, please.
Okay.
Okay. Thank you for letting me ask the question. Yeah, Professor, for the error, because the SAR works by changing polarization of to generate an image, and the position of the polarization give the errors on for the final image.
Yeah.
Yeah, and how to reduce that? I mean, well, I'm aware about the technique, several techniques to reduce during the pre-processing, but what can be done to reduce it in the acquiring stage of the image?
Yeah. Okay. Yes. I think the error is it is what I'm consider until right now is about the hardware error and also the the image error itself. For the hardware error is including the length of the cable itself also have the influence to the phase. Yeah. I think like Pak Bambang and another researcher that working for the INSAR, it is very serious error. Yeah, because if the cable that we use, like we install in CN235, it is very long. Yeah, but when we install in our UAV, it's very short. So in this case, is the length of the cable from the front end until to the antenna itself. We must consider this one to reduce the error. If on the L band, yes, or P band, it is maybe it's not so problem. But if we work for the C band, X band, or K band, it is a serious problem. Yeah. First is this error from the phase, and the other one is about the noise itself. Yeah. The noise itself is including the noise inside the system itself. Yeah. For example, when we use for the long, transmitter, it means the temperature will increase. The temperature increase is the noise will increase too. Yes, that this noise will include in our, the signal. It's right. The signal is we need to reduce. Yes, the we call as the temperature, noise. Yeah. So to solve this one is we use the Starling engine, yes, to keep the temperature in in stable one. And the other one is about the antenna itself. Yeah, the antenna is when we fly. Yeah, when we fly in different altitude, the temperature is different. The temperature is different. It means the noise in antenna also different. So in this case, is we must make some compensation about this noise itself. Okay, next, the noise is on the error is about the geometric error. Yeah. When we put in UAV, the UAV is unstable. Yeah.
Unstable.
If a small UAV is more unstable. So why we develop is very large UAV, and now we develop also for the high altitude platform. Yeah, if 15 kilometer, it is because it's very stable. Yeah. So to reduce this error itself. Yeah, and to compensate the another error of the geometric is we consider also, using the data of the IMU and GPS as the input of the motion compensation. Yeah, motion compensation is to to decide the coordinate every pixel. Yes, so it is what we done until right now. Yes, I think many error. Yes, in our system. Yeah, but our target is centimeter resolution. Sorry, centimeter. Yeah, resolution and what is accuracy. Yes. So it is I think it's challenge. Yes. In this problem. Yeah. Yeah.
All right, thank you very much, Professor Josafat. Okay. Actually, we have 3 questions. The first one from Pak Cahyo Adi Prabowo. What kind of signal processing is used to evaluate the SAR images?
Signal. Sorry.
What kind of
Signal
algorithm
processing.
for the SAR images? What kind of algorithm do we use to evaluate, to
It means
analyze?
the RDA, range Doppler algorithm. Yeah.
Probably. Pak Cahyo, can you?
You means yeah.
Can you give the question directly?
Okay, thank you very
okay.
much.
Yeah.
Okay,
Yes.
please.
What is the answer?
Yeah.
Josafat?
Yeah.
Yeah. How about the signal processing? Is used to evaluate the SAR images.
Yeah. For the signal processing is we use the range Doppler algorithm. It is to process from the signal from the bit, the bit level until to the single loop complex. For the detail, and you can refer to my book. I'm already sharing in the chat room. You can find the code, yes, and also the raw data, yes, and how to process it. You can get in this book, yeah. It is yes, a range Doppler algorithm is our basic, algorithm that we use until right now. Yeah.
Okay. Okay. Thank you very much, Professor.
Okay. Yeah, you're welcome. And next, yeah.
Okay, thank you very much. Just short answer, Professor. In your opinion, what is the bottleneck for Indonesia to realize commercial SAR sensor? This is from Mr. Hari Septanto.
Okay, yes,
What?
I think it's many problem. I'm already have many problem that to say in Indonesia. Yeah, first is the security problem. Yes, the security is very hard. Yeah. Sometimes we cannot move the SAR sensor to Indonesia, and the component itself, and also the budgeting itself, how to buy the system of the budgeting in Indonesia is very complicated compared to another overseas. Yeah, and also maybe about what is the application is many, yes, but the institution that want to be in the to
Operate.
handling, yes, it is I think it's not so many, yeah, compared to another country. Yeah, but I hope in the future it's more better. Yeah.
All right.
Yeah.
All right. Thank you very much, Professor Josaphat. Ladies and gentlemen, it appears that our QA session has come to an end. If you have any question, unfortunately, due to the time constraint, we cannot continue. Feel free, if you want to ask questions, you can contact Professor Josaphat directly. A big thank you for Professor Josaphat for sharing your experience, and thank you everyone for your engaging question. We look forward for future interaction. Okay. And next is before we wrap up today's session, I would like to express our deep gratitude to Professor Josaphat Tutuko Sri Sumantyo, for an exceptional presentation, for generously sharing his expertise and his knowledge with us. As a token of our appreciation, please allow me to virtually present this certificate of recognition. Professor Josaphat, your contribution has truly enriched our understanding about synthetic aperture radar, and we are immensely grateful for your time and insights. Thank you once again, and we look forward to possibly the future for collaborations. Have a great day.
Thank you very much, Pak Bambang and all. Yes, keep your health. Yes, and best regard for your family. Yeah, thank you very much.
Thank you. Thank you very much,
Thank you,
Professor.
Prof. Thank you, Prof.
Yeah, thank you very much. Yeah.
Okay, now I would like
to. Yeah, sehat-sehat.
Pak Yu, terima kasih. Okay, now I would
sama-sama.
like to pass the baton to our Master of Ceremonies, Ibu Artita, who will guide us through the rest segment of our event. Ibu Ardita, please, over to you.
Yeah, okay, thank you, Dr. Bambang. Okay, thank you to Professor Josaphat Tetuko Sri Sumantyo, and also thank you to Dr. Bambang Siadi for a wonderful discussion and presentation. We are now ready for the parallel session 4 and 5 in 2 breakout rooms. After these parallel sessions 6, 7, and 8 will begin later after the afternoon break. Now, our host will first assign presenters who are presenting the respective session based on the schedule. For the rest of the participants, you are free to move between rooms by clicking the breakout rooms to join the available presentation session. Some reminder again for the presenters: first, keep the naming convention according to the guidelines. Second, we also encourage you to keep logged on during the breaks. Third, for the presenters, please turn on the video for the whole session in your assigned sessions. Fourth, please be reminded it is compulsory for presenters to be present at their respective Q&A sessions. Fifth, do not forget to fill in the attendance form as the presenter when you are in your own session. Sixth, please have your presentation slides ready for the question and answer sessions. For all the participants who want to ask some questions during the presentation sessions, please use the raise hand menu that can be accessed from the reactions menu in your Zoom application. Thank you.
Okay. You can hear my voice. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Good afternoon. First of all, I would like to thanks for joining us in ICRAMET 2023, especially in parallel
Recording in
session
progress.
5. Let me introduce myself. I'm Valin Oktaviani from Research Center for Telecommunication, National Research and Innovation Agency Indonesia. It's my pleasure to be a moderator in here. Today we have 4 papers that will be presented with the topic related to the remote sensing and radar system and antenna device and technique. Then I will make sure that all the presenters have joined in this room. The first presenter is Nurul Hasanah with the title Experimental Evaluation of Polarimetric Ground-Based Synthetic Aperture Radar Imaging Using Portable VNA. Miss Nurul Hasanah, have you joined with us?
Yes.
Okay. The second presenter is Mr. Sevda Sahin with the title A Novel Radar Receiver for Joint Radar and Communication System. Mr. Are you
Actually,
here?
Miss. Hi.
I'm sorry.
No
I'm
problem.
sorry.
No problem. I'm here.
Okay, the third is a new improved Sierpinski carpet structure based in planar array to synthesize low side loop radiation pattern by Ahmad Jamil Abdul Qadir. Have you joined with us? Hello? Okay, next, the last investigation of the range scanner radar performance for reflectivity rainfall estimation in a co-location grid data by Mr. Tin Sinatra.
Yes,
I'm sorry. Yeah. Okay. Before we start the session, I will inform you the rule that must be noticed for all the participants. The first, for all presenter in the session, please keep your video on until the session finish. We will have screen capturing. We will have screen capturing session by the end of the presentation or when all participants are present. And then please fill out the attendance form during the session. And then the time for each presenter is 15 minutes long. Please make sure you are present during your question and answer session. And then for the participant who like to ask a question, please use the raise hand function attraction menu in your Zoom. And then let's begin the presentation. I would like to invite the first presenter. Please welcome Ms. Nurul Hasanah from University of Indonesia.
Assalamualaikum warahmatullahi wabarakatuh. Hello and welcome to our presentation. First of all, I'd like to thank the committee for giving us the opportunity to present our study at ICRAMET 2023. My name is Nurul Hasanah. I'm from Universitas Indonesia, and I'm delighted to be presenting to you today. The title of this research paper is Experimental Evaluation of Polarimetric Ground-Based Synthetic Aperture Radar Imaging Using Portable VNA. So to get started, we will explain the presentation outline. The presentation will begin with a quick background and go over some motivation process research. After that, we will take a look at the configuration developed for this research and dig inside to cover the basic principle of ground-based SAR. The raw data from the experiment is then processed by the back projection algorithm in order to evaluate the performance of the 2D image result. Following this, the focus images are shown and evaluated based on references in regard to the point target position from the experiment. Last but not least, the key points are summarized and presented. In this section, we will explain the background and talk about the motivation of this research. Recent trends are exploring ground-based synthetic aperture radar for various purposes. In general, GBSAR is a radar system that operates on land and can observe targeted ground area on a small scale.
This mobile system moves along a rail track to facilitate its observational capabilities. The primary application of GBSAR is deformation monitoring. Its imaging ability, which lets the system do a lot of measurement at the same time, is an intriguing feature that makes the GBSAR system complementary to other deformation measurement techniques. On the picture, you can see the GBSAR geometry that move along in the X direction and capture image in range or Y direction. In an earlier research work, a VNA is used for the GBSAR system for the early detection of landslide, and a simple experimental ground-based SAR or GBSAR system for studying SAR fundamentals was introduced. So the aim of this research is now to acquire preliminary knowledge and skill in the field of polarimetric ground-based synthetic aperture radar imaging. Now we will take more detail of GBSAR experimental setup with a basic concept of SFCW and algorithm that we use. Figure 2 and Figure 3 illustrate the experimental configuration of the GBSAR system created for testing purpose. The setup comprises vector network analyzer, a pair of standard gain horn antenna for transmit and receive, an Ethernet cable, Ethernet wire, two wireless high-frequency cables, and an antenna positioners. The point target consists of some corner reflectors and prototypes of UAV. Then the sensor moves in a stop-and-go mode, scan scene at each step, and thus acquire monodimensional image, which are subsequently compressed in a single two-dimensional complex image using the inverse Fourier transform. And this is the detailed position of each target. As you can see, P1 with a side length of 40 centimeters, P2 and P4 have 10 side length with 100 centimeters, P3 with a side length of 50 centimeters, while P5 and P6 using prototype of UAV constructed from composite material. So to summarize, we define some parameters as initial setup for the experiment. We choose SFCW as radar type, with the operational frequency of the GBSAR system are chosen between 5 until 7 gigahertz based on antenna specification. Frequency step is 0.5 megahertz. Number of frequency sample is 4001. And we declare height of GBSAR system is 5 meters with aperture step 10 centimeter in azimuth. Number of sampling point is 173 with nominal transmission power -1 dBm. And we conduct 4 polarization here, which is HH, HV, VH, and VV. So next is basic explanation of SFCW concept and back projection algorithm. I will just give a brief overview of this section due to the time limitation as it already explained in detail in many researchers and papers. SFCW, network in frequency domain, transmit an analog signal over the determined bandwidth with uniform frequency step and can be described as time-dependent frequency series. The received signal at each step frequency are then converted to an intermediate frequency signal, which is then demodulated into baseband in phase I and quadrature Q signal. Then the IQ signal contains both the amplitude and phase information of the target. To verify that the reflected signal from the intended target align with the most recently transmitted pulse, the range of SFCW radar sensor should be less than the ambiguous range, and this range is also called the maximum range that is affected by the frequency step or delta F. For our system, the maximum GBSAR range is 300 meters, with range resolution is 0.075 meters, while azimuth resolution is 15 centimeters. And for imaging algorithm, we use BPA, which is time domain algorithm. From the given diagram, the collected data from one scan is then applied inverse Fourier transform. The difference range data utilized to determine phase adjustment and conduct linear interpolation. The commutation of each reflected signal for each pixel relies on the differential range, which is the distinction between the distance within the radar and the pixel and the distance to the scene center. Now we will look at the image result from the previous experiment. The raw data was collected using a portable VNA from 5 to 7 GHz, as we declared before, in FCW mode with a 65 scan angle. Having 4,001 steps in range, its acquired data required 2.5 seconds to record. Moreover, as azimuth shifting was still carried out manually, obtaining one polarization requires roughly 30 until 40 minutes for 173 sample points. Figure 6 displays the complex SAR image result for each polarization from the GBSAR VNA experiment with the position of the target indicated by the previous figure. A visual examination of the polarimetric image confirmed that each imaging result corresponds to the object in the field scene. Co-polarized image show less backscattering values than cross-polarized image. The HV and VH polarization produce image with some distortion and noise. And the focus HV image has noise in the upper right corner, as you can see. This condition could be caused since antenna orientation shifting procedure is performed manually, which puts hardware noise into the measurement result. So in this section, the key point will be summarized. To provide preliminary knowledge in the SAR field, a polarimetric GBSAR experiment was performed employing a two-port portable VNA, two-horn antenna, and multiple CRs and targets. The geometrical configuration of the experiment was theoretically evaluated, and some preliminary working strategy concern was established. Finally, an imaging study has occurred, giving results that are aligned with the concept. Furthermore, more research will be conducted for a deeper polarization scattering matrix analysis and applying polarimetric calibration based on the image result. Okay, thank you. The presentation is over now. Thank you for your attention. If you have any question, I'm glad to answer them.
Thank you very much for your nice presentation and interesting topic. Now I would like to open the floor for question. If you have any question, just raise hand or write down your question in chat box. Please don't be hesitant if you have any question. Okay, while wait the question from the participant, I have a simple question. How to set up the SAR system to produce image result from each polarization? Is it by altering the position of the horn antenna or by changing the reflector position?
How to set up is we still done with manual.
Hello.
For each measurement.
I'm sorry because the video is break. Can you explain any more?
Oh, okay. So we still do it manually. So we change the direction of the polarization of the antenna from vertical to horizontal by change the antenna position.
Okay, so you still use a horn antenna with a single polarization, isn't it?
Yeah, linear polarization.
Oh yeah, maybe if it will generate a better performance, yeah, if you use the dual polarization horn.
Oh, okay, it's nice suggestion.
Okay, any other question from the participant? Just write down in the chat box or raise your hand in reaction function. Oh yeah, Mr. Iqbal, Muhammad Iqbal, please.
Yeah. Thank you for your presentations. Yes. I kind of wondering how you can define the parameters in GB, what is it? GBSAR antenna. You define the numerical values in it, and how you get those kind of numerical values. Is there any reference for that, or you just have randomly put the number inside of it?
What kind of numerical value do you mean? Is it the power?
I guess it shows on the slides number 3, I guess. Slide number, I'm sorry, I'm not sure.
Oh, okay. For the frequency range, we chose 5 until 7 gigahertz, but based on antenna specification, based on antenna specification, while the frequency step is 0.5 megahertz to get better resolution.
Okay. Okay, I think that's all for me.
Okay, is there any question? Okay, I think it's enough. Once again, thank you very much, Ms. Nur Hasanah, and please give an applause for Ms. Nur Hasanah. Let's move to the second paper that will be delivered by Ms. Sevda Sahin from TOBB University of Economic and Technology, Turkey. Please, Miss, the time is yours.
Hello, and welcome to this presentation about a novel radar receiver for joint radar and communication systems. My name is Sevda Sahin. I am a PhD student at Top University in Turkey. I have more than 20 years of experience on radar and electronic warfare domain as system engineer. This is the content of my presentation. After a brief introduction about integrated sense and communication topic, I will continue with waveform design for ISAC system. Then I will discuss about receiver processing for both communication and radar receivers, including proposed new technique. Finally, I will give our simulation results. Integration of radar and communication systems on the same platform causes some problems, like the interference and installation. Especially size, weight, and power limitations on small-scale platforms are very big problems. Integrated sense and communication systems have significant potential in solving these problems, as they reduce congestion both in the spectrum and on the platform. In this study, we focused on the joint waveform design for ISAC system. Joint waveforms are studied in 2 main areas: sensing over communication signals and communication over sensing signals. We consider radar-centric concept in this study. In this study, a monostatic pulse radar is assumed in the scenario. As a contribution, a new technique for radar receiver with better range and velocity estimation performance is proposed. Performance analysis and comparisons of both techniques indicate that the radar signal contain and do not contain the communication symbols were made. In addition, the similarity rate in the communication receiver was also examined. In this paper, we used short pulse radar waveform to implement both sensing and communication functions. The frequency time graph of the chirp signal for n pulses is given in the figures. As you can see in the first figure, the initial frequency of each chirp is constant for regular LFM signal. To send the communication symbols within the radar pulse, different initial frequencies are used for the chirp signal for each symbol. As you can see in the second figure, each pulse is divided into 2, and a chirp with a different initial frequency is used for each segment for ISAC signal. The signal received by the communication receiver is given by first equation. Here, WK represents additive white Gaussian noise. The demodulation of this signal at the receiver is usually carried out using match filtering. In this method, the cross-correlation of the received signal with all possible signature signals is calculated. The result with the highest peak value is accepted as the send symbol. In ISAC application, since the waveform changes randomly according to the transmitted communication symbol during the integration process, this affects both the range and velocity estimation negatively. To enhance receiver performance, phase correction method can be used. In this method, each pass in the IF band is multiplied by a phase correction factor corresponding to the symbol carried by the pass. This process is performed to align the passes that are shifted in frequency due to different communication symbols. Radar signal processing is performed after the phase correction. In this new technique, instead of passing each pass on the radar receiver through the same match filter as in classical method, the radar passes received at the receiver are passed through a match filter which is compatible with the communication signal sent by the transmitter. To achieve this, match filters are used in the radar receiver as many as the number of symbols that can be sent from the transmitter. This avoids the need for phase correction. Match filters can be designed by using these formulas for each communication symbols. The basic functional block scheme is given in this figure for new ISAC radar receiver. Simulations were carried out using MATLAB for monostatic pulse radar case by using the ISAC waveform. First, the detection performance of the radar was examined for phase correction technique. Radar detection performances in the radar receiver when the pulse contain and do not contain the communication symbols are examined to analyze the amount of distortion to the communication symbols. Then the analysis were repeated using the Neve technique, and the performance of the Neve technique was evaluated. The parameters used in the simulations are given in this table. The radar receiver performance when the pulses contain communication symbols is determined by using conventional receiver for the ISAC signal to analyze the amount of distortion due to the communication symbols. As you can see in the range Doppler graph, the conventional receiver detects multiple targets. To enhance receiver performance, we use phase correction method. In this method, each pass in the IF band is multiplied by a phase correction factor corresponding to the symbol carried by the pass. Radar signal processing is performed after the phase correction. As you can see in the range Doppler graph, the receiver performance was improved and false targets are eliminated by this method, but no significant improvement was observed in the speed detection performance. To improve velocity accuracy and enhance receiver performance, the radar pulses received at the receiver are passed through a match filter, which is selected from a match filter bank according to sense communication symbol. As seen in the range Doppler graph, the velocity accuracy of the receiver was significantly improved by this method. To analyze in more detail, the effect of the communication symbol number used in the communication channel on the performance of the radar receiver, the range and velocity of the target detected on the radar receiver were estimated by using various number of symbols. Estimation error was calculated according to the mean square error method. As can be seen in the figures, using the proposed new method, range and velocity estimation is made with higher accuracy regardless of the number of symbols on the radar receiver. We also analyzed performance of the communication receiver. As can be seen in the figure, acceptable error rates can be obtained when SNR is greater than 10 dB. In this study, we analyzed the performance of both the communication function and the radar function in an Isaac system with past LFM modulation. We proposed a match filter bank technique to increase the performance of the radar function. We repeated the performance analysis according to system operating frequency and various number of symbols transmitted in the communication channel. With this proposed method, range and velocity estimation errors caused by the symbols used in the communication channel on the radar receiver were eliminated. Performance of the receiver is independent of the number of communication symbols. We measured the communication performance in terms of symbol error rate for various SNR values. These are the references used in this study. Thank you very much for your attention.
Okay, thank you very much, Miss, for your excellent presentation and also fascinating topic. Now I'd like to invite any question from the audience. If you have any question, just raise your hand and write down the question in chat box. Please, for the participant, if you have any question, don't be hesitant to ask the presenter. Okay, while waiting for the question, I have a question. In your research, you use a lower frequency at 10 gigahertz. It is possible to apply your proposed method for frequency under 10 gigahertz, for example, for S-band radar that has an operating frequency of 3 gigahertz.
Yes, it is possible. Actually, in the paper, we used also high frequency band, for example, 85 gigahertz. And we gave our results for that frequency band. And it could be also used for the lower frequency bands. And the performance is regardless of the frequency band. Yeah, we can use this method.
Okay, so it can be used for all the range frequencies, isn't it? Yeah?
Yes, exactly.
Okay, any question from the participant? Oh yeah, as you mentioned that you proposed an integration between sensing and communication. So is it possible to be applied for autonomous vehicle since it needs sensing or also communication to each vehicle?
Yes, exactly. We choose 85 gigahertz frequency band because of the autonomy radar. You know, that radar operates at approximately 85 gigahertz. Our main concern was autonomy radar, but it could be also applied for the military radars. You know, for the UAV systems, UAV sensors mostly have radars or other electro-optical cameras to increase the situational awareness. And they also have to share their sensor results with each other and also central control center. Because of this topic could be applied for the military radars for lots of purposes.
Okay, it's very interesting research. Any other question from the participant? Okay, if there's no more question, thank you very much, Miss Sevda Sahin, and please give an applause for Miss Sevda Sahin.
Thank you very much.
And then once again, I want to invite Mr. Ahmed Jamil Abdul Kader. Have you joined us in this room? Okay, let's move to the last paper that will be delivered by Miss Tin Sinatra from BRIN. Please, Miss, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Today, I would like to present our study. The title is Investigation of the Rain Scanner Radar Performance for Effectivity Rainfall Estimation in a Co-location Grid Data. And here, our team from BRIN. Motivation of the study. Rainfall varies widely in place and time. Rainfall measurements from a rain gauge can only provide single-point information and limited information about spatial variations in rainfall. An X-band rain scanner radar, or here we call RSR, has been installed in a mountainous region of the Bandung area to observe spatial rainfall conditions. Comparison of the RSR performance with other X-band weather radar has been carried out in several campaigns. The latest campaign is in 2021 using a comparison with this type of weather radar, and the performance shows that RSR can identify the rainfall reflectivity that occur continuously within 3 consecutive days. And the RSR was also able to identify large reflective area caused by the mesoscale convective system, or MCS, during radar campaign in 2017 and in 2021. In this study before, we compared the spatial detection between radar. And here, we investigate the performance of RSR in estimating rainfall within the RSR coverage area. The rain gauge network will be used to obtain information on the actual rainfall in comparison with the RSR measurement. Now about the rain scanner radar. The RSR is a local single polarization X-band based on marine radar for rain monitoring. The RSR has been installed in mountainous region of the Bandung area to observe surrounding rainfall condition. The non-Doppler radar transmits 6 kW of the peak power, resulting in a maximum range of 44 km. The more detailed specification of the RSR is shown in this table. It produces an image of a rainfall map every 2 minutes with a spatial resolution of 120 meters. The RSR separates rain objects from other objects by implementing the cluster map method, which removes all unwanted signals. The rain gauge network was used in this study. The Citarum River Basin Organizations, Balai Besar Wilayah Sungai Citarum, has a rain gauge network for monitoring rainfall along Citarum River. Here the location of the rain gauge, and here the distance between the rain gauge and the radar locations, which is varies from 5 until 28 km. This study utilized the rainfall data from January to December 2021. Implementation of correction method on radar data using rain gauge data is determined by data availability. So due to several technical and management issues, there are empty rainfall data. So we use these 6 gauge stations from 13 available stations operated by BPWS. The method for the rainfall estimation of RSR is first we do the data collection of echo radar and rainfall data by gauge, and then we identification rain event, and then calculation of calibration parameter to calculate the rain intensity. Here the figure, first about the data collection. Here the red asterisk indicated the radar location. The orange triangles indicates the location of the rain gauge, and the red circle is the radar monitoring coverage area. So to minimize the bias between the radar rainfall estimation from RSR and actual rainfall measured by rain gauge, an average reflectivity of 9 grid is used to represent one location of rain gauge. Here the illustration, here a rain gauge. So here we use 9 grids. to represent one location of a rain gauge. And the bias is influenced by several factors such as topography and wind. Identification of rain event. The rainfall data is divided into individual rain events. A rainfall event consists of at least 2 detections of rainfall data within a period of less than 60 minutes. In order to examine the quality of radar detection, we compare the RSR accumulated reflectivity and rain gauge rainfall depth. Here we use the data from Cicalengka and the Cidurian as illustration. Generally, the radar detection pattern can match gauge data. A different pattern occurred during November and December, where the increased rainfall from the rain gauge could not be followed by radar reflectivity. There are several factors influencing this condition, such as hardware limitation of the magnetron lifetime, which is the source to generate power at a certain operation frequency. So, to maintain the quality of the comparison between RSR and the rain gauge, the data is only limited from January until October. Calibration parameter for rainfall estimation. So there are several methods for calculate the rainfall estimation with conventional weather radar based on relationship between radar power output, reflectivity, and rain intensity. And the main object of this paper is to convert DRO into rain intensity. The RSR's received signal is empirically transformed into a dimensionless radar output, or DRO. DRO value is defined and is this equation, where S is the signal output radar, gamma is attenuation correction, and it is a volume correction. So DRO value is defined as an 8-bit conversion of the video signal from the RSR. Because the X-band signal is strongly affected by atmospheric attenuation and the RSR scans with a relatively wide vertical beam, we implement both attenuation and volume correction. Next is calculate ratio between rain gauge and RSR. The calibration method is based on a linear regression between accumulated DRO and the accumulated rainfall depth obtained by each rain gauge per rain event. A linear regression is calculated for each rain gauge by extracting radar data from 9 grids. The calibration parameter is then calculated using the slopes from all 6 gauge locations. This figure depicts the linear regression between the DRO and rainfall depth for 6 gauge Cicalengka, Cidurian, Dago Pakar, Dayakolot, Jatiroke, and Raja Ekek. And here the R-square show a value of more than 0.5, which represents a good correlation between rainfall depth and DRO. Topography location seems affected the RSR detection since Dago Pakar that located in the upper topography have minimum R-squared value compared to other locations farther away from the radar. The slopes from all 6 gauge locations is then used to calculate the calibration parameter, or beta, as a function of range from radar location. So here we calculation beta as a function of range. The exponential function is fit and obtain this model. Beta is a function of range. Based on the result, we have R-square is 0.9. It is indicated that the range on which RSR can be used for rainfall estimation is up to 28 kilometers. However, to improve the quality of the radar detection, It is necessary to add more gauges that are located, especially more than 20 kilometers, where the attenuation and the effect of the large volumes can become larger. After we get the beta, then we calculate the range estimates based on model. Here to calculate the intensity of the rain by RSR. And here the results from the 6 gauge. The figure shows the difference in the percentage of the comparison between RSR, estimated rainfall, and observation. In general, the rainfall estimation tends to underestimate then measure rainfall by gauge. In all locations except Cicalengka, there are cases where the rainfall estimation tends to overestimate rainfall by more than 100% for rainfall events, but in most cases of rainfall events with rainfall depths less than 4 millimeters. The difference between the rainfall measurement by rain gauge and the rainfall estimation by RSR due to ground clutter and the uncertainty of calibration method. As we know that RSR is located in a region with complex topography and surrounded by numerous high buildings in urban area. It produces the ground clutter and can affect the rainfall detection by radar. Using a single gauge to represent a radar pixel area about 360 meters provides the uncertainty of the calibration method. The radar measures rain at certain height, while gauge measures at the surface. So here the conclusion. Analysis of the DRO rainfall estimation of RSR using the collocated 9 grids of rain gauge calculation has been conducted. RSR accumulated reflectivity could respond well with the rain gauge monthly rainfall pattern, although the year-end period gives a different response. From results of the ratio between rain gauge and RSR, it shows that RSR can detect rainfall with different rainfall intensities even for longer distance of up to 28 kilometers. The comparison of rainfall estimation by RSR and rainfall measurements by rain gauge shows that the RSR estimation tends to underestimate compared to the rainfall depth of the gauge. Nevertheless, for light rain condition, RSR estimation tends to be overestimated. Thank you very much for your attention.
Thank you very much for your excellent presentation and interesting topic, since the rainfall session is coming especially in Bandung. So, is there any question from the participant? Please don't hesitate to raise hand or write down. Okay, this is any question from Mr. Cahyo Adiprabowo. Can you please explain further about clutter map method? Please. Yes.
Yeah. Thank you. Can you hear my voice?
Yeah.
Hello. Okay. Thank you for the question. So for the clutter map, we scan. We observe the. We scan the atmosphere in the clear sky. Mean there is no rain event. Well, we scan about 20 until 50 scan, and then we average the signal. So that's for the clutter map. So it's it's the signal when the atmosphere is clear from the rainfall. So when this signal so when there is a rainfall event, so the signal the scan signal from the rainfall event is the subtract with this signal. It's
is it clear, Mr. Cahyo?
Okay, I got the message. Yeah.
Yes, thank you.
Okay,
Okay,
I
thank
get
you
the
very
message. So it's a bit about comparison between the clear sky and the cloudy sky.
Yes.
Okay, thank you very much. Yeah.
Yeah, thank you, Mr. Cahyo. Anybody want to ask to the Miss Tin Sinatra? I have question that as you explained in the presentation that you look at the RSR in the different distance. Is it any effect with different distance to the performance of the RSR?
The different location is for the gauge. The RSR is only one, so it's located in the high building in the Bandung. So the question is,
oh yeah, different range gauge.
Yes,
different land gauge location is affect to the performance, to the estimation, the rainfall estimation, or what the effect?
So the because the RSR is a single operation with the high vertical beam, so the further range from radar, so the higher vertical beam, so it will give more ground clutter and more attenuation. So that's become the uncertainty in this study.
Okay, thank you very much for your explanation. Any other question? Thank you very much, Ms. Tin Sinatra, for your presentation, and please give an applause for Ms. Tin Sinatra.
Thank you.
Once again, I call Mr. Ahmed Jamal Abdul Qadir. Have you joined with us in this room? Based on the information from the committee that Mr. Ahmed Jamil will join with us, but until now he didn't join, and we will waiting for 5 minutes.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology, Indonesia. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policymaking, and societies.
Thank you very much for waiting for us. And Mr. Ahmad Jamil Abdul Kader, have you joined with us? Hello? Hello once again, Mr. Ahmad Jamil Abdul Kadir. The committee informed us that he already joined, but it's hasn't present in this room.
Bu Pauline, he is still trying to join. He is trying to join. The connection, maybe there is some issue with his connection, I think.
Okay, we will wait for a while. Okay, welcome back to the parallel session 5. It seems that Mr. Ahmad Jamil Kadir cannot join with us in this session because maybe he has a problem with connection from Iraq. Okay, with the conclusion of the last presentation, so parallel session 5 come to the end. Before we finish our session, we take a picture, screen capture. Okay. Please open the camera and then I will count 3, 2, 1. The next 3, 2, 1. Okay, I want to express my gratitude to all presenter and all the attendees. Thank you very much for your active participation. I have a great reminder of this conference. Thank you very much.
Recording stopped.
Jurnal Elektronika dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as the OAJ, Google Scholar, Mendeley, and etc. JET is also ranked as Center 2 in Kemenristek Green Accreditation System. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge, and therefore, no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
Recording in
And last
progress.
one is analysis and conclusion. Bandpass filter is an electronic device that allows signal between two specific frequency to pass, but that isolates signal at the other frequency. So in the bandpass filter, we have three components for frequency. There's the low frequency, and the center frequency, and then the high frequency. Microstrip line has conductor above the substrate for the wave path. The substrate and the path has different of the size, also about the thickness. Substrate is the place for microstrip paths and ground plane. So in the substrate, that it has thickness, dielectric constant, and Rostangen. In this figure, we see the ideal bandpass filter and the realization of the bandpass filter. In the ideal bandpass filter, we can see that this have a response of the slope is very sharp, but for the realization it's very difficult for realization response like the ideal bandpass filter. This is a figure of the microstrip. So in the microstrip, we can see microstrip at the substrate. So the substrate on the top layer, we have the patch or microstrip who has a width and length and the thickness. So in the bottom layer from the substrate is a ground plane. This is a basic theory of the microstrip line for calculate about dimension of the microstrip, because in the microstrip line we have two media, that is a substrate, and the second media is air. So we must looking for of the constanta dielectric relative. This is the formula for this. The other side we can use the facility from the ADS, from the software simulation, that is a line calculator. So we can use this formula or this facility from the ADS. So in the line calculator, we can input the impedance, constanta dielectric, width, length, thickness, height, constanta dielectric, and the other ones. Goal of the study is we have a ring frequency 2.31 gigahertz until 2.49 gigahertz. With the frequency center 2.4 gigahertz, and then bandwidth 180 megahertz. I hope the response has S11 less than minus 20 dB, and for the S21 more than better minus 3 dB. Substrate, we use the substrate from the Roger Droid 4350, who has a dielectric constant 3.66. And then the substrate Roger Droid has the thickness is 1.527. In this slide, this is a table 1. This is dimension of the simulation for the patch. And then in the figure 5 is design of the bandpass filter, who will be simulation and realization. This is result of the simulation at 2.4 gigahertz. So in the simulation software, we have a response of S11 is minus 0.77 dB and S21 minus 22.047.
and the bandwidth 3 dB for the simulation is 180 megahertz, with low frequency 2.31 gigahertz and high frequency 2.49 gigahertz. This figure is a realization of the bandpass filter. In the left picture, this is a top layer from the substrate Roger. That is a design of the bandpass filter. That is a patch, the patch. And the figure number 8, it is a bottom layer of the filter. In this bottom layer, with full ground plane. This is a response of the return loss from the simulation and realization. So we got the S11 simulation at minus 22.047 dB, and the S11 realization we got minus 19.34 dB. Also in this figure 7, we comparison about the insertion loss S21. The result of the S21 simulation minus 0.77 dB. And then for the realization, S21 realization is minus 0.65 dB. And the figure 11, this is a distribution of the current. The show with the color. So it is has the red color more large distribution current from the other color. It is we have green and blue color less than from the red color for distribution current. So in the table 2, we can show this is a result of the S21 from simulation and realization. Simulation has at the center frequency 2.4 gigahertz, with the result S21 for 3 dB is minus 0.77, with the bandwidth 180. And then for realization, we got response S21 with minus 0.65, with the bandwidth 170 megahertz. The response of the S11 for minus 3 dB simulation and realization. For simulation, we have for lower frequency 2.29 and the upper frequency 2.50, with the response of the S11 at 2.4 gigahertz center frequency is minus 22.047, and the realization lower frequency from 2.25 until 2.46, with the response S11 for 2.4 frequency, 2.4 gigahertz frequency is minus 19.34 dB. This simulation, design, simulation, and realization, and this research, the author would like to thank for Research Center for Telecommunication at National Research and Innovation Agency, those who have support for this paper and this prototype. The conclusion of this presentation is simulation and realization of the microstep bandpass filter print on the PCB board. That is, we use Roger Durite 4050 at the simulation and realization at the 2.4 gigahertz frequency center. In the simulation result, at the center frequency 2.4 gigahertz is minus 0.77 dB, and the realization is minus 0.65 dB. And then for simulation, we got the bandwidth is 180 megahertz, and also for realization we got 170 megahertz. So there is has different bandwidth is 10 megahertz. This is my presentation. Thank you for your attention. Thank you for your time. The time for you, moderator. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you, Mr. Teguh Raldi, for interesting topic in bandpass filter. And the time is about 5 minutes for question and answer. Okay, maybe in chat room. The first one from Mr. Asani Hafizu. What is the cause of the discrepancy between simulation and experimental result? It is possible to get a more similar result to simulation, perhaps by some modification. It's time for your answer, Mr. Teguh. Discrepancy.
Okay, thank you, Mr. Moderator, and thank you, Mr. Ahsani Hafizu Sali, for your question. I'm trying to answer your question. That's right. In my realization, that is have different result of the response of the bandpass filter, because I'm in this simulation I'm use advanced design system, software design for the microwave. It's possible, or maybe I can say normally, if I have different response of the realization about filter or antenna. So it's in the realization we don't know precision about the constanta dielectric from the substrate. In this paper, I use Roger Dwight 4050. I'm just see at the datasheet, PDF datasheet from the Roger. So I don't know it's a real how many constanta dielectric. Is number one. Number two, I'm realization this bandpass filter in Spectra. Maybe Spectra is the place who I'm realization in Bandung. I don't know what is the condition in the room of the realization, because it's not always use new ferrite for extract my PCB, my design, maybe like that. So it's I think it's will make different from the result of the response this bandpass filter. And also the width of the patch is very small, but the apa sih tukang cetaknya gitu, the cetak cannot make precision. Maybe I think I have designed 7.8 like that maybe, but in the realization in the Spectra, that's 1.1 millimeter. That is will make the different response of the design. Thank you, Mr. Ahsani. So it is technical problem if I'm realization.
Thank you for your answer.
It's enough for you, Mr. Ahsani.
Yes, thank you.
Okay. And for chat room, we have a second question. Your bandpass filter, how many gain you get in your simulation, or your filter design can increase the gain?
Okay, is question from Mr. Rizky Rahmatullah. Thank you, Mr. Rizky Rahmatullah. It is a design about the bandpass filter. So you know, the bandpass filter is a module for make strike of the frequency who pass in at the modules. So I have three parameters. That is low frequency, pass frequency, and high frequency. So the band pass filter who can use to pass frequency from the low until the high frequency. So in the filter that does not have the gain, because the filter just through pass of the frequency what is our design. In this design, I will pass the frequency from 2.31 until 2.49. That is 180 gigahertz from simulasi, but I got only 170 megahertz. Just like that, maybe Mr. Rizky Rahmatullah.
Okay, thank you. Maybe this is not Mr. Rizky Rahmatullah. Okay, and may I have one question for you, Mr. Teguh?
Okay.
And in the graphic of you compare from simulation and measurement, the graphic you compare simulation and measurement. In measurement is like a wavy line, you know, different with simulation that which have a straight line in the your graph. What about this wavy line of this measurement?
Share my screen.
Simulation and measurement.
Simulation and measurement.
Yeah.
About the response of the return loss.
Yeah, response of return loss.
Yes. What your question, please? I'm sorry.
There is a different have like a wavy line on measurement result.
Different response return loss from simulation and realization. Like that?
Yeah.
Yeah. In the simulation, I got minus 22, but in the realization, we only got minus 19, maybe like that, dB. So it is some question from like Mr. Ashani. I'm never get the same response if I'm simulation and realization, because I say we have some factor from for fabrication. This is a situation. It is practical, maybe like that, and maybe one reason plus from Mr. Asani is the in the simulation of the ADS we only use I only use mesh 100 mesh. So if I can use more than mesh for the simulation, maybe this make more than accurate. But my computer cannot do that for the simulation more than 100 mesh for simulation this project.
Okay, maybe next question from participant in the chat room. I have read all. And how about raise hand in participant? Okay, Mr. Tagupaldi is the last presenter of this session, and I would like to say thank you to entire speaker for great presentation. and the audience to their active participation. And for next session, in this room, we have session 6 for electronic material, component, and circuit. And thank you for all for this, the end of the session. Give applause for us. And thank you.
Thank you, Mr. Budi, Mr. Asani, Mas Asif,
Okay, thank you.
and the other.
Thank
Thank
you,
you
Mr.
for
Putu.
this communication and sharing about the knowledge. Thank you very much. Good luck.
Okay, thank you. Yeah.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Welcome to Parallel Session 6 of ICRAMET 2023. My name is Lia Yuliantini from Research Center of Electronic Print. I will guide your presentation as moderator in this session. So today we have 5 presenters. First is Miss Nelviani from National Research and Innovation Agency BRIN. Are you here now, Miss Nelviani?
Yes, I'm present.
Yes. Next is Miss Shafa Mutia from Sumatra Institute of Technology. Have you been here, Miss Shafa?
Yes.
Okay, thank you. Third is Miss Muhimatul Khairo from Universitas Negeri Surabaya. Have you been here, Miss?
Yes, I'm here.
Okay. And fourth is Mr. Erdin Al-Muqaddas from Bandung Institute of Technology. Are you present?
Yes, I'm here.
Okay, thank you. And 5 is Miss Putri Milana from National Research and Innovation Agency. Have you been here, Miss Putri?
I'm here.
Oh, okay, thank you. And before we start our presentation, I would like to remind some notes for all participants in this current session. First, for all presenters in this session, please keep your video on until the session finished. We will have screen capturing session by the end of the presentation or when all participants are present. Second, also please fill out the attendance form during this session. Our co-host will send you the link in the chat room. Third, please have your presentation file ready in order to answer some questions from your slide. Fourth, the time for each presenter is 15 minutes long. Please make sure you are present during your question and answer session. 5, for the participant who would like to ask a question, please use the raise hand function at reaction menu or chat box on your Zoom. Okay, without further ado, I'd like to welcome our first presenter, Ms. Nelviani from BRIN with title Developing a Portable Electrothermal Micro Anti-Lever Readout System. Ms. Nelviani, time is yours.
Assalamualaikum warahmatullahi wabarakatuh, and good day everyone. First of all, I'm Novieni on behalf of my team from Research Center for Photonics BRIN. Would like to present our topic, which is about developing a portable electrothermal microcontroller readout system. And without any further ado, I will jump to the first slide. The background of the research we are conducting is based on the use of microcontrollers, which are currently quite popular, especially in biosensing applications. Therefore, a sensitive and precise system is needed that can read these sensors for use in real-time monitoring systems under various environmental conditions and also easy to use. However, Currently, the available system is a static system, which means we still use the physical oscilloscope and function generator, making it more challenging to use, especially for in situ measurements. Therefore, our research aims is to develop a portable system with an electrothermal microcantilever triple sensor with high sensitivity and also precision. Previously, I would like to explain the microcantilever sensors that we use. In this research, we employ a piezoresistive triple self-sensing cantilever that operates in dynamic mode. The dynamic mode occurs when the cantilever is externally activated, causing it to oscillate at its natural resonance frequency. And the dynamic mode occurs and any alteration in the load or mass of the cantilever leads to a change in this frequency, and the change in frequency is then being measured. We utilize a commercial microcantilever sensor, which have several advantageous characteristics such as cost effectiveness, high sensitivity, and also the ability to self-monitor. And these qualities are important when detecting low mass concentrations of substances, such as dust properties. Now we will jump to the methods of our experiment. Here is the block diagram of our system. This is the frequency resonance detection system for the microcantilever sensor, and we utilize three primary components, which is the here we call it as the monitor or the mini PC, and then this is the analog discovery tool or AD2, and also the self-sensing triple cantilever with the PCB, along with the PCB, which is it has the amplifier and also the low pass filter. And here, the use of the AD2 can aggregate the results of multiple instruments, such as function generator and also oscilloscope, allowing for in situ experiments. And this is the real prototype of our system. This is the mini PC, this is the AD2, and then this is also the microcantilever here. And this is the flow chart of measurement about how we collect our data. And the data collection was carried out within a frequency range of 85.5 kHz until 88 kHz, corresponding to the resonance frequency of the triple cantilever, which is estimated at 86.45 kHz. And the characteristic for high precision in the system is associated with the datasheet for the cantilever resonance frequency. And now I will explain the results of our experiment. This is the graphic user interface or GUI for a resonance frequency sweeper. We call it as the frequency sweeper application. And the application design is structured into three parts, which is the control section, the configuration section, and also the visualization section. And these frequency sweepers are employed to examine the mechanical characteristics of the microcantilever and find variations in resonance frequency brought on by interactions with substances. And the phase difference refers to the time delay between the excitation signal and the response signal of the cantilever, which provides information about the energy dissipation and damping characteristics of the cantilever. And changes in the phase difference can indicate variations in the mechanical properties of the analyte, allowing for detection and characterization of the material. For the first experiment is to characterize our system. We would like to characterize the high precision of our developing system, and there will be two conditions, which is the open systems and also the closed system. In the open system, the microcantilever sensor is stimulated by a water vapor created by a room humidifier, and the vapor exposure time for the microcantilever is shown by the level variation from level 0 until level 3. And according to the graph, Here first the resonance frequency graph. It explains that the resonance frequency shifts weaker as the level change higher, which are caused by an increase in the amount of water vapor sticking to the microcantilever. And also the fast difference for the open system, it also similarly experiences a weaker frequency shift when subjected to prolonged water vapor concentration. Then for the closed system, the water vapor is fed into the microcantilever in a vacuum chamber until it achieves the necessary humidity level, which is at around 45% until 90%. And when the closed system varies from 45 until 90%, the resonance frequency of the microcantilever sensor is shifted dramatically. And meanwhile, the resonance frequency appears to remain constant at humidity at 60% and 75%. It looks like there is the overlap in this humidity level, and it could possibly because water vapor sticking randomly in the surface of the microcantilever. Also, because of our microcantilever is not equipped with a sensing layer that is suitable for trapping water vapor. And then after we characterize our system, now we want to calculate the linearity of our system, both for open and closed system. And according to the calculation, we see that the accuracy degrees here, the R squared, is around 0.9 and 0.8 for open and closed system respectively, which means that the difference in the number of particles attached to the sensor at each increase in concentration level is linear. And the stability of the system phase is assessed by analyzing the phase difference that occurs when sensor undergoes frequency resonance. The detection in both systems produces a phase difference that is often stable. And last, we calculate the Q factor, which represent a resonator's resonance quality and sharpness. And this value is calculated using this equation, which involving the full width at half maximum value, or SWHM. And if we take a look to the open system, this is the Q factor for every level. And the average for the Q factor in the open system is around 251.8, this is so high. And also in the closed system with the Q factor average around 248.67, it is so high for the Q factor. And it means the Q factor in both systems is stable and indicates that there is no major damping that could interfere with detection accuracy. To conclude, based on the results of the experiment conducted, the radar system microcantilever sensor that has been developed can be used to detect water vapor particles with a sufficiently high Q value. And moreover, the system is more portable and provides ease of changing sensor layers to detect various other particles. And for the next research, the fast-locking system method will be employed to track the resonance frequency of the microcantilever. And I think that's the end of my presentation, and thank you for all of your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for your informative presentation. Let's continue to Q&A session. If participants have a question for Ms. Nelvieni, please raise your hand or use chat box on your Zoom for ask the question. Okay, if no question, maybe I have a question for Ms. Nelvieni. In the method, we see there are a block diagram of the system, right? You use some fast filter that is low pass filter. We know that there are many type of pass filter, such as high pass filter or low pass filter. So what the reason you use low pass filter than high pass filter?
Okay, thank you. Miss Lia, for the question. Actually, the low pass filter is came with the microcantilever itself. So the microcantilever that we use here is the commercial one. So it's already being produced by a company. So it came with a pack. It already has the low pass filter and also the amplifier and also the Whetstone bridge and everything. So yeah, that this system we should use that low pass filter to make to filter the signal, which maybe is not maybe could be noise or something. So yeah, I think that's the answer. I think it's still in the mute.
I'm sorry. And how about the error or sensitivity for the system?
The error or the sensitivity, actually, we not like exactly to calculate the error and the sensitivity here, because our need is to see if for the first in the developing system of the readout for microcantilever, we want to focus on by using the system we can get a linear actually the microcantilever itself it's already a sensitive one, so we can see that our measurement is sensitive is by referring to the linearity of the system. So as I already mentioned before that the linearity of the system is quite linear, it means that actually by using this system, we can get also a high sensitivity of detection.
Okay, thank you very much for your clear answer. If there is no question for Ms. Nelviani, maybe we can continue to the second presenter. But before we continue, I see that our presenter and also participant have been in the room. So I would like to ask you for joining our photo session. Please open your camera ready. Okay. 1, 2, 3. Second slide. 1, 2, 3. Okay, thank you for your time, and we can continue for the presentation for Ms. Syafa Mutiah from Sumatra Institute of Technology with title Development of Controllable LED Light Source for Retinomorphic Sensor Measurement Test. Ms. Syafa Mutiah, time belongs to you.
Ladies and gentlemen, distinguished guests and esteemed college, welcome to ICRAMET 2023. Let me introduce myself. My name is Syafa Mutiah from the Sumatra Institute of Technology, who will represent my team to present the result of our research. Also introduce my team, namely Eri Dwi Kurniawan from Research Center for Electronics, National Research and Innovation Agency, David Erickson Simbolon from Sumatra Institute of Technology, and Taufikur Rahman from Research Center for Telecommunication, National Research and Innovation Agency. It is my great honor and privilege to stand before you today as we convene to discuss development of controllable LED light source for retinomorphic sensor measurement tests. The background of our research is derived from the ongoing development of autonomous vehicles by contemporary researchers. The sensor utilized in these autonomous vehicles serve the purpose of detecting object movement. As a result, A retinomorphic sensor has been developed for implementation in autonomous vehicles. In the process of sensor development, a testing device referred to as an LED control has been employed to ascertain the functionality and efficacy of the sensor. The retinomorphic sensor is a type of sensor designed to emulate the function and operational principle of the human retina. The operational principle of this sensor is bifurcated into two aspects: spatial distribution and temporal distribution. Regarding spatial distribution, the sensor can detect substantial changes in the image, specifically in light intensity and wavelength. Concerning temporal distribution, the sensor exhibits the capacity to detect motion changes. As can be seen in the image below, the system shows that this research requires an LED control as a test tool for the development of retinomorphic sensor. The general operational principle of the LED control revolves around its capability to manipulate lighting patterns, brightness adjustment, and LED color control. This functionality is achieved through voltage current regulation and the application of pulse width modulation, or PWM, as an electrical current regulator. The following is flowchart of LED control programming. The declaration of fixed, desired, and output variable is done before performing 10 rotation, which represent 10,000 ohms. Each rotation is equivalent 1,000 ohm or 4,200 steps based on trials. The voltage sensor reads the voltage and converts the ADC value to VNOW, initiating the stepper position and V minimum. The difference between VNOW and minimum V0 is calculated. The potentiometer modulate convert V0 to R0, then to steps with a value of 4.2. The motor moves backward a distance step 0 because V0 and step 0 are negative. The output becomes V minimum. The user enters the desired V1, which is converted to R1, then to step which the formula 4.2 times R. The stepper motor moves, changing the R value of the potentiometer and V of the sensor. The voltage sensor reads V out, and the monitor displays the result. The illustration represents the schematic diagram of the LED control apparatus employing AC power as the voltage source. The substantial voltage is subsequently converted through a voltage converter, namely the XL4015. Furthermore, brightness regulation of the LED is achieved through a microcontroller program to control a stepper motor. This motor, in turn, manipulates a potentiometer to adjust the desired voltage. The following is the result of a series of LED control tools that have been created. The CV, or control voltage potentiometer, on the XL4015 module was replaced using a 3590S-103L potentiometer module. The process of replacing the potentiometer module has succeeded in regulating the voltage. Arduino Uno can receive a current of around 700 mA from the voltage sensor. The following is data on the voltage result during the initial condition of the LED control. The voltage will be set to the lowest condition when the LED control is first turned on. A comparison of the voltage measured under minimal circumstance is shown in table. The digital display voltmeter and the monitor each read different value ranging from -0.15 to 0.41 volt. From the LED control voltage data, the initial condition it is turned on, a graph is obtained. The average value of the voltage read by the voltage sensor is 1.3455 volts. Meanwhile, the voltage read by the digital voltmeter is constant at 1.3 volt, and in the orange paragraph, in orange graph. The following is a common program to input voltage and to rotate the potentiometer. Listen below voltage data when the LED controller is input voltage value 15.0 volt in the form on an LED display. When the user of the LED controller inputs the record voltage value, tabel below display the voltage data. The voltage value used in this experiment was 15 volts. For this voltage to be reached, 14 seconds are required. Accordingly, the stepper motor rotates at a rate of around 1 volt per second. And then conclusion is the LED controller has voltage adjustment capability between 1.2 and 25 volts. However, the highest power the LED can withstand is somewhere between 15 and 16 volt. As a result, 16 volts should be set as the input limit value in the microcontroller program. This is so that the LED does not access voltage, which can cause the LED to overheat. The results show that the error difference between the reading data and monitoring data is very low, unstable. It means that the system has good accuracy and stability. That's all my explanation from the result of our team research. Thank you.
Okay, thank you very much for your insightful presentation. Let's move to Q&A session. If participants have a question, you can raise your hand or maybe can write message in the chat box. No, maybe I have a question for Ms. Shafa. So, may I know the range of wavelength from your LED in the experiment? Ms. Shafa?
Okay, thank you for the question and answer session. It was handed over to my team.
Yeah? I cannot hear your answer. Ms. Shafa?
For the question and answer session, it was handed over to my team.
No, I mean the wavelength. What kind? Maybe for in the visible wavelength from 300 nanometer for 1000 nanometer. What kind of LED that you use?
Sorry, maybe I will have
yeah.
to answer. Okay,
Yeah.
so in this research, we still use the LED with the color of red. So the wavelength of the LED is around 650 nanometer. But in this research, we want to also have a LED controller that can be used in the different LED. So we can set in the different LED, such as the green LED or the other. So we can set the voltage for voltage of the LED, and we can set as our desired value of LED.
Oh, okay. So, you just only use in the visible range, right?
Yes, because this is the application of the retinomorphic is in the visible spectrum. So we do some research in the visible.
Okay, so you don't need some UV or maybe infrared.
I don't think so.
Okay. Okay, thank you for your question, Mr. Eri Dwi Kurniawan. Maybe another question from Mr. Widya Budiawan, please.
I have one short question. Can we change the LED with UV maybe? Is it possible?
I think it is possible because every LED have a different forward voltage and different forward current. If we know the value of the forward voltage and the forward current, we can change every LED, such as the UV or as I say, in the green LED and another LED.
Mr. Widya, how about the answer?
Yeah, it's okay. It's okay. That's all.
Okay. Thank you. Thank you for your question, Mr. Widya, and also the answer for Mr. Eri. Due to time limitation, maybe we can continue to our third presenter, Ms. Muhimatul Khairo from Universitas Negeri Surabaya, with title Lead PB Detection Analysis beside on Multimode Plastic Fiber Optic Sensor. Ms. Muhimatul Khairo, times belongs to you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. I am Muhimatul Khairo. Now, I want to present about our research, the title Lead Detection Analysis based on Multimode Plastic Fiber Optical Sensor. With me, Muhimatul Khairo, and our colleagues from the Indonesia Universitas Negeri Surabaya. This is the main reason of our research. This is about the heavy metal pollution. Heavy metal pollution has still concern in the world, in country of the world, such as America, India, China, even to our country, Indonesia. That heavy metal pollution, has been caused serious health problems like organ damage and even death. Among of the heavy metal, lead is the one component that high gas concentration that found in drinking water. So we use lead as our main object. Until now, lead detection is still using laboratory analysis method like atomic absorption spectrophotometer, fluorescence spectrophotometer, and analytic stripping photometry. However, this method is expensive, use a risk chemical compound, and use long time consuming to get the result. Therefore, we proposed another technology to detect lead in water using optical fiber sensor base. Optical fiber sensor has been used like many variable, especially for physical variable sensing, especially in chemical sensing. And the sensor have a main advantage, such as higher sensitivity, inexpensive, and safe from the chemical risks. Yes, this is a design of our proposed sensor. This device has three main components. The first one is the light source. We use red beam laser as the source. And the second one is the sensing part. The sensing part builds from plastic multi-mode optical fiber that has been stripped 2 cm long in the middle until cladding part. And we assume the cladding part has been replaced with our sample. Yes, the lead solution. And the last part is photodiode. Photodiode is device to detect the propagated beam and amplified before its display in LCD layer. And then we have to prepare our sample. Yeah, the sample is lead solution. The lead solution is based of lead nitrate that has been made using 1.6 gram of lead nitrate and we soak it with distilled water as the solvent. In our study, we use 5 farad of lead concentration. This is a 0.0 ppm, 0.1 ppm, 0.5 ppm, 1.0 ppm, and 1.5 ppm. Yes, this is the result of our research. The research used 2 different optical fiber sensor. The first one is strict optical fiber sensor. As you can see that the lead concentration has inversely correlation with the output voltage. It is because lead is a metal component that have a higher absorption, especially in the red band area. So, the beam that have been received in photodiode has been decreased with the higher concentration of lead. And this study, we have 3 times experiment or measurement. And as you can see that the 3 try obtain 3 different behavior of characteristics. This is because of different mode that have been propagated in the multi-mode optical fiber, or maybe because of different numerical aperture or different incident angle of the beam. Okay, the next one is we use bending optical fiber sensor with radius 4.6 cm. As you can see that the output voltage is lower than the strict optical fiber because in the bending optical fiber has obtained a loss of bending. And same as with the strict optical fiber, it have a 3 different behavior because depend on mode that has been propagated in optical fiber. Next one, we have to calculate some of variable of the sensor characteristics, like a working range, sensitivity, and resolution. As we can see that bending optical fiber have the wider working range and higher sensitivity. It's same as the previous research that say that to increase sensitivity of sensor, we can use a bending optical fiber sensor. Okay, from the research, we can conclude that the output voltage is inversely proportional to least contribution. However, the proportion was not directly linear and depend on the mode of the incident angle of the beam. By the variation optical fiber configuration is a bending and straight. Bending has a wider working area of sensor and higher sensitivity. There is a 1.3 for voltage and 0.9 to 4 voltage per ppm respectively. The result indicated that the optical fiber is compatible with the lead detection application to minimize the impact of heavy metal pollution in water. Yes, this is the end of presentation. If you have any question, I have grateful to open the new discussion together. Thank you very much.
Okay, thank you, Ms. Shafa, for your captivating talk. And let's move to Q&A session. Maybe if participants have a question, you can raise your hand. If no, okay, Mr. Widya, please.
Okay, thank you for the presentation. Can you explain the reason behind why the sensitivity is higher when it's bending than and straight? So what is the reason behind that one? Okay, thank you.
Please, your answer, Ms. Muhimatul Khairo.
Okay, thank you, Mr. Widya, about that question. This is with the calculation that with some calculation about the sensitivity from the data that we have obtained from the research. So the data in the streak and the data and with the bending by fiber optic, we have to compare, and with the calculation we obtain the result of sensitivity, and it's related with the another the previous research that that said that the bending fiber optic have a higher sensitivity of sensor. Yeah, yes, this and the proof is from our calculation in our research. I hope it can answer your question. Can you hear my hello?
Yeah. How?
I just want to confirm what is the expectation with that's the reason why when we bend it give a higher sensitivity. What is the reason behind that?
Okay. Maybe I mentioned that if we while we have the research, the higher concentration of the lead, it's the so the lowers the range of the voltage that we get with the sensor. So the range of the voltage is higher, so the sensitivity we assume will be higher, like that.
Okay, thank you for your answer.
Okay.
Okay, thank you. Maybe I have one question for Miss Muhimmatul Hairo. You use the light source is laser red beam. What you use red beam? Why you didn't use green, blue, or violet maybe?
Yes. We use the red beam because the first reason the laser of the red beam is very cheap maybe than others laser, and the others reason why the red beam, because we have observed about the UV result about the lead, and it's sensitive invisible, and it's in the range 900 until 500, the lead detection. So we assume the red beam will be more sensitive than the other wavelength, but in the future research we will use the another wavelengths.
So lead have very strong absorption in the red region, right?
Yes, yeah.
Okay, thank you very much for your answer, Miss Muhimmatul.
Miss Leah, please unmute the audio.
Okay, I'm sorry. So we can continue to next presenter, Mr. Erdin Almukodas from Bandung Institute of Technology and National Research and Innovation Agency, Republic of Indonesia, with title Enhancing Inverted Perovskite Solar Cell Efficiency with Vanadium Oxide Modified PSS Whole Transport Layer. Mr. Erdin, time is yours.
Warahmatullahi wabarakatuh. Distinguished guests, respected colleagues, and esteemed member of the scientific community, I extend my heartfelt gratitude for this opportunity to present my research at the ICRAMET 2023. The title of my research, Enhance Inverted Perovskite Solar Cells Efficiency with Vanadium Oxide Modified PSS Whole Transport Layers. Organic and inorganic perovskite material have attracted considerable attention for their outstanding optoelectronic properties since their discovery as light absorbing sensitizer in photovoltaic cells. The inverted structure has emerged as a promising design for perovskite solar cell due to its low temperature processing and simplified fabrication compared to mesoporous structure using materials like titanium dioxide, which require high temperature processing. The PIN structure is also studied for its stable condition and minimal hysteresis. The whole transport layer in this structure plays a crucial role in efficiently extraction hole and preventing charge recombination at the interface, making it a pivotal element in the PIN architecture. Understanding and optimizing the whole transport layer are essential for achieving enhanced device performance. PSS is a cost-effective, thermal stable, and flexible organic polymer readily used as a whole transport layer in perovskite solar cells. However, its hygroscopic and acidic nature pose challenge, potentially causing substrate corrosion and perovskite layer decomposition, while inorganic alternatives like copper thiocyanate or nickel oxide offer improved stability. Their lower conductivity limits perovskite solar cell performance. In our study, we introduce an innovative approach to enhance PSS properties. We modify its solution with vanadium oxide using an aqueous ammonia-based process. This form a metal amine complex and subsequent low temperature treatment on FTO or ITO substrate deposit metal oxide within the PSS matrix. The addition of vanadium oxide is expected to raise the work function of PSS, improving hole extraction efficiency and increasing the open circuit voltage. Furthermore, the use of an ammonia-based vanadium oxide solution aims to raise the solution pH value, enhancing the stability of inverted perovskite solar cells. This novel modification approach addresses the limitation of PSS, optimizing its performance as a whole transport layer and contributing to the overall efficiency and stability of inverted perovskite solar cells. The VVB films was created using the spin coating technique in figure during the deposition process to mitigate the inherent hygroscopic properties of the system. This film effectiveness arises from the interaction between oxygen atoms in the metal oxide and hydrogen ion from PSS, forming hydrogen bonds that prevent corrosion on the FTO electrodes due to PSS intrinsic acidity. The addition of vanadium oxide not only reduces hygroscopic properties, but also increases the solution pH value, making it more alkaline. To prepare the PSS or vanadium oxide PSS precursor solution, varying concentration of vanadium oxide 5, 10, 15, and 20 milligram to milliliter were dissolved in ammonia. After homogenization, through stirring and filtration using 0.45 micrometer stirring filter, each vanadium oxide solution was added to the PSS solution in a 2 to 5 volume to volume ratio, followed by overnight stirring 60 degrees Celsius. The resulting solution, denoted as 0, 2, 6, and 8 milligram to milliliter of VPP, represent the concentration of vanadium oxide compared to 1 milliliter PSS. After deposition, the whole transport layer on the substrate, the assembly was transferred into glove box for the deposition MIPBI3 and electrons transfer material, this PC60BM. The devices was furthermore the device was further refined with the deposition of silver electrodes using thermal evaporation, adjusting the thickness to approximately 100 nanometers. The potential enhancement resulting from the addition of vanadium oxide to PSS is evidenced through meticulous UV-vis testing, as shown in Figure A. The result clearly indicate a significant difference in absorption within the 350 to 900 nanometers wavelength range for PSS with vanadium oxide, especially at higher concentration of the vanadium oxide solution. This tradition implies promising outcomes in improving the interaction between the whole transport layer and the perovskite layers, facilitating more efficiency charge transport. Additionally, insight into impact of vanadium oxide are present figure B and C, revealing notable charge in the work function upon introducing vanadium oxide onto the ITO substrate. Specifically, the work function transition from 4.94 electron volt to 5.69 electron volt compared to the PSS layer ITO, which has a work function of 5.04 electron volt. This induced or work function hold significant implication for device performance, allowing enhanced hole extraction from the MIPBI3 layers to the anodes while maintaining the commendable conductivity of PSS. Next, the devices were fabricated on 2.5 to 2.5 centimeter square substrate with an active area 0.1 centimeter square. The box diagram of PV parameters of the inverted perovskite solar cell with different hole transport layer condition shown in figure A to D. Our experimental results show that the power conversion efficiency increases as the concentration of vanadium oxide additive increases, rising from 7.7% to 9.0% when the additive concentration reaches 8 weight to volume. Meanwhile, other parameters such as VOC and fill factor, as shown in figure C and D, show a similar trend, decreasing as the additive concentration increases. The increase in VOC and DSC indicate that the addition of vanadium oxide increases the sun resistance in the PSS conductive layer and enhances the extraction of hole in the device. Therefore, despite the decrease in fill factor, the increase in charge extraction contribute to the overall increase power conversion efficiency. The GV, as shown in the figure, highlight the significant improvement achieved by incorporating vanadium oxide additive into the PSS-based hole transport layer of perovskite solar cells. The vanadium oxide additive notably enhances the open circuit voltage, reaching up to 1.02 volt. Concurrently, the overall efficiency improved from 7.7% to 5.0%. Detailed in the table. A small hysteresis typical of inverted perovskite solar cell is observed in devices with and without the additive, further confirming a positive impact. In evaluating incident photon to current efficiency or IPCE, depicted in figure, the introduction of additional vanadium oxide additive significantly enhances the device responsiveness to light across various wavelengths. The IPCE measurement affirmed the additive role in augmenting the responsiveness of solar cells to incident photons, emphasizing its positive impact on photo-generated charge carrier extraction. This finding collectively underscore the effectiveness of the vanadium oxide additive enhancing the overall performance of inverted perovskite solar cells. Conclusion: the incorporation of this additive into the PSS solution serves as an important modification, acting as a whole transport layer in inverted perovskite solar cells. Compared to device using poor PSS, our investigation have revealed significant performance improvement with the composite whole transport layer. At a concentration of 8 mg to milliliter, this improvement is truly evidenced by the remarkable increase in power conversion efficiency, increasing from 7% to an impressive 90%. In addition, key parameters such as open circuit voltage, short circuit current, and fill factor also show substantial improvement. Our research further underscore the potential of vanadium oxide additive in increasing VOC up to an impressive 1.02 volt, presenting a noteworthy challenge for PSS-based whole transport layer. In addition, the responsiveness of light to current conversion was also improved, indicating the high potential of vanadium oxide additive in PSS to achieve optimal performance in inverted perovskite solar cells. We express our gratitude to ICRAMET 2023 for this valuable opportunity. Especially thank you to the Green Research Assistant Programs and Barista Scholarship for their crucial support. Our sincere appreciation also goes to the Research and Innovation untuk Indonesia Maju programs for funding this research project. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for your insightful presentation, Mr. Erdin. So if you have a participant have a question, please raise your hand. Yeah, Miss Putri Milana, please, your question.
Okay, thank you for Miss Ria. Mr. Erdin, can you explain the effect of incorporation vanadium oxide to the series resistance and the sun resistance value in the IV or GV parameter? And the second, which parameter in GV measurement affect the most by the series and the sun resistance? Thank you, Miss Lia.
Okay. Yes. Please, Mr. Edwin, the answer.
Thank you for acquire, Miss Putri. Allow me to show the slide. The doping of vanadium oxide at the optimal concentration of 8 milliliters has yielded an efficiency of 9%. However, it is notable that at this concentration, there is an observed reduction in open circuit voltage and fill factors compared to other concentration. This phenomenon is to an increase in series resistance, specific doping concentration. Specifically, the optimal concentration of 8 milligram to milliliter, the series resistance experience an elevation resulting in lower voltage and fill factor. Conversely, resistance at this doping concentration measure 1,654 ohm, smaller value milligram at 3,001 millimeters square. This elucidate the efficient suppression current within the device, contributing to enhance stability. Interestingly, despite the resistant higher doping concentration lead to an increase in the conductivity of the whole transport layer. Is attribute to the increased abundance of vanadium oxide on the surface, facilitating more efficient whole transportation. Consequently, this result in enhancement in short current density or GSC and an increase in the electrical power that we convert. So with a good solar cell exhibit this high sun series resistance.
Okay, Miss Putri Milana, how about the answer?
Okay, one more question. So what we expect in the sun resistance? If the sun resistance value is increased, so the performa perovskite solar cell decrease or enhance or increase. What we expect in the sun resistant value in order to the good performance.
Yeah. Okay. In generally, of solar cell can be effectively represented by by using equivalent circuit model source in this figure. Series resistance comes from the internal resistance of the perovskite solar cell caused by factors such as light absorption, interface layer, hole transport layer, electron transport layer, or maybe metal electrodes. On other hands, sun resistance indicate leakage patch for example the active layer, which are characterized by a large number of holes on the surface or recombination effect. This answer.
Okay, I think that's enough, Ms. Pia and Mr. Erde. Thank you.
Okay, thank you for the discussion. Due to limitation of time, we can continue to next presenter, Ms. Putri Milana from BRIN with title Symmetric and Asymmetric Porphyrin as Precipitating Agent for Perovskite Solar Cell. Ms. Putri Milana, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Thank you for the opportunity. My name is Putri Milana from Research Center for Electronics, National Research and Innovation Agency, and I would like to present our research with entitled Symmetric and Asymmetric of Porphyrin as Precipitating Agent for Perovskite Solar Cell. The defect in perovskite structure can affect the carrier recombination process, charge transport process, band alignment, and interfaces, and also defect mobility. On the left side of figure, this is the ideal lattice, and the right side is a defective lattice. The use of pacivator to reduce the defect in perovskite structure has been demonstrated to be an effective approach for enhance the photovoltaic performance and long-term stability of perovskite solar cell. The type of pacivator or pacivating agent for perovskite solar cell are small organic molecule, organic ammonium salts, polymer, and hydrophobic molecule or water repelling. One of the hydrophobic molecules are porphyrin and its derivative that have unique feature or characteristic like strong absorption infrared and Q band, which can effectively absorb solar energy in a wide spectral range. And porphyrin also have 4 meso position and 8 beta position can be easily modified. The photophysical and electrochemical properties of porphyrin also can be fine-tuned in a controllable way, and their outstanding thermal stability and excellent charge transfer properties. Modification to porphyrin compound side chain and a peripheral hydrogen atom can be easily accomplished. The design and the synthesis of various porphyrin have captured significant attention to further enhance photoelectric conversion efficiency. Through retrosynthetic analysis, mesotetraphenylporphyrin or TPP can be deconstructed into 4 pyrrole units and 4 benzaldehyde units. Synthesis of symmetric porphyrin with R is hydrogen group, hence the product turned to mesotetraphenylporphyrin or TPP, while with R is methoxy group, then the product developed into the mesotetramethoxyphenylporphyrin or TMOPP. Synthesis of asymmetric porphyrin using phenyldiferomethan as a precursor mixed with methoxybenzaldehyde. This method formed two asymmetric porphyrin. In example, methoxy-3-phenylporphyrin and bis-methoxy-diphenylporphyrin. Asymmetric porphyrin were synthesized using this method to control the product selectively. From the proton NMR analysis, 5-methoxy-3-phenylporphyrin, bis-methoxy-diphenylporphyrin, and tetramethoxy-phenylporphyrin has 3, 6, and 12 hydrogen atoms at a chemical shift of 4 ppm, respectively, which was not found in TPP. This chemical shift indicates that the methoxy group are connected in the porphyrin ring. The presence of methoxy substituent in the phenyl group significantly impacts the proton environment, the porphyrin ring. The influence of the methoxy group in the porphyrin ring is evident in the proton NMR spectra, where chemical shifts range from -2.8 to -2.6 ppm are observed in this figure. The negative chemical shift in porphyrin due to the anisotropic effects. Photophysical properties of porphyrin. All the porphyrin exhibit the characteristic feature like a prominent short band, which attributed to the electronic transition from ground state to excited state S2, and the less intense Q band, which attributed to electronic transition from ground state to excited state S1. The various mesoposition of substituent did not alter the transition mode of the porphyrin. However, they shift the absorption toward longer wavelength, commonly called a red-shifted. The introduction of one methoxy group connected to the porphyrin molecule, methoxy-3-phenylporphyrin, the absorption spectrum exhibit a subtle shift toward longer wavelength. This phenomenon becomes clearly evident when the 4 methoxy groups are connecting into the porphyrin molecule, forming tetramethoxy-phenylporphyrin. The effect of the methoxy group connected into the porphyrin is also confirmed by emission spectra. This is the emission spectra of porphyrin with the excitation wavelength was 420 nanometer, and the emission spectrum of mesotetramethoxyphenylporphyrin or TMOPP was red-shifted correlate to the TPP from 656 nanometer to 664 nanometer. And the Jablonski diagram shows the electronic state involved in the vertical transition, which when a conjugated molecule is exposed to photon, its electrons are excited from the ground state to the excited state S1 and S2, known as absorption spectra. This is which depict by the blue line. Afterward, this excited electron undergo non-radiative relaxation through vibrational state to reach a lower energy generally S1. An electron in S1 return to the ground state, releasing energy radiative or undergoing fluorescence, which depicted in the green light. The emission spectra of porphyrin are associated with the electronic transition from S1 to the ground state that agree with the Casa rule. Perovskite solar cell performance. The introduction TPP on the perovskite film enhanced the efficiency of perovskite solar cell. The preliminary result of IV measurement shows that the control cell without the TPP has lower efficiency than with TPP. It suggests that TPP can act as protective layer to block the water molecule from interacting with the perovskite structure. Even though the LUMO level of TPP do not suitable for whole transporting layer material to facilitate the charge transport. However, as a pacifier, TPP can fulfill its function. Meanwhile, the HOMO level of TMOPP suitable for whole transporting layer material. The presence of methoxy group attached to porphyrin ring can alter the HOMO-LUMO energy level with respect to the TPP, where it shifts both HOMO and LUMO to the higher energy. Moreover, methoxy group might provide a better intermolecular interaction at the interface between perovskite and the porphyrin layer, thus create a protective layer. Role of porphyrin as pacifier. The presence of water dismantles the perovskite structure by dissolving the methyl ammonium and iodide ion and infiltrating water molecule in the perovskite lattice. Porphyrin are generally compound of high hydrophobicity. As such, the deposition of porphyrin onto the electron transporting layer surface is expected to reduce the well-known hydrophilicity, hence the prohibiting the absorption of water molecule from prior to perovskite damage. Porphyrin suppress the moisture, induce the degradation of the device. So the conclusion in this research are the differences in the side chain and the peripheral substituent in porphyrin govern the distinctness of their photophysical properties, including their energy level. The presence of methoxy group may improve the interaction at the interface between perovskite and porphyrin layer, and TPP can act as a protective layer to block the water molecule. From interacting with
Maybe I
perovskite
have one
structure.
question for Ms. Putri.
And also the
If we see
modification
in
of
the GV curve, maybe we need to improve the fill factor of PV device that use passivating agent. So, what kind of your future work to increase the fill factor and also efficiency of solar cell with passivating agent?
Maybe for the future work, I will use the some of the group, functional group like methoxy group or methyl or carboxyl group in the porphyrin ring. So it can increase the interaction between the perovskite structure and the they can to block the moisture or the water molecule, so they can minimize in order to increase or enhance the performance in perovskite solar cell. I hope that answer your question.
Okay, thank you very much for your clear answer, Ms. Putri. Because we have time limitation, and Ms. Putri Milana is our last presenter. Once again, I would say thank you for all presenter and also participant. Before we close, I will ask you